Hey guys, this is Vishal from Edireka and I welcome you all to this session on AWS pricing. Today I'm going to give you various reasons as to why AWS has the best pricing model when you talk about various cloud service providers. But before we do that, let's quickly take a look at today's agenda first. Firstly, I would be talking about how does one go ahead and choose a proper service. Then I would talk about different pricing fundamentals and pricing models that AWS has to offer to you. We would also discuss different AWS calculators and the free tier of AWS. Finally, I would finish things off with the cost optimization part. I hope this agenda is clear to all of you. So let's not waste any time and get started then. So how does one choose a service? Well, there are quite a few parameters which one needs to consider. As far as the best service providers in the market is concerned, they consider these parameters. Customer friendly. It is very important that a service provider is customer friendly because different businesses have different needs. And if the customer needs are met, then the customer would be happy. And as far as the service provider is concerned, that is what the aim is. If you talk about Amazon, it has the best customer service. And Amazon proudly claims that if you've ever used one of their services, you'd know that we are the best service providers in the market. Next, we have transparency. Now, it is very important that a service provider is transparent. Now, what do I mean by this? What happens is most of the times people are forced to pay money upfront and then they're given access to the services. This does not give them any time or have any kind of demo with the services that are provided by the service provider. This is where AWS is different. What it does is it offers you free tier. Now, what this free tier does is it lets you use all of its services for free and that too for 1 year. So you have sufficient demo or access to the services which AWS has to offer to you. And then you can take a call whether you want to go ahead and pay for these services or not. Pocket friendly. AWS is highly pocket friendly. Why am I saying this? Say for example, you have to go ahead and buy a server. Now AWS lets you have a server for 1 month at a meager price of $5 only. And this is highly affordable. So these are few of the important points which people need to consider when they go ahead and pick a service. And when you talk about AWS, it meets all of these needs. So let us move further and try to understand the different pricing fundamentals which AWS has. Now AWS considers these three fundamentals, that is compute, storage, and data transfer. If you talk about compute, what AWS does is it charges you on hourly basis. That is, you can use their compute and their processing services at a very less price, and also you'd pay only for those resources which you've used. And again, when you talk about time constraint, if you're using those services only for 1 hour, you'd be paying only for 1 hour. Next, we have storage. What AWS does is it charges you per gigabyte. That is, even if you use very less space, you'd be paying only for that space. And since it is almost as less as 1 GB, that is, you have to pay only for 1 GB, what this does is you don't have to worry about scaling because if you're using more resources, you'd be paying accordingly. So yes, when you talk about storage, this is a very important point and AWS has it covered. Next, we have data transfer. Now, when you talk about data transfer, again, AWS charges you per gigabyte and it charges you only for the data that goes out. So yes, this again is an important point. And based on all these points, what AWS has done is it has gone ahead and it has built various pricing models. So let us move further and take a look at those pricing models one by one. Now, AWS has these three pricing models, that is pay less as you get more, pay as you go, and save when you reserve. Let's first talk about pay as you go. As I've already mentioned, AWS has a very flexible pricing model. Now, what do I mean by this? AWS charges you on hourly basis, plus it charges you only for the compute capacity and the resources which you are using. So if you need a particular resource for 1 hour and you need n number of or n amount of compute capacity, you'd be paying only for that thing. Say for example, your requirement is 40 GB for first month, but what happens is you end up only using 10 GB. Now in this case, your 30 GB of space is wasted, and this is when you pay upfront. But if you're paying on hourly basis and only for the resources which you're using, you're actually saving up all the cost which you would otherwise pay. Secondly, we have something called as pay less as you get more. Yes, more the services you use as far as AWS is concerned, it charges you fairly less. You have a chance of saving up to 70% of your total cost, and that is a very nice feature to have. You also have something called as save when you reserve. Now, if you know how much resources and the compute capacity that you're going to use in near future, what you can do is you can go ahead and reserve these services in advance. Now, in that case, AWS charges you fairly less compared to the other models. So let us go ahead and take a look at these one by one. Firstly, we have no upfront costs. Now, what this means is you can go ahead and reserve your resources and your services in advance, but you're not paying anything. But what happens here is you're paying an amount which is lesser than the previous two mentioned models, that is pay as you go and pay less as you use more. But this thing is still costlier compared to the other subtypes of this model, that is partial upfront cost and full upfront cost. Now, when you talk about partial upfront cost, you are paying a partial lump sum amount which is less than the total amount, and you are reserving all your instances and all those things. But this is comparatively affordable when you compare it with no upfront costs. It is, however, costlier than the last one, that is full upfront payment or costs. In the last point, that is full upfront costs, what you do is you decide, okay, these are the amount of resources which I'm going to use, and this is the compute capacity which I need, and accordingly you book all those resources and you make an upfront payment. Now, since you're making an upfront payment, this is the most affordable of all the pricing models that are there. But for this, you need to be assured that these are the minimum resources which I'm going to use, and if required, I will have to scale up but not scale down. So this is about different pricing models as far as AWS is concerned. So let us move further and try to understand the next point. Now, how does one go ahead and calculate the savings which one makes? Well, AWS has provided you with an AWS calculator. Now, what does this AWS calculator do? It lets you calculate your monthly expenses. That is the services which you've used and all those things. Hence, you can keep a track of all the money which you're supposed to invest. Apart from that, it also provides you with various templates which lets you appraise your complete solution. There's one more variant as far as the calculator is concerned. It is called as TCO, that is total cost of ownership. Now, it is little different than the normal AWS calculator. What it does is it basically lets you calculate or compare one service's price with the other service. It also lets you compare the infrastructure solution which AWS has to offer to you, and this might vary from business to business. So when you talk about the total cost of ownership for which you might invest, this is the calculator which you should go for. Now, when you talk about the AWS calculator or the TCO calculator, I would be giving you a small demo, or once I walk you through the AWS website, I would be telling you as in how do these calculators work. I hope this point is clear to all of you. So let's move further and try to understand the next point. Now, AWS also has to offer you a free tier, which I mentioned in the past. So let us move ahead and try to understand what this is exactly. Now, as I've mentioned, AWS has various services to provide to you, and those services will have the subtypes as well. So all these services are available to you for free for 1 year. And this is the access which AWS provides to you. Say, for example, you have a service called as Amazon Elastic Cloud Compute. This is one of the most popular services as far as AWS is concerned. And when you talk about its access, what AWS does is it lets you access 750 hours of this service on any of your OSs, whether it's your Linux, whether it's your Windows, you can have access to this thing. And when it comes to using this service, 750 hours is sufficient if you're trying to get started with AWS. Then you have other services like Elastic Load Balancer, you have Elastic Block Storage, you have Amazon Web Services. And based on the usage, they have different capacities which are made available to you for free. Now, AWS won't charge you for any of these things. And when you need a demo, I feel these resources are more than enough. Again, once I switch into the website, I would be talking about the free tier as well. So let's do one thing. Let's actually go ahead and first take a look at these resources or these services one by one. That is, let's try to understand what free tier is and what these calculators are with the help of the AWS website. So what I'm going to do is I'm just going to go ahead and switch into the AWS website. So yeah, what I've done is I've actually gone ahead and I've opened AWS free tier. Now this is what it looks like. Basically, these are all the resources which it has to offer. But before we do that, what you need to understand is you need to create an account here. To do that, you'll have to go ahead and enter your debit card or credit card details. Now, AWS won't charge you as long as you use all these services in the limits which AWS has mentioned. And to be honest, those are fairly large limits. So you won't be exceeding that if you're just using or having a demo of these services. So how does one do that? One goes ahead and gives in their credit card or their debit card details. AWS will charge you $1, that is 1 USD, for some verification purpose. And within 10 minutes, that amount would be refunded back into your account again. So this is only for the verification purpose. And after that, if you overuse the resources, then AWS would charge you. So what you have to do is you have to just go ahead and create an account here. Now these are the free tier services which AWS has to provide. It has something called as Elastic Cloud Compute, that is EC2. And as I've mentioned, it has 750 hours of it. You have Amazon QuickSight, which is used for analytics basically, and it is available in 1 GB of your spice capacity. Now, I won't get into the details of what spice capacity and all those things are. You have something called as Amazon RDS, which is for storage. And again, it provides you with a capacity of 750 hours per month, which is again very high. You have Amazon S3, you have Amazon Lambda. Now, these are fairly popular services. And as far as the space or the capacity which is mentioned here, it is more than enough or sufficient. AWS also provides you with various tutorials that will help you get started here. So if this is your concern, I would suggest that you just go ahead and log into AWS's website, have an account there, and you're good to go. As far as once you sign in, how it looks, I'll show you that as well. You can just go ahead and log in. Now I have an account already on AWS. For some reason, my internet is very slow today. There you go, it takes eternity. Yes, so once you log in, this is how it looks like. You can go ahead and you can actually create your own instances and all those things. Say for example, you have something called as EC2. You can go ahead and you can specify all the details, as in this will show you how many instances are running and all those things. For now, there's nothing that is running here, so there's 0 instances that are running. So you can actually go ahead and create your instances and do all those things. You can launch your instances, say for example, and you get to select as in what OS and what all do you need to do for it. So yes, but then this is not the discussion for today. So I'll just go ahead and skip this part and I will switch to something called as the calculator. As far as the free tier is concerned, these are all the services that are available to you and you can actually go ahead and use those. Now next we have something called as our simple monthly calculator or AWS calculator. Now it gives you your monthly estimate, as in for all the services which you've used. All you have to do is you have to go ahead and add the details, as in what is the description, how many instances are you using, its usage, and the type of the instance. Now the T1 and all those, the micro instances and all those, these are the details that have been covered in a session called as AWS tutorial by Edureka. If you want to have details about those, you can actually go ahead and view that video as well. Now this is where you talk about the billing option, whether it's on demand and all those things. You're free to go ahead and choose a plan for you. As you can see, it's visible here. And once you do that, once you've filled in all these details, your storage, your compute capacities, your elastic IPs and all those things, you finally need to come here and you just need to say that there's an option here which actually lets you submit all these values. And once you do that, you'll have the final result, as in, okay, this is your usage till time and this is the predicted usage and all those things. Then you have something called as your TCO. Now this is more global or more general kind of an application. Now this is something that deals with your interim expenses and all those things. This is for the overall expenses, as in the total cost of ownership. You can select the currency here, as in you have an option of paying in different currencies. Since it's a global leader, you have options to pay in different currencies as well. Say for example, you're somewhere in India, you would be paying in rupees and you can select that option here as well. Apart from that, what is the environment which you need to compare it against? Because yes, as I mentioned, that you can compare different architectures, so you can go ahead and select that as well. You have various other features. Say for example, you can go ahead and put in the details for the servers, whether those are physical servers, virtual servers and all that. Your storage. Now there are storage types here. Say for example, you have SAN, you have NAS, you have object. You just need to fill in these things and then you need to calculate your TCO as well, and you'll have the total cost of ownership too. So these are different calculators, and this is how the free tier as far as AWS is concerned works. So you're actually free to go ahead and explore these things because it is available to you freely, and you can just have access to this and get the know-how as in how AWS works. I hope this is clear to all of you. So let's move further and continue with our discussion as far as the pricing video is concerned. Now that we've understood what the AWS free tier is, let us move further and consider this final point of discussion, that is cost optimization. Now this is a very important point. As I've already mentioned that money is very important when you talk about businesses. It is also very important that you are able to optimize all the money that you are investing in various projects. Now, this is where AWS is very good because it helps you optimize your cost a lot. Yes, it has great pricing models, but apart from that, it also lets you use those wisely so you can optimize your cost. Let us take a look at these points one by one. Right size your services. Now, as I've mentioned, it is easier to upscale, but it is not easy to downscale. So it is always wise to start with lesser resources and lesser compute capacity. So this is where right sizing becomes very important. And AWS lets you do that. Since I've mentioned that it has highly flexible pricing model, you can actually go ahead and choose minimum resources, start with small, and then upscale according to your needs. We also have something called as reservation benefits, which I've again discussed in the past. You can go ahead and choose the models which actually meet your requirements, and you can actually go ahead and reserve few of the resources upfront, which you're very sure about. And yes, you end up paying less again. Elasticity benefits. Now, what AWS does is it provides you with various tools. It also provides you with something called as scheduler. Now, these time schedulers, what they do is they let you switch off and switch on your various resources that might fluctuate when you talk about their usages. Say, for example, you have services like EC2, RDS. Now, these are instance based services. And when you talk about their usage, that might not be constant throughout the various hours of the day. So you can decide to switch off and switch on these resources so that they're used optimally, and you end up paying only for the hours for which you've used those services. So this is where time schedulers do come into picture. And this is where AWS has great elasticity or great flexibility. Finally, in this list, we have something called as track and manage services. Now, AWS provides you with various tools and softwares that actually go ahead and let you keep track of all the real-time usage and measurements that you're concerned with. Now, what this does is this actually helps you optimize your usage. How? Because there are tools that let you build real-time dashboards and all those things. Now, since you have those, you can analyze all the traffic, all the data, and all the resources which you're using. And thus you can cut down on a lot of cost, or you can just go ahead and optimize a lot of money and cost that you're investing in your projects. So these are the points that are very important when you consider cost optimization. And this was probably the last point when you talk about our today's session, that is AWS pricing. So if you're concerned about going ahead and picking a proper cloud service provider, I would say that choose AWS, and it would definitely ensure that you sleep with a lot of cost optimized. I hope you had something new to learn from this session. As far as this session goes, this is the end of it. Thank you. Bye bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
Hey guys, I am Vishal from Edureka, and I welcome you all to yet another session on AWS. In today's session, we are going to go ahead and understand what is AWS Cloud Computing Architecture. But before we do that, let's start by taking a look at today's agenda first. First and foremost, I would talk about what cloud is and what AWS is. Next, we would understand the need to move to cloud. We would also talk about different design principles. And then finally, I would finish things off with a use case and also a demo where we would be building an application that would be covering most of these design principles. So let's not waste any time and quickly jump into the first topic of discussion, that is cloud and AWS. So what exactly is this cloud? Now, if you go by the definition, this is what it is. It is a huge space online, collection of servers, and finally their orchestration. If you consider a scenario that existed before cloud came into picture, you'd understand that back then you had to actually go ahead and buy your own servers, maintain them, monitor them, and take care of everything else that was needed apart from focusing on your business. So this was a huge task. Now, this is where cloud came into picture. It simplified most of your responsibilities. Now, you can actually go ahead and rent these servers or various other services in the form of pay as you go model. That means you'd be paying only for the services that you use, and your cloud service provider would take care of all the other things like monitoring and maintaining your applications. All you have to do is just focus on your business. So, this is what cloud is. It is a new approach towards cloud computing where all these services are orchestrated together and a solution is given to you in the form of service. So what exactly is this cloud service? Now, what different cloud service providers do is they provide you either an infrastructure or a platform or a complete software in the form of service. To give you an example, we use Gmail. So what we do is we just go ahead and type particular mail and send it to the person. Now, how is the mail delivered to that person? Where is it stored? Whether the security is something that you need to worry. Well, all these things are taken care by your vendor. All you do is you just go ahead, type a mail and send it, and it gets delivered. So here the complete software is given to you in the form of service, and your provider takes care of everything. Another example is your Google app engine, right? I mean, it is more of a platform where you can actually put your applications or build new ones, right? So here a platform is given to you where you can actually go ahead and put your data, right? Or have your own applications. Now, these kind of platforms are given to you in the form of service. And this approach is called as platform as a service. Another example is AWS, which is again a complete platform which is offered to you where you can actually go ahead and host your applications. Now, these kind of services, whether it's your software, whether it's your platform or your infrastructure, when they are provided to you for computing, these services are called as cloud services. And that is what different cloud service providers do. They provide you with these services. Talking about cloud providers, if you have to take one of the best cloud service providers in the market into consideration, you have to call it AWS, that is Amazon Web Services. Now, it is the leading cloud service provider in the market and has the highest market share, and it provides you with more than 70 services to use. If you talk about these services, they are divided under different domains like your computation, security, database, migration, compliance, and a number of other services. So yeah, if you do want to go ahead and understand what AWS is in detail, I would suggest that you go ahead and refer to the other YouTube videos that Edureka has to offer to you. You can visit our YouTube channel, just type Edureka on YouTube and you'd be redirected to the channel. There you search for AWS series and you have more than 50 videos that talk about AWS in detail, and each of this service is talked in depth. So you would have a clear understanding of all these things. The fact that you people are here on this video and trying to understand what AWS cloud computing architecture is, want to believe that you already know what AWS is. And I would like to keep it to the surface and just tell you that it is one of the leading cloud service providers. It provides you in services in various other regions in the world or n number of regions that are there in the world. And there are more than 70 services that it has to offer to you. Having said that, let us move further and try to understand what are the reasons one should move to cloud or AWS in particular. Now, if you ask me about certain reasons, I would say the sole reason why people move to cloud is cost optimization. Simply just moving your application from your existing infrastructure to cloud has helped quite a few people to save a lot of money. So yeah, just moving your architecture or infrastructure from one place to the other or to the cloud would help you cut down on a lot of costs. How that we would discuss with time, but yeah, that is one possibility. And that is why these cloud platforms are so popular, and AWS in particular, because the pricing models it has are simply awesome. So what are the other reasons that you need to consider? Well, assets have become programmable resources. Now, what do I mean by this? As I've given you an example, back then you had to buy your stack of servers, you have to maintain that, you had to monitor that, right? So that has changed with time. Nowadays, what these cloud service providers do is they provide you with a number of services. As I mentioned about AWS, it has more than 70 services, right? So you can think of these services as components which you can pick and use to meet your needs, and only for the time duration you want to use it. So yeah, your assets have actually become or converted into any kind of resource. It's just like using electricity. Say for example, when you have electricity at your place, what you do is you just press the button and probably your light gets switched on, your television set gets switched on, right? So you're not concerned about doing anything. All you do is you just pay for the electricity that you're using. Same is with these cloud services. All your assets are rented to you in the form of services, and you can think of them as programmable resources all you have to do is put your applications or your code there, and the service providers, they take care of everything. Availability is another important point, because if you're based in USA, you might want to have your infrastructure in USA. But suppose there are certain constraints and because of which you cannot do it, then it would be very inconvenient for you. This is where cloud comes into picture. If you talk about AWS, it has more than 50 regions across the globe, and you can choose the region that is closest to you. So that way you can get rid of all the latency that is there. And apart from that, if you want to set a business at a location that is strategically somewhere else, you can move your data to that location as well, and you can operate from that particular region as well. So if you talk about global availability and reach, well, AWS or most of the cloud platforms will take care of it. If you talk about AWS in particular, it does it to a greater effect or a much better effect. High level managed services. Now, when you talk about AWS, it's not just computation. There are quite a few other services. I just mentioned that there are somewhere around 8 domains. And if I'm not wrong, these domains are also growing day by day. Whether you talk about machine learning, data warehousing, or whatever those things are, everything can be taken care of here. Not just machine learning and all those things. If you want to use customized or ready to use applications, those are available. If you want to just host a simple website, that can be done. So no matter what kind of requirement you have, almost everything is taken care of when you talk about a cloud platform. Built-in security. Now this has always been a concern. If you talk about any cloud service provider, back then people always doubted whether these platforms were secured or not. When I say back then, I'm talking about a scenario that existed somewhere around 5 years back or maybe 10 years back. People did not trust these cloud platforms. Why? Because moving your data to cloud seemed riskier, because you were putting your data on a resource or at a place which you thought might not be safe. And back then you had outages which did make this decision a little risky. But nowadays, if you talk about cloud service providers like AWS, they have so many compliance programs and so many security principles that ensure security at every step. And that is one of the major reasons why these platforms are more secure, and it is easier to move your data because you can trust these resources a lot these days. So these are some of the reasons why you should go ahead and move to cloud. Since we talked about the reasons, let's now try to understand, if you do have to go ahead and move your application or build a new architecture or application using a cloud platform, what are the points that you need to consider? Well, we would be considering these design patterns or principles for that. First and foremost, we would be talking about scalability, which is very important. Now, what is scalability? If you ask me, I would say it is the ability to scale in a linear manner, support linear load balancing, and ability to scale both horizontally and vertically. Let's try to understand these points a little more. When I say I want to scale in a linear manner and support linear load balancing, I'm referring to the fact that, first of all, let me just talk about scalability a little more. There might be people who do not know what scalability is. For them, scalability is nothing but the ease with which you can actually expand your architecture to meet the growing business demands or needs. Suppose you have a website and you are hosting or you are kind of maintaining, say, 1 million users or corresponding or servicing 1 million users. Suppose this base grows, your infrastructure will also have to grow, right? So the ability to grow accordingly is called as scalability. So what scalability is in true sense is the ability to scale linearly. That means, yes, if I have a number of customers which need to be serviced, that does not mean that I just need to increase the space that I'm using. I should also be able to handle the load. That means I should be able to balance the load. If I'm using distributed applications, I should be able to distribute my load properly, and I should be able to correspond and process the request in the same time that I used to do in the past as well. So this is in true sense called as scalability, where you can scale in linear manner and also balance the load that you're dealing with. And again, you should have a strong ability to scale horizontally and vertically. Let's try to understand what vertical and horizontal scalability exactly is. First, I would talk about vertical scalability. Now, it takes place when there is an increase in the specification of an individual resource. Suppose I have a server, and in that server, I actually need to go ahead and increase probably the space that is there. So yes, I would be scaling in a vertical direction because it is a single resource I'm talking about. I'm not distributing my so-called resource. I'm just scaling it in an upward manner. can you do it by using your AWS? Well, yes, you can. And how do you do it? Well, first and foremost, what you can do is you can just go ahead and stop the existing instance that you're using, and you can resize it to a more suited type. As we move into the demo part, I would be talking about this point a little more, and even during the course of explanation of further points, we would be understanding this. So do not worry, we would get there. But this is what you do. You can stop your existing instance and switch to a more suited one. This might not be convenient always because architectures are not that simple and you cannot always just stop an existing instance and move to a suited one. In most of the cases you can, but not always. In certain cases, there are exceptions. So, yep, even though it is easy to do, it is not always advisable that you scale vertically in almost every situation. For certain situations, horizontal scaling is also preferred. Let's try to understand what that is. Now, when you talk about horizontal scaling, it is the ability to scale through an increase in the number of resources. Here, the example is to add more hard drives to a storage array. Now, if I have a particular storage array, I need to have more hard drives. Now I'm scaling horizontally here. Back then I was talking about a single server, but that is not the case right now. I'm talking about a complete array and I need to add more hard drives here. So I actually need to scale horizontally. But when you scale horizontally, you need to consider quite a few other points. Here, the state of your application is also important. So when you talk about the state, you have to consider following points as well. Stateless applications. Now, these are easy to scale. When I say stateless applications, I'm talking about applications which do not depend on previous sessions or future sessions. That means I have an application, suppose, and I have to give it certain input. That input would always generate the same output in every possible case or every possible situation. So that means no matter when or from where I give the input, the output is same. So it does not depend on any state whatsoever. The output is always same. So scaling such applications becomes easier horizontally. But there are situations where you're dealing with stateless components as well, or components where the state does matter. In certain situations, you have your websites, right, where you're using a particular browser and you are visiting a particular website. Now, certain cookies are stored, right? So when you have these cookies, again, you can scale horizontally. Why? Because the state is stored in the form of cookies and you can scale the architecture. So even in stateless components, scaling is possible. But if you're talking about stateful components where your states are of utmost importance, you cannot just go ahead and scale with that ease. It is possible in this scenario as well, but it is almost impossible in most of the cases because say for example, if you talk about your databases, right? You cannot deal without the state because your databases will have a particular state. So if you have to scale, it becomes difficult, right? So what do? You can have a multiple nodular structure where you can actually go ahead and have multiple nodes, and each of these nodes can hold all the data that is related to a particular state and you can scale accordingly. So that is one way of dealing with it. The other way is this thing, distributed processing. You can actually distribute your architecture in such a manner that again, similar components, they stay at the same node, and you can distribute your architecture in such a way that you can let it scale. Now, when you talk about an architecture, there would be certain components which are stateless and certain would be stateful. So if you distribute your load accordingly, scaling up at least the stateless applications becomes easier, and stateful can be dealt with. If possible, those can also be scaled. If not, some other ways can be used to handle that, and your damage becomes minimal as possible. So yeah, when you talk about scalability, these are the factors that you need to consider when you are building an application or having an architecture. Basically, you have to consider whether scalability is possible, how do you want to scale, and you have to consider all these factors. Now if you talk about Amazon Web Services, that is how it is different. It gives you instant scalability. If you talk about storage as well, there is something called as S3 that gives you scalability in minutes, even less than that. So you need to add extra space, just select it, you can expand the way you want to, and again you'd be charged very less, only for the services you use and only for the time duration you use. There are other services there as well which deal with archival data as well. Suppose the data that is not very important to you, here you can have multiple storages, and the only problem here is it is cheaper but it is slower. So if you talk about different services, there are different ways in which you can scale. If you talk about AWS, and if you're concerned about scalability, AWS will definitely take care of it. So our next point of discussion is disposable resources instead of fixed servers. Now, what do I mean by this particular point? We've actually discussed this point in the previous slides, but I would still like to throw some light on it. What happened back then was, when you talk about the situation when cloud came into existence, we had to deal with fixed servers or traditional approach of architecture. So you had to work with fixed resources, and that led to problem. One, scalability wasn't possible. We just discussed what are the factors that you need to consider. And again, back then scalability was a huge task, because even if it is possible to scale considering the previous factors which we discussed, you had to consider quite a few other points, like, do you need any upgrades? How do you scale up? Do you need to add more hardware? And you had to consider so many things. You had to upgrade and update all those things. So instead, what people thought was, let's predefine an architecture and then use it. So they actually eliminated the thought of scalability. They just had an infrastructure that they thought would survive or last for maybe certain amount of years. That meant wastage of resources and improper utilization of resources. Upfront costs, I just discussed this point. That is, they predefined their requirement and paid accordingly, even if it went underutilized. And that would mean that you ended up paying a lot more than you actually should have paid for. Hard coding IP addresses. Yes, this was another drawback with your so-called fixed servers. And finally, configuration drift. Now, this again is an important point. As we all know that softwares, they upgrade constantly, right? That means if you talk about your Windows operating system, you'd be getting a notification every now and then saying that go ahead and update your operating system, right? So there are certain updates, certain security updates, your so-called antivirus has expired, or if you're using a mobile phone, we all know that your apps constantly get upgraded. So if you talk about these upgradation, if you are using particular applications on cloud, if you are using particular applications on cloud, now upgrading to newer versions becomes easier. Back then it wasn't, because you had to worry about a lot of things. You had to personally go ahead and upgrade all these things. Plus, since you had a fixed architecture, switching to new softwares or applications was much more difficult than what it is these days. So if you talk about cloud services, nowadays you treat services more as disposable resources. That means use them to meet your needs that are here right now. Now, one example is you can instantiate your compute resources. Now, what cloud platforms do is, again, take into consideration AWS, you have something called as Elastic Cloud Compute, which is nothing but think of it as a temporary server machine which you can use to meet your needs. And if you need to upgrade to a better version, you just go ahead and switch to a more advanced one. You can create a snapshot and you can just go ahead and use that particular instance instead of the one which you're using right now. So it is very easy when you talk about these cloud platforms. Infrastructure as a code. Now this is even better. You have something called as Elastic Beanstalk, where you just move your data and stop worrying about anything else, because you have ready to use templates where you just put your code and everything is taken care of. Another important factor that you need to consider these days is automation. Now, when you talk about automation, if you talk about any cloud service platform, what they do is they let you have automations for various services. That means, as I mentioned, you do not have to worry about monitoring your business or your applications rather, and you can focus on the business end. So that is what these platforms let you do. They let you have automation in a number of ways. Let's try to understand some of the applications and what can they do for you. Now you have something called as Elastic Beanstalk. I just mentioned that you can just move your code and start having your application there, right? Now, Elastic Beanstalk is nothing but platform as a service. If you talk about other AWS services, most of them are infrastructure as a service, where a basic infrastructure is given to you. Now, if you talk about Elastic Beanstalk, it is platform as a service. That means a complete platform is provided to you. There would be certain predefined templates, just like if you do programming in a particular language, you use libraries, right? Now, what do these libraries do? They have ready to use codes and functions, right? So that is what Elastic Beanstalk is. When you talk about building applications, you have ready to use templates. Like suppose you want to have an application in Java, a predefined environment would be created for you. All you have to do is move your code to Elastic Beanstalk and your application is ready to use. So yes, when you talk about automation, it happens to a better and a larger scale with Elastic Beanstalk. Next, you have something called as EC2 auto recovery. Here you can actually recover the data. You can store your instances. As I've just mentioned, suppose you use EC2, which is again a compute service, that is Elastic Cloud Compute. You can use a ROS server. You can put your softwares, you can put your libraries, and you can run programs, have applications built there, right? Now, there is a particular state where you feel that you need to switch to some other instance. So in that case, you can take snapshots of your existing instance. There is something called as AMI. Now, I won't get into the details of it, but that lets you have snapshot. That means a copy of your so-called instance, and you can upgrade to a newer one with a quicker ability or in a faster manner. So when you talk about recovering your data from one instance to other, it is a job of minutes rather, or even seconds to be honest. AWS auto scaling. Yes, you have services like CloudWatch, which take care of quite a few things and even auto scaling. Now, what happens here is, suppose I'm using a particular architecture or application, and if I want to scale, I can actually go ahead and set alarms or certain limits. And if the limits get exceeded, AWS is smart enough to auto scale your application according your needs. So if you talk about automation, it is automation in true sense. You just set it the way you want to, and everything is taken care by AWS. AWS CloudWatch. As I've just mentioned, as the name suggests, it's a cloud watch. It keeps a watch on your applications. You can set alarms and you can do quite a few other things. You can keep a track of logs, events, and so many other things. So when you are going ahead and having an application on any cloud platform, these are the points that you need to have an understanding of. You need to understand how your business works and how do I need to scale or how do I need to grow. So accordingly, you can actually go ahead and set your automation policies or use the services that actually meet your needs. Loose coupling. Now, this is another important point as well. If you talk about cloud platforms, the first thing they provide you with is integrations. That means you can move your existing applications. Once you move to cloud, you can build a completely new application, or you can switch or integrate with an application that is completely new to you. Quite a few people have actually gone ahead and switched to quite a few services that are there on cloud, and they've saved a lot of money. And how does this switching and integrating become so easy? It is the nature in which these cloud services work. Now, the applications that are there quite loosely coupled. Now, what do I mean by loosely coupled? That means these applications, even though they form a cluster, they are very loosely bonded to each other. You can pick one service, edit it, and put it back. So that is what loose coupling means. How is it possible? You have well-defined interfaces, and again, they are fairly isolated to stay in the architecture, but also be independent enough for all the upgradation that is required. Service discovery. You have services to do all the stuff that you need to, and it takes care of all the issues that are there. That means if you have a particular requirement, a particular service would meet your requirement. And suppose a customer comes in, he is redirected to that particular service in the best possible way, and your AWS takes care of it. Asynchronous integration, and then you have graceful failure. Now, what do these things do? They ensure that integration is possible in all possible scenarios, whether you're dealing with asynchronous situations or synchronous situations. And apart from that, even the failure is handled in the best possible way because you have proper applications. As I've already mentioned, you have something called as auto recovery and all those things. So even in case of failure, you do not have to worry. There are always ways in which you can actually go ahead and deal with so many issues that are there, or if there are any other issues that can be dealt with. Another important point that you need to understand is your cloud platforms. They treat your architecture as services and not servers. Again, that does not keep you fixed or that does not keep you tied to a particular infrastructure. You have managed services and those are fairly isolated and they take care of your problems or your requirements based on your needs. So all these things are taken care by your cloud platforms, and when you do go ahead and have your application there, you need to consider these things as in what are your requirements. Now, when you talk about these cloud platforms, they actually have various vendor policies where you can actually go ahead and give in your requirements, and based on the customer needs, a policy is drafted or services are made available to you as per your needs. Apart from that, you have something called as serverless architecture. That means you're not tied to a particular server and you actually do not know where the server is or where your data is. All you have to do is you have to worry about the applications that you use and the business that you run. Cost optimization. Now I can go on and talk and talk and talk about this point. If you talk about cloud service platforms, I would suggest that again you go ahead and visit YouTube channel of Edureka, and on that channel you search for AWS pricing or maybe Google Cloud Platform pricing, and you'd understand how pricing works when you talk about these cloud platforms. As I've already mentioned so many times, traditional architectures, one of the major problems was the money or the upfront costs that you pay. If you talk about cloud platforms, everything is taken care of. First of all, right sizing. You pay only for the resources that you use and only for the time duration you use. Here, if you're using a service for 30 minutes, you would be charged only for 30 minutes. If I'm not wrong, AWS charges you on hourly basis. So if you're using for a service for a particular hour, you'd be paying only for that. If you talk about a service like GCP, Google Cloud Platform, now if you compare GCP with Amazon Web Services, Amazon Web Services is more established in the market, but comparatively pricing is better for Google Cloud Platform. But apart from that, AWS is much, much better. But if I was to consider only pricing, I would talk about GCP a little more because Google Cloud Platform, it charges you in the best possible way. As we all know that Google is very popular, and if you talk about their big data services, they have been very advanced when you talk about that domain. So they have gone ahead and implemented various machine learning algorithms that actually help you in cost cutting when you talk about using their services. How they have something called as proper power management and all those things. So since they pay less for the power and power management, you are charged less for using their services. And they have models like pay as you go, and you pay only for the minutes which you use. And the minute you stop using their services, you are not charged. So that is how convenient it is. And this is where these cloud platforms are so good. When you talk about right sizing, it is taken care of. Variety in pricing. Now, there are quite a few other things that can be talked about. Like, as I mentioned, there is pay as you go model. You have something called as pay less as you use more. Apart from that, you have, miss, you can just go ahead and choose how do you want to use servers or how do you want to rent these resources. Do you want to rent them for a year? If you do that, again, you would be charged less. And even if you use them pay as you go model, it is still cheaper than having your own infrastructure. So if you talk about pricing, there are quite a few things that you need to consider. I would suggest that you go ahead and visit their website as well, because every pricing or pricing for every service is given there individually, and you can calculate it yourself. You have something called as these pricing calculators, monthly calculators, which give you estimates as in these are the services you're using and this is the amount you would be paying. Apart from that, they give you free tiers which are made available to you, and you can use their services for one complete year without paying any money. So that means they believe in a philosophy where you can actually go ahead and use their services. That means use our services first and then pay for the services that you use. If you feel that you're satisfied, only then go ahead and buy our services. So this is the model they believe in. And that is why when you talk about cost optimization, AWS is a very good platform. Now, if you talk about it from an architecture perspective, as an individual, you also need to consider quite a few factors like how much would I be charged? How much resources do I need? Do I need to pick particular architecture or particular applications or particular softwares? So these are the points that you would be considering. And the points which I just mentioned about the cloud, they take care of all your concerns. If you're worried about buying too much resources and then paying and not using them, you do not have to worry about it because you have something called as pay as you go model. If you're concerned about constant upgradation, you do not have to worry about that as well. If there is a new software that you need to use, just go ahead and integrate with that software and your cloud provider will take care of that as well. So when you talk about cost optimization, it is happening in true sense. Next, we have caching and security. Now, again, I won't jump into the details of these points, but I would like to cover these to certain extent or to the surface. Let's talk about caching first. Now, I recently had a session on caching. Not caching exactly, I had a session on AWS CloudFront, which lets you do this. Now, if you talk about caching, there are ways in which it is done. One, you can actually go ahead and cache your complete application, or there is something called as edge caching. Now, if you talk about edge caching, I would like to talk about CloudFront. Suppose you are accessing a particular website, and while doing that, you need to fetch some data, some objects, or some images, whatever it is. So what you do is you type in a particular URL. and you get directed to a particular website, right? You have no idea where the website is, right? It can be somewhere else. Suppose you are based in USA and your application or your website, it is located somewhere in Australia. Now, what happens is the data that flows to you, it flows through you or to you through a network. Now, there can be quite a few multiple stops that are there, and that leads to latency or the data being reached to you in a delayed manner. So how do you deal with it? What AWS does is it gives you certain edge locations. That is the locations that are closer to you. Suppose you are based in USA. Now the location would be somewhere in between Australia and USA, or it would be more close to you. So depending upon the traffic that flows to that website and where are the maximum customers, what CloudFront does is it creates the copy of frequently asked data at that edge location. So if you request for a particular set of data, it is fetched to you from that particular edge location, and that helps you in speedy access to that data. So that is what caching does. And that is where you have to consider all these things when you do go ahead and have your architecture on cloud platforms as well. Apart from that, security is one more thing. Now, if you talk about security, you can actually go ahead and set your own privilege rights. You can go ahead and think as in, okay, these are the security groups I want. These are the ports I want to have access from. These are the people I want to give access to. So all these things are taken care of when you talk about your cloud platform like AWS. Apart from that, you can actually go ahead and give all the responsibility to AWS to take care of all your security issues, and you can just focus on your business. So this is where the cloud platform is different. And when you do go ahead and consider these points, whether it's caching or security, you have to consider certain points. Like if you talk about caching, you have to consider where do you need to place your data, where do you want to cache it from, and all these things. And if you give these requirements to AWS, it would take care of all those things. If you talk about security, you need to discuss or have a clear idea as in what is your business model, what are the points that you need to consider, and how would you like to proceed with your security. And again, your cloud service provider will take care of all the requirements and customizations if you have any. Next, what I'm going to do is I'm going to present a use case to you people, and the use case talks about Six Waves Games. Now, it is a popular gaming company. What they do is they publish and develop various gaming applications, and those are made available to people through social media platforms like Facebook. And the company aims to publish various games which would help unite people socially. The aim is to bring fun and exciting games to social network. And what they want to do is they actually want to reach quite a few people and reach people in different regions, even in different languages. So what they have now is more than 50 million active players monthly. So you can assume the number of people that are there that use their games. Now, if you're talking about 50 million users monthly, you might be understanding how much traffic do they entertain and how many games they must be having to deal with these many people. So with this comes various other constraints as well. So let us try to understand how they evolved and what were the shortcomings they faced and how did they use AWS to answer or solve most of their queries and problems. So this is the scenario that existed before they actually switched to AWS. Back then what they did was they rented physical servers from some other service providers, and these were the problems they faced. It was quoted by Mr. Tong, who was one of the representatives of the company, and he said that they faced constant problems like repeated configuration process on individual servers. They had to invest a lot of time in implementing these customizations. And as I've already mentioned, if you're talking about repeated configuration, you have to consider something called as constantly upgrading and updating your softwares and having constant installments of various updates. Apart from that, they also had to invest time in monitoring and fixing any failures if there were any. What they did was they did go ahead and use AWS, and most of these problems were taken care of. First and foremost, they had the ability to make use of AWS AMI, that is, we are talking about machine images here. It is nothing but taking snapshots or copying the states of your instances and using it somewhere else. So if you do have an upgrade, instead of wasting your time installing new softwares, just upgrade to a newer instance which is more powerful and which meets your needs. Decoupling was easy. That means having
separation or having differentiation between your applications, your games was easier for them. How? They could decentralize or they could create separations while dealing with different processes, and that made their task easier. Plus, AWS provides you with various security groups and security principles, so everything was taken care of. If you talk about the architecture, first and foremost, what they did was they grouped their gaming servers according to their similarity. There were certain similar applications, those were placed at a particular group of servers, and similarly, clusters were created. And these clusters were placed on different AWS accounts. This ensured proper decentralization. And now you are talking about various accounts and various different clusters. So how was the load managed? Well, they used something called as load balancing or load balancer, which is an AWS service that let them balance this load properly. And the game was made available to people at different places in different languages. Again, they made use of different security groups to ensure all these so-called clusters were safe and secure. So yes, you can actually go ahead and give a shot if you are interested in using any of the cloud services or cloud service providers. And I'm sure that no matter what is your requirement, AWS or the other cloud service providers would definitely help you take care of all of those. Now let us move further and take a look at today's demo. We are going to go ahead and do quite a few things. Let me first switch into the AWS console where I have a free tier account. I would tell you what the application is or what are we going to do exactly. But before that, I would be switching into my console. If you all do have your AWS free tier account, you can just switch into your consoles as well so that we can move ahead and implement this demo. Now, let me tell you that this demo is going to be a little lengthy, so be patient enough. And if you follow all the steps, I'm sure that you would be able to keep up with me because I would be going at a very slow pace. Do not worry about that. So yeah, let me just switch to the console quickly and we can get started with the demo part. Okay guys, so what I've done is I've gone ahead and I've logged into my AWS console. Now this is the place that we are going to use for the sake of our demo today. And this is nothing but our free tier access. You all can have an access to a free tier account. For people who are completely new, you just go ahead and type free tier in your browser and search for it. One of the links would appear. This is the link you have to select and you would be redirected to this page. Now, as you can see, you can use this free tier and gain some amount of hands-on experience that is good enough to get you started with AWS. So what does this free tier offer to you? As you can see, 12 months of free and always free products. Now, these are some of the popular products that are there. You have your Amazon EC2, which is Elastic Cloud Compute, and you have 750 hours per month, which is more than enough to help you get started. Apart from that, you have other services like Amazon QuickSight. Now, this is your analytics service and it gives you 1 GB of spice capacity. I won't get into the details of that, but one of the services, Amazon RDS, which lets you have a database, storage database, and all those things. You have storage services like your Amazon S3, which is your simple storage service. They have certain specified limits. Amazon Lambda, which is another compute service, and quite a few other services actually. So you can actually visit this website and take a look at all these services and their benefits and understand what do these services have to offer to you. You can just go through these videos and get the basics. As you can see, you have learn with 10-minute tutorials, start building with AWS and all those things. So you have access to all these services. You can just go ahead and visit this website. Now, once you do visit this website, you have to create a free tier account, which is very important. You have to click on this thing and you would be redirected to a page where you would be asked as in what is your current job role and why do you want to use AWS. So you can just come here and enter in those details. Once you do that, as you can see, you can select whatever your role is out of these and what are you interested in exactly and you submit it. You can sign into the console if you already have an account. If not, you would be redirected to a page where you have to enter in few of your credentials like your email ID and all those things, and you also have to give in your credit card and debit card details. Now this is a free tier account, but if you exceed those limits which were specified in the previous page, you would be charged by AWS. So do not worry, you normally won't exceed that limits because limits are specified very clearly. As we move further, you would be having a clear understanding of that as well. But for now, this is what you need to understand, that If you exceed those limits, you would be charged. But you do go ahead and create an account because that won't happen. You have certain alarms and all those things which you can set that if you reach particular limit, those alarms can be set so that you won't be charged. AWS also throws in a notification every now and then that you're exceeding your limits. So do go ahead and create an account. One more thing, you would be charged a minimal amount. When I created my account, I was charged a verification fees of 2 rupees, that is Indian rupees. I'm from India, so that is the currency we use here, and which is very, very less. And those 2 rupees were again reinstated back into my account after the verification was complete. So I would suggest that you create this account. And once you do have an account, this is what you would have at your disposal. That is your free tier account. So these are the services that are made available to you. You have your compute, developer tools, you have analytics. In analytics too, you have Athena, EMR, Cloud Search, so many things. Kinesis, EC2 is a very popular service. So is S3. CloudWatch is something that lets you do monitoring stuff and all those things. So you have access to all these services. Now getting back to the demo part, I just talked about architecture and quite a few other things. Now, when you talk about AWS, it makes your architecting process very easy because it gives you so many access to so many services rather. You have access to these services like EC2, which would let you create virtual machines in minutes. And once you have those virtual machines, you can host any kind of applications you want on those machines. So yes, when you talk about architecting, everything is taken care of. You have various security groups and all those things that monitor your security, monitoring tools that monitor your applications, auto scaling, you have image creations where you can create replicas and all those things. So in this process or in this demo, I would be talking about quite a few such things. First and foremost, I would like to talk about some basic things so that we can have everyone on the same page. First and foremost, I would start by creating a virtual machine or two. I would also go ahead and create a ready to use application using Elastic Beanstalk. And we would take a look at certain metrics and principles so that we can conclude quite a few things that we talked about in the theory part or in the explanation part. First and foremost, let's start by creating some virtual machines, or as they say, EC2 instances. Now, EC2 is nothing but your Elastic Cloud Compute. It lets you have virtual machines. Say, for example, you want to launch another virtual machine which has a Windows operating system. You can do that. If you want one on Linux, you can do that as well. If you want an Ubuntu one, even that is available. Red Hat is available. Everything is made available to you. So all you have to do is just go ahead and create an instance. But when you do go ahead and create an instance, there are other things that you need to worry about as well. Now, if I have an instance, I have to worry about the security part, the access part, and all those things. So when you actually go ahead and launch these applications by using platform as a service kind of services, you do not have to worry about any of these things. Your AWS takes care of these things automatically. But if you use infrastructure services, in that case, you have to create everything from the basic. Your so-called EC2 instances are nothing but raw servers or clean servers, nothing but an infrastructure rather. So you have to build everything from the start here. So let's do one thing. Let's launch a basic instance first and see how it works and what all things are we supposed to do in it. To create an instance, I would be needing a security group as well, right? So I'm just gonna go ahead and create one. Let's say I create a security group quickly. I have these many available. I don't want to use these. I would just go ahead and rather delete these because I don't need them right now. So I say delete action. I say delete again and it gets deleted. So there you go. So let's create one very easy. Just give it a name, sample SG for demo's sake. I would keep it default and I need to add some inbound and outbound rules. Now, as the name suggests, this is the traffic that is flowing in and flowing out. So I have to set in certain rules for it. When I say inbound, first and foremost, I need HTTP for the web traffic that would flow in. I say anywhere that is open for everyone. I can add other rules if needed. We normally, when you keep it my IP, it would just allow your IP. If you say custom, whatever you specify would be allowed. So you can just go ahead and copy this thing and use it. I would always suggest that you keep it your IP only so that only you can have access to it, but you can also keep it general as well if it is not of an utmost important when you talk about security. If it is not. RDP is something that I need for my Windows instance. That is the first one I'm going to launch. And again, I would be copying this thing and I've created a sample security group that is sample SG. Next, I would go ahead and launch an instance. How do I do that? I come here and I click on, now these were the instances that I terminated recently. Launch an instance. It gives me a plethora of options. You have your Linux instance, You have your so-called Windows instances as well. So you can actually go ahead and choose the one you want. We would be creating other instances as well, but first let's start by creating a Windows instance. This is the one I would be creating. It is free tier eligible. That means I won't be charged once I create this instance. I click on select. It gives me specifications as in what is the virtual CPU, memory, and all those things. I won't tinker with it. Just next. These are some other details. Again, next. Storage. Do I need to add more? For now, no. I need to add a name tag. Yes, I would. Demo instance, just for the sake of reference. Next. Security group. Please add an existing one. And this time it is sample SG, right? Yep. So I say review and launch. It says that it is open to all and that is not safe, but since it is for the sake of demo, we can use it the way it is. So I say launch. Now again, this is an instance and it would be connected, or you can connect to it by one key pair that is unique to it. So you have to make sure that you have one generated key pair and it is unique. So I would suggest that you keep it safe as well. Let's call it say demo 1 for now. And I say download. My key pair would be downloaded so that I can place it somewhere safe. AWS demo folder, I would put it here. I have quite a few keys here. Demo 1 is the thing I recently created or just created. Now I say launch and my instance is getting launched. So what I'm going to do is I'm going to go ahead and create one more instance meanwhile, because launching takes a while. As you can see, if you just come here and go to EC2, you realize that 0 instances because my instance is getting created and it is running, but it is initializing for now, demo instance. So it would take a couple of minutes or 5 minutes at least for this instance to get started. And once it does start, then you can actually go ahead and log in. But even after the instance starts, it takes 4 minutes for the first time for it to get initialized, and then you can actually log in quickly. So once the instance is created, it is good and easy to use and easy to log in, but you have to wait for some minutes in the initial part. So instead of sitting and waiting for this instance to get initiated, let's go ahead and launch one more instance. Accordingly, I'm going to quickly create a security group here as well. Now this time we would be launching a Linux instance. Now we know that how to create a security group, so I would quickly do it. Let's call it say EC22 SG. And what are the traffic rules that I want to set it? First, let's call it demo because there has to be some description. Let's quickly just keep it HTTP and let it be open from anywhere. Let's add one more rule. This time let it be SSH. I need SSH and let it just take in my IP. Do I need outbound rules? Let's just say open to everyone and my security group is created. Now we can just go ahead and launch one more instance. So one instance is running right now, as you can see here, but it is still initializing. So I'm going to go ahead and launch one Linux instance this time. This one supports all PHP and all those formats and files as well. As we do go ahead and learn something else like AMI, you would understand this thing a little better, as in how can an instance support all these files and all those things. Do I want to give it some name? Say Linux demo. There you go. And I say next. Security group, I just created one, so let me just assign that thing to it. EC2SG, EC22SG, review, launch, key pair. Please generate one more for me, and this time I would be creating demo 2. Download key pair, it gets downloaded. Again, let's copy it here. So we have our both key pairs ready, and this time my so-called instance is getting launched. If I click here, so yeah, my instance is in process now. So we've actually gone ahead and launched two instances. Let's check out whether the first instance that I launched, is it initialized? It is still initializing. So we would have to wait till this initialization process is done. So what I will do is, meanwhile, I will just pause the session for a minute and I would get back once these instances are up and running. So there you go. Now the instance, this one at least has been launched. So let's just go ahead and see how it works. So we select this particular instance, that is demo instance, and I say connect. Now when I do that, I would be given an option to download a remote desktop file using which I can launch this instance. So I click on it so that it gets downloaded. Next, I need to get the password for this instance. So how do I do it? I click on get password. The password isn't available yet. Why? Because as I've told you, you have to wait for 4 minutes, right? So again, I believe we'll have to wait a little more. So let's wait. Let's try it now whether we can log into this instance. This was the one we created, right? So connect, get password. Yes, we can now. So I have to choose that particular file, and demo one was it, right? Yep. So I say go ahead and decrypt password for me. So this is the password that I would be using. I just copy it from here. I click on this file. I say connect administrator password. I just paste it here. Do I want to continue? Yes. It depends on your processing power, your system's processing power, how fast it processes these things. As you can see, the instance is launched and I'm logged in as an administrator. So I have a virtual machine which I can use on my system. Since the internet is slow today, it took a longer while, but it happens faster than this. And you can actually go ahead and do all the stuff that you want to do. You can create your applications and you can do a number of other things here. It has refreshed now, and just like your Windows operating system, this too has a Windows operating system just like any other system. You can go ahead, create files, install softwares, and once you install softwares, you can make copies of this so-called operating system as well. As we move further, we would be discussing that as well, do not worry. But my aim here was just to show you this instance. Now I'm going to go ahead and terminate this instance. Do I want to stop it? Yes, I want to. So I would just go ahead and close this instance for now. My other instance is up and running, and I'm hoping that 4 minutes are done here as well. Now the way you log into this instance is different. When you log into a Linux instance, it works differently. How? You need to first use your so-called key pair and convert that into a ppk file, and you have to run it through a third media, and in this case it is putty. So for people who want to use a Linux instance, I would suggest that you go ahead and download putty and putty gen as well. Why do you need putty gen? I would tell you that. So first and foremost, let me open it. I would share the links, do not worry. You would have links for putty gen and putty as well. You can download those. And if they are not available to you, you can just go ahead and Google putty and putty gen, and those would be made available to you as well. So this is putty gen. Now what putty gen does is it converts my so-called PEM file into a format that my putty understands. So for that, I have to come here. Before that, I would just say load and AWS demo. This is where our file was, right? So if I just go to all files, demo2 was the key pair I used for this thing. So I would say it was imported here is what it is saying. I save it as a private key, and name I give to it is demo3. I say save, and now the Java's key generator is done. Why? Because it has converted that file into a ppk file. So I can close it. Now I need a putty to log into it. So I open putty. So I need to put in my user configuration details like this here. This is public DNS. I copied from everything that is after at, and I paste it here. Next, I need to go to data, and here I have to type in the username. As you can see, it is EC2 user, which is here. So I'm just going to enter it here, EC2 user, and I need to authenticate this process. So how do I do it? I click on authorize, that is SSH, and authorize. So you say browse, you select demo3, and you say open. Now you say open. It says the host does not exist. Something is wrong. Okay, we will deal with that later. So this is how it works. Basically, when you do go ahead and log into it, a console would open and you can actually go ahead and enter certain commands. Now, while creating this instance, something might have gone wrong, so we cannot log into it. I would not want to just go ahead and launch this instance again because that would waste a lot of time. So let's just move further and try to do something else with this thing. Now, what you've seen here is you've actually gone ahead and launched an instance. So if you have a job where you have to do everything from the beginning and you have to set everything from the very start or from the very core, you can actually go ahead and launch these instances. Apart from that, what you can do is you can just move to services. You can have your storage as per your needs, whether you want an S3 storage, do you want to have an SQL database, you can just go to RDS and launch an SQL database as well. Just like we launched this instance, you can launch volumes and databases as well. And on that, you can just go ahead and deploy already created applications or create your own applications as well. So that is why these instances are very important and you can do so many things. Now, these are basically your infrastructure services. Why? Because you do everything from the very basic and you do so many processes and so many things while doing these things. So instead of putting in these many efforts, you want to use templatized applications. There are ways to do that as well. Now you have something called as Elastic Beanstalk. If I open that thing, it would redirect me to this page, and if I click on create an application, I can just start by creating an application. Let me give it some name. I've actually gone ahead and copied certain names. Control C. If I just come here, I'll paste this name. Let's say samples one, just say samples. Description, demo application on PHP, and I say create. So this would help me create a PHP application. Now it asks me whether I have an environment available with me. I say no. So I can just go ahead and create one immediately. I just set in few details and it creates the complete environment for me. So I select this web server environment because I'm trying to host a web app here. So it already fills in the details, as in this is the name it gives by default. Let me just put in some domain name randomly. Let me copy this. Again, let me tell you, this is something that I'm putting in. You can put in any name that you want and just check whether the domain name is available or not. If I say check availability, it says it is available, so I can use it. I'm saying demo web app. In the description, you can add more description if you want. Platform, I need a pre-configured one. That means you do all the work. I just give me a platform where I can launch my application. And how do I use the code? Now, don't worry, I would be sharing the link for this particular code. So you can just go ahead and download a sample code from AWS website. I probably believe I have it downloaded with me, so I would be uploading it myself. I say upload and I say choose a file. Now, where did I put it? This is the one. It is a zip file. Relax, I would be putting it in the description so you all can have an access to it as well. So I say upload, and there you go, the file has been uploaded. So when I just go ahead and first let me just quickly take a look, everything is right here. Yes, so you can configure certain things. You can come here and you can just click on configure. This is everything under free tier eligible, so all the resources that are created. Now, as I've just mentioned, if you do go ahead and create your own instances, you would be putting in so many efforts. You would be creating your security group, you would be assigning a particular database to it and all those things, right? Now, if you talk about a configured application, here Elastic Beanstalk is taking care of everything. As you can see, it has given me option, as in this is the instance. It has created an instance, T2 micro instance on its own, and it would be using this instance. All the details are given about it. You have your virtual key pair that is associated with your so-called instance, and its details are here. You can modify that as well if you want to add something else. Network, you can go ahead and modify your network. So if I come here and I say VPC, I can select a particular availability zone. Say I select this and I have that here. So yes, everything is taken care of. Now, this is how it is different from an infrastructure as a service. This is a platform where you have ready to use resources made available to you. All you have to do is just create your application or put your application here, and your so-called system takes care of everything. And that is where AWS is so different from so many other services that are there in the market. So if I just come here and I scroll down, and if I say create an environment, it would just go ahead and create an application for me, and I would not have to do anything else. I mean, everything is literally taken care of here. So this might take a couple of minutes more. As usual, I will pause the session and I would come back once this thing is done. While this instance gets launched, I would like to put forth some things. Now, as I've just mentioned, when you talk about infrastructure as a service, you do everything on your own, right? This example actually gives you a clear differentiation between those things. Now, this is platform as a service. Now, if you take a look at the proceedings here, and if you start from the bottom, you can see that first it started by creating an environment. It used Elastic Beanstalk, and then it actually went ahead and it then created a security group. It assigned an IP to it and all those things. So this is how it works, and you have to do it on your own when you use infrastructure as a service. But in platform, it does everything for you. And once it is done with everything, you get this instance which you can just go ahead and use. Not an instance, it's an application. So you can just have this ready to use application which is given to you at your disposal. So when we created that instance, it took so much time, isn't it? Means you had to launch that instance, assign a security group to it, and it took like 10 to 15 minutes just to get that instance started. But when you talk about these ready to use applications, your so-called AWS or this AWS service, it has taken care of everything. And within 2 to 3 minutes, you actually have this session which is up and running, and you have this application which you can use. So if I click on this link here, I would be having a ready to use application. I can actually go ahead and customize this website. I can bring in updates. Now, the zip file which we downloaded, you can edit the files that are there in it as well. You can add better colors. You can make change to the interface. You can add more applications and do a lot more stuff or a lot more things with this so-called application. This is a basic thing, and it actually redirects you to AWS documents. Say, for example, if you want to know about Elastic Beanstalk, you can click on this link and it takes you here. So it is fully functional and up and working for you. So this is how you create an application using Elastic Beanstalk. If I come back here, I have quite a few things that I can do. So this is what I was talking about, what all it did and what was the time duration in which it did it. So it was waiting for this thing happened, then this happened, then this happened, and then this happened. So it took care of all these things and it gave me this so-called application. Apart from that, what AWS does is it gives me quite a few other things. If I want to configure it, we have already seen it, right? You can configure the software the way you want to, and you can add as many things as you want to. It gives you logs. You can generate logs on hourly basis as well. Health, well, how strong it is overall status is okay here. Monitoring, no data to monitor for now is what it says. So selected time and range, you do not have anything to do. Time range, I say 1 hour. There you go. This is the environment, how healthy it is. CPU utilization, it has not been utilized till time is what it's saying. You can change it as per your needs, whatever you want, and you would be getting all the data that you want. You can actually go ahead and refresh this application. You can think about adding alarms as well if you want to go ahead and add some alarms to it. But we would get back to this thing as in how can you add alarms and all those things. Right now, our so-called application hasn't been used at all. So there is absolutely nothing for me to show to you people when you talk about the monitoring part. Else you get all the data here as in how much CPU has been utilized, what is the maximum network that is out of this application and all those things. So what we are going to do now is I'm just going to go ahead and show you one more thing that is related to the architecture part as well. This is the monitoring part. Here you would get all the data that you need. But now that I've gone ahead and I've created an application, this was a fairly easy one because all I had to do was just go ahead and create an application, right? Just launch it. That's it. But you might come across situations where you actually go ahead and launch an instance and create your complete application. In situations where you do not want to lose that data or want to reuse that data, you can carry out two tasks. One is your reusability task and the other one is recovery task as well. And how do we do that? Let me give you an example. If I just go back and I go to services, if I move to EC2, now this instance was just launched, right? So if I say up and running, it would show three instances here. Two are terminated, ignore those. But this is my PHP samples website, right? So this is the instance for it. So what if I want to reuse this piece of code again and again? Can I do that? Yes. If I click on this thing, I have an option of mirroring this instance. But before that, I need to stop my instance because your data is ephemeral. It's okay. This is for the demo sake. I do not mind if I lose the data on this thing. So why do I stop this instance? Because there are certain processes that are going. And when you take an image, that means you're taking a snapshot of your complete instance. And when you do take this snapshot, there is a possibility that you might lose out on some data that is happening in real time, right? So when you stop the instance, everything pauses and the state and the volume of your instance is held in one position or in one state. So you can actually take a snap of it. Now, when I say a snap of it, what I'm doing here is I'm actually creating a replica of this instance. So in future, if I launch my AWS console and I want to create a similar application, instead of going through all the process which I just went through, I can just go ahead and launch this snapshot. So this enables reusability. And even if I lose out on an instance which is in some other location, and if I have a snapshot of that instance in some other location, at a different location rather, so if one of the location goes down or server at one of the location goes down or something happens to that data, I can always go and use the data that is there at the other location. That is why creating a snapshot or an image of this instance can help. Now this is what I have here, right? So if I just click on this thing, my instance has stopped. I can just say image and I say create. What kind of image do I want? Say PHP sample, or let me just give it a new name, new PHP samp, so that we can differentiate it. If there are any other instances with similar name, we can differentiate it from those. So this is the name of our so-called instance, and this is an image for say recovery. Do I want to do something else? No, I just say create it. Okay, let me just retry it. For some reason it is not allowing me to launch this in a stopped state. So let's just go ahead and start this instance. Let's just skip this for now. We have other instances that are made available to us. Let's say this Linux one is something that we need to create an image of. Let's just say sample one, and let's say demo, and let me just create an image out of it. Yes, the image is created there and there. Probably the thing that this was being used by my so-called application, I could not just replicate it immediately because it was in some process, and that is why I got these errors here. So instead, what I've done is I've picked this running instance and I've made a copy of it. I do not have any issues about losing any data on this thing. So I've just gone ahead and created a snapshot. I can come to AMIs and take a look at the AMIs that are being created. And this is the one which I just created, which is getting created and it is pending. Now these are some of the other instances that I have gone ahead and created. If you want to take a look at these so-called AMIs, you can always come here. You go to services, you go to instance, and in that you always have an option of launching an instance. So when you do that, you have these options here. Quick start, what is the AWS marketplace for certain instances, it will tell you what are the popular ones and all those things. So when you come to my AMIs, as you can see, these are some of the sample instances that have been launched previously. Now this is for a PHP application. Again, if you just select it, it is a ready to use instance. If you say next, you would realize that it has been configured with security groups and all those things. So just like the other instances you launched, if you launch this particular instance, it would give you all the configured stuff that was there in your PHP application, and you can use it readily anywhere you want to. So that is what AMIs do. It is nothing but your AWS machine images. That means you can take images or snapshots of your volumes and your applications, and you can just reuse them wherever you want to. So this is a very important thing when you talk about AWS, because it helps you in architecting your resources much better. Why? Because you always have so many options to deal with so many things. I mean, if there is something that is missing out, you always have something to do with it. Now, the instance which I just created, or the snapshot, that has also been completed. So if I again go to the dashboard and I say launch an instance, if I come here to my AMIs, you would be having three AMIs here. Where is the third one? Okay, it is still under process. So this thing actually got terminated. So that is why we could not create a replication of it, because it was in a terminated state. Now this is your demo instance and this is your PHP samples instance. That is again an instance that is being used. If I just again come here, services, if I say Elastic Beanstalk and I select this thing, my application is still up and running, right? Why? Because I just created an image. Now, as you can see here, there was a warning here. Why? Because an instance was removed, and that meant there was an health check failure here. But what happened was the image that was processed, I already have an image that is working or has same set of data. So it switched my application to that instance, and that is why it says environment healthy and has transitioned from pending to okay. Why? Because it moved on to the snapshot, that is to the image which I had taken. So even if the instance it stopped, now I have another sample instance, or the image rather, from which I can actually go ahead and run my so-called application. So if I go back, let me just show it to you again. So if I say services, EC2, PHP samples. This thing is still running. Why? Because it is supporting my so-called PHP applications here. And if you take a look at the timing, it is 4:27, which is 7 minutes from or prior to when I was actually using my so-called instance. And this is 4:18. This is when we actually did go ahead and create our so-called application using PHP. So when I did go ahead and stop this thing, I had an image here. So this image, when that thing stopped somewhere around 4:26, it jumped onto this thing and it switched back to being healthy. Why? Because it used the other instance that was made available to it. So that is what you can do. I mean, even if you lose your data or you lose one of your instances, if you can just go ahead and take snapshot of it, you would have a backup which would fully support your application the way it was back then. That is why AMIs are very important. And if you consider all these factors like your AMIs, and if you consider in monitoring and all those things, and if you take care of all these things, security and all, you can have a very healthy and nice architecture. So if you are architecting an application, if you have a clear understanding of all these topics, you can do so many things and you can have your application modified in so many number of ways. So yeah, that is what we've done. We've actually gone ahead and we've created some instances. We've actually gone ahead and launched an application. We have seen how the monitoring part works, as in what are the stuff that are made available to you. Now, this is the thing that is here. As you can see, this is the CPU utilization that I have, and I can actually go ahead and set alarms as well. If I want to keep a check, as in how much is the CPU utilization, and if it exceeds my expectation, I can always keep a check on it, as in if it goes above this level, you please inform me on these things. And this is how you do it. You click on that alarm icon. If you come here, my period is 1 minute, threshold, let's say 10 minutes. And if it not 10 minutes, if it is greater than this value, I want to be notified, and let the state change accordingly. What is the email address I want to be notified on? Let it be this. I say give me an alarm, and I say add name, CPU usage should be better. So I say add. Now once I do this, my environment gets updated accordingly, and it would send me an email saying that do you want to go ahead and means allow these notifications. That is the email ID which I've entered. It would send a mail to that person saying that do you want to be notified when the CPU usage is up to a particular limit or it has crossed or whatever condition I set into it. Do you want to be updated accordingly? So let me just go ahead and show it to you. So if I just say yes to those notifications, I would be constantly notified on all these things. So this is the mail which I've just received. It says, do you want to confirm? I say yes. So subscription confirmed. That means each time I have a notification, the system would update to me or inform me as in, okay, this is what is happening. So it has been updated now. And from 1 minute from now, I would be getting updation as in whether the CPU usage is more than 30% or not. And if it is more than 30% or more than 10% is the limit which we have set, it would give me an alarm actually. So let's just wait for a minute and see whether we do get an alarm or not. So yeah, this is pretty much the demo that I wanted to cover here. I wanted you to have a sneak peek into quite a few things, as in what are the basics, how can you create instances, how can you go ahead and create your applications, plus the AMIs and all those things that I talked. These are the things that are to be considered when you actually go ahead and architect a particular solution, because there are quite a few things that actually help you build a very good application or have a very good infrastructure. And when you talk about AWS, as I've already mentioned, there are 70 plus services, and almost every need that you have can be taken care of by using AWS. I have to wait for this application. So I would meanwhile just pause this video, and once the update is here, I would just show you the notification. So yes, as you can see, I was notified with an alarm. So this is what they have to say. View this alarm in AWS Management Console, and these are the details. So state change and all those things. There was insufficient data, so they had to like they could not change the state and all those things. So yep, here is the update as in what has happened and what can be done, or what is the current metric. So you can actually go ahead and set alarms for your so-called instance as well. There you go. So this was about the session, and this was about AWS. I would try and share all the links that I've talked about and that can be used by you people. so that you can go ahead and carry out the tasks that we've done. As far as this session goes, I would be ending it here and here. And if you do have any queries, make sure that you put those queries in the chat box below so that we can actually go ahead and get back to you on those queries as soon as possible. I hope this session helped. Thank you. Bye-bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to EduReka channel to learn more. Happy learning!
Hey guys, this is Hemant from AWS. Welcome to this session on what is AWS. So without wasting any time, let's skip on to the agenda to see what all we'll be covering in today's session. So we'll start this session by first discussing what is AWS and then move on to discuss the different companies who are using the AWS service. Once we're done with that, we'll move on to discuss why companies, big or small, are using AWS or any other cloud provider for that matter, right? So once we've discussed what is AWS and why AWS is important, we'll look at some of the basic services that AWS has to offer us and then move on to discuss the AWS global infrastructure. Once we're done with that, we'll end this session by discussing the various pricing options provided by AWS. Right, so guys, this is our agenda for today. I hope it's clear to you. Now let's go on and discuss the first topic of today's session, which is what is AWS. So guys, AWS, that is Amazon Web Services, is a subsidiary of Amazon.com and is the world leader in cloud computing market. Right? It was launched way back in 2006 when no company had the cloud computing business model. It took the risk, and now today 70% of the whole cloud computing market is residing on AWS. So now you can imagine how big AWS is, right? Talking about companies who are on AWS, let's look at some of the companies, some of the prominent companies who are using the AWS infrastructure. So these are some of the very popular companies like Kellogg's, Adobe, Airbnb, General Electric, Netflix and Amazon, which are using the AWS infrastructure for their operations. Now, Netflix and Amazon are completely dependent upon the AWS infrastructure. Now, you can imagine if these two companies, which are so big and the whole world is using it, even your application is going to share the same infrastructure as these apps. So you can imagine that your application is in safe hands, right? You can be assured with that. Having said that, let's move on to discuss, but why do companies use AWS? What's the advantage of having the cloud computing technology with you? Right, so let's shed a light on that, and for that, let's take an example. Say you think of starting a business, and say your business is Instagram. You think of launching the Instagram application, and you have the application ready. So now you have to make it available to the world. So the first thing that you have to do is you have to invest some money, buy some servers, and upload your application on it, and your application is up and ready, right? So you start with a small user base and you say, okay, so in 1 month or so, I can expect that so and so users will be there. But your plan doesn't go according to your will. And what happens is overnight, your application becomes so viral that there are millions of users who are trying to access your application now. So the servers that you had are now very overburdened with the kind of traffic which is coming in, and you get very anxious as to what to do. So what do, you invest some more money, buy some more servers, and now the situation seems to be a little normal, right? But guys, servers are machines. We should not forget about it, right? And they are bound to break down. So one fine day, what happens is your servers, they go down, they go haywire, and your application is not working anymore. So to fix this, again, you had to hire a maintenance team, which is now going to manage your servers for you. That is, any kind of server upgrade which is required, any kind of software patch which has to be put in, or when your server goes down, replacing it with a new server, all of that is now going to be managed by the maintenance team, right? So the kind of attention that was required for you to give to your application, it could not get that attention because half of your attention was towards the infrastructure side, which is understandable, right? So these were the problems before cloud computing, and one fine day AWS came up and said, but why don't you use my servers, right? I have a stack of servers in my warehouse. Why don't you use some of them, right? And the best thing about it is that you don't have to buy the servers from me. You can just rent them from me, use them for the time you want it to, and give them anytime you want. Say you give it to me after 5 hours, you just pay for the 5 hours time that you used it for, right? At the same time, you don't have to worry about the maintenance, right? I will do the maintenance for my servers. And with this was like, the God came in and said, let me help you out. It was like that. So this was a very good deal for you because now you're not spending money on buying servers, you're not spending money on the maintenance team. Everything is being managed by AWS and at a very cheap price of per hourly basis, right? So it's very awesome. So moving forward, we've understood why AWS companies are adopting AWS or any other cloud platform and what exactly is AWS. Right? Let's move on to discuss the services now. So let's take an example again here. Let's take the example of a website. So this is a skeleton architecture for a very normal website that is there, right? How does it function? The user first he goes onto a website, he goes onto the internet and he types in a web address, right? That web address then goes to a DNS server. That DNS server basically gets that converted into an IP address. That IP address points to a load balancer. That load balancer in turn is distributing the traffic among many of the servers, and you end up on any one of these servers. This is how it happens, right? And now this server is again connected to a relational database, and this relational database is basically having all the information which is required for your website. And also both these entities, that is your database and your servers, are inside a network so that they can communicate with each other, right? So these are the basic entities which are there in a cloud computing world. Right now, taking the same problem as before, that suddenly a whole lot of user group comes in and your servers become overburdened. Now how do you take care of that? So you don't have to take care of anything. Cloud computing, the cloud computing model is such that it will take care of itself, right? So it automatically senses that the servers are getting overburdened. It adds a server automatically, and now your situation becomes normal, right? So this is how the cloud computing world is going to help you out. We discussed this already, right? But now, having seen this architecture, how it works, now let's look at how these services or how these components will look when we look at it from the AWS perspective, right? So when you talk about AWS services, the DNS server that we discussed is called Route 53. The servers, the web servers that we discussed are EC2 servers. The relational database is RDS. The network in which these components will be enclosed in is VPC. And the load balancer is again load balancer. And the property which increases the number of servers and lowers them according to traffic is auto scaling, right? So these are some of the basic services offered by AWS, and these are awesome, guys, right? So these were the services that we were to discuss. Moving forward, now let's discuss about the global infrastructure that AWS has to offer. Now, AWS provides these many services throughout the globe. It has a global presence, right? And these orange dots are the regions that AWS has, right? Each region has multiple zones, and zones are nothing but huge data centers with a lot of servers, right? So probably when you choose America, when you choose the US, so probably you'll be ending somewhere around here, right? If you choose a region, one region is this and the other region is this. One zone would be one circle, and this is how it functions, right? So in all, there are 18 geographical regions around the world, and in those regions, we have around 50 availability zones, right? So there are 50 huge data centers around the world that are at your disposal, right? But why will you need a global infrastructure is a question, right? So say we take the same example forward, the website servers, and these servers are now distributed among different places throughout the world. Now, what advantage does it give you? First of all, it helps you in a disaster recovery kind of situation. For example, this server goes down, you all again have these two servers to serve your traffic fraud, right? So if this server goes down because of power outage or any natural calamity, your application is still up because it has been hosted in different regions, right? This is one advantage. The second advantage is that it serves the purpose of users from different countries. For example, you are in this country and you're trying to access your website, probably you can access it from this server, right? Rather than having your servers at a one central location, which will not only have more latency, that is response time, if a customer is out of the country, but also it's a very bad measure to take when we are to consider about disaster recovery, right? So this is the reason that AWS has a global presence, that they have a global infrastructure. So it is there because so that your customers can have the lowest latency possible, and also you can implement the best disaster recovery measures. All right. Having said that, let's now talk about AWS pricing, guys. Now, AWS pricing is amazing, So, like we discussed, so we have a per hour billing kind of system, right? So, and the pricing is also region specific in the sense that each region has different pricing for different services. They don't differ much, but still they are different from each other for each region. So you can choose a region according to your preference. Also, there's a scene called reserved instances. So when you choose reserved instances, you save up to 90% costs. So when you say reserved instance, it basically means you rent the server for a particular term, say a 1 year term or a 3 year term. And when you do that, when you compare it with on-demand pricing, you save up to 90%, which is awesome, right? And also there is an option for spot pricing as well, wherein you get incredibly low prices by bidding on servers for a particular price, right? So you bid on server for, say, I want a server for $2. If a server is available, you get it, right? You use that server until the server price goes up. And once it goes up, the server is taken automatically for you, right? It could be helpful for workloads wherein the work is not that urgent, but you want to get it done in the minimum cost possible, right? So it is helpful in that. And with that, guys, we come to an end to the AWS overview. Thank you guys for attending to this session. I hope you guys learned something new today. So if you like this video, please like and subscribe to our channel and share it to your friends so that they can learn more. Happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
Hey guys, this is Hemant from Edureka. Today in this session, we'll be talking about Amazon AWS. So without wasting any more time, let's move on to today's agenda. So we'll start off with what is AWS, and then we'll be discussing the different domains which are there in AWS. So domains are basically the categories under which AWS offers its services. Once we learn all these services, we'll try to solve a real life problem using these services and the domains that we have just learned. After that, wouldn't it be cool if you could use all these services for free? Or if you could practice this use case for free? Yes, you heard it right. I will teach you guys how to do that by making you guys learn the AWS free tier. After that, we'll start off with AWS certifications. So we'll be discussing all the certifications which are offered by AWS. And then we'll start off with AWS Solution Architect role, the role that you guys have taken this training for, right? In the end, we'll talk about the AWS competitors. We'll talk about all the major players which are out there in the cloud computing market, and we'll see why AWS is still a leader among them. So guys, this is our agenda for today. Are we clear with it? Right, John says yes, Dhruv says yes, Theon says yes. All right, guys, so let's move ahead. Let's start off with what is AWS now. So AWS is a cloud services provider from Amazon. So it's a platform on which AWS offers its cloud services. Now these cloud services can be mixed and matched to create any kind of application. Now this application can vary from a healthcare application to a social media application to a banking application. You can create any kind of application in the AWS infrastructure, but you would use the same services for it, right? And that is the reason these services are actually called the building blocks for AWS. So guys, this is what AWS deals in. Do you have any questions related to what AWS has to offer us or what AWS deals in? So since now we understand what is AWS, let's move on and discuss the different domains under which AWS offers its services. So these are the different domains that are there in AWS. So first up, we have the compute domain. So the compute domain would include services like EC2. So an EC2 is just like a raw server. It's a fresh computer that can be configured to be anything. You can install any software in it. You can configure the firewall to any setting, and it can perform as you require, right? So you can configure it to be a web server. You can configure it to be a worker tier environment. You can configure the EC2 server to be anything. Right. Next up, we have the migration domain. So migration domain basically helps you in migrating your data from your own data center to the AWS infrastructure. Now there's a service in the migration domain which is called the Snowball. So Snowball helps you transfer your data from your own data center to the AWS infrastructure when you have a large amount of data. So suppose your data center is at a scale of petabytes, right? So it doesn't make sense for you to transfer this much amount of data on the internet, right? Because it will eat up your bandwidth. So that is where Snowball comes in, and that is where you will use Snowball. Next up, we have the security and identity compliance. So security and identity compliance basically includes services like IAM, which helps you authenticate people to your AWS account. So if you have a company and you want to give usage restrictions on the employees that are using your AWS account, you can do that using IAM. Next up, we have the storage domain. So storage domain would basically include services like S3, which is a file system. So a file system is basically used to store executable files which can be used on your website or somewhere else. Right. Next up, we have the networking and content delivery. So networking domain would basically include services like Route 53. So Route 53 is a domain name system. It converts your domain name to a public IP address. So it performs just exactly like a domain name system. And you can also use Route 53 for external resources as well. It's not important or it's not essential for you to use the AWS resources. You can actually point it to different servers as well. Next up, we have the messaging domain. So messaging domain would include services like SES. So SES is a simple email service which can be used to send bulk emails to your customer base. To do that manually, it will take a lot of time, but with SES, you can do that with a click of a button. Next up, we have the database domain. So database domain would include services like RDS. So RDS is a relational database management service. So it basically manages databases for you. So when I say manage, it can update your database engine. It can update your security fixes. All the tasks that were done manually before can now be done automatically using this management service. Then comes the management tools domain, which would include services like CloudWatch, which is an all-in-one cloud monitoring tool which you can use to monitor your AWS resources, right? So guys, these are basically the domains in which AWS offers its services, and these are the functionalities. So with this, you get the idea of the functionalities that you can incorporate in your application if you're building it using the AWS resources. So guys, are we clear with this slide? Are we clear with all the domains? All right, people are saying yes. Dhruv says yes. John says all clear. All right, guys, let's move ahead. Let's solve the problem now. Enough of theory. So we have discussed all the domains in AWS. So we basically know what all AWS deals in or what all AWS services can handle, right? So if we have a use case like this, we have to create an e-commerce website just like Amazon. So what all domains would we require, right? So let's discuss that. Let's give it a thought. So first of all, we would need a lot of servers because obviously we'll be hosting a website on something, right? So we will need the compute domain. Next up, we will also need a file system where we can store our images for our products and also maybe MP3 files or video files if there is a download option as well, right? So we would need a file system. Next up, we will need a database as well because we would need to store our users' passwords and emails for their logins and also save their preferences, right? So all of that can be stored in a database. So we would need the database domain as well. Then we would need a domain name, right? So our domain name should point to our server. So we would need a networking domain in between which could convert a domain name to the IP address of the server on which our website is hosted. Right? So these are all the domains that we'd be needing. Let's try and represent it using a diagram. So we would be needing a compute domain, we would be needing storage, we would be needing database, we'd be needing networking. So yes, this is it guys. So this is basically the architecture or this is the way your website will function using these resources. Right? So any doubt guys, anything that you want to add in these domains? So guys, if you are clear, let's take 2 seconds more on this slide. Now, if you were to make this architecture using the cloud services, you have AWS at your disposal. But let's also give it a thought. If cloud computing was not there, you would have bought everything yourself on your own money and you would have made this architecture. Now, this would have led to problem. Let's see what all problems you would have faced. So first of all, this setup would be very expensive. Why? Because guys, you'll be buying a lot of servers and guys, servers are not cheap. They are very expensive. This setup is obviously going to be very expensive for you if you buy all the servers. Second of all, let's address the problem of scalability. So scalability basically means growing up the number of servers or coming down from a minimum number of servers. Now you cannot judge the kind of traffic which is going to come on your website, right? Now, if you become over ambitious and you buy a lot of servers, it will lead to for their idle time because you buy a lot of servers, but they'll not be utilized properly because that kind of traffic is not coming onto your website for now. And if you become less ambitious and you buy less servers and more traffic comes onto your website, it becomes a bad experience for your customer, which is again bad for business, right? So what to do? So this was a problem. Third of all, you had to monitor and maintain your servers. Since you're buying the servers on your own, you would have to hire a team to monitor your servers continuously because obviously you don't want your website to face any kind of downtime. And if and when you encounter a problem, troubleshooting this problem will obviously involve more money. you can solve it on your own or your hired team will do that, right? In any case, you will incur more cost and hence it will become more expensive for you. So guys, these were the problems and hence we use cloud computing today and save costs on everything, right? So guys, are we clear with the problems that were there before cloud computing? All right, Dhruv says yes, John says all clear, Theon says all clear, Parvati says yes. All right guys, so let's move ahead. Now, since these are the problems, people didn't want to buy their servers on their own, right? They wanted cloud providers. Now, if you were using a cloud provider, say like AWS, let's see how you will architect this problem. So in the networking domain, like I said, there's a service called Route 53, which is a domain name system. So we'd be using Route 53 for that. In place of storage, we'd be using S3 because S3 is a file system offered by AWS. Now in terms of database, we'll be using RDS because we'll be storing the user's information, the login, ID, the password, and the product information, which can all be represented in the form of a table. It is structured and hence we'll be using a relational database for that. Right. Next up, we have the compute domain. So the compute domain would include services like EC2, which will host your website onto it. And then since your website should also be scalable, right? So let's address the three problems which we just discussed. So our setup was expensive, our setup was very difficult to scale, and we had to monitor and maintain our servers, right? So first of all, the expense part, so you pay as you go. So whatever you use on Amazon or whatever you use on AWS, whatever services you're using on AWS, you pay them according to your usage. So if you're using a server for say 2 hours, you just pay for those 2 hours. You don't pay for the whole month, right? So, and obviously if you're not buying servers, the investment costs come down drastically, right? This setup is no more expensive. It comes well within your budget. Next up, there was the problem of scalability. So under the compute domain, we have elastic load balancer and auto scaling. Let's discuss a bit about these services. So auto scaling automatically scales up and down your number of servers according to the metrics that you have set. Now what are these metrics? These metrics could be something like this. So suppose you have 3 servers running, and when you say then the combined capacity of them, the combined CPU usage of these 3 servers goes beyond 80%, launch a new server or spin up a new server. So this is done by auto scaling. Again, same in the case when the CPU usage goes below 10%, maybe decommission a server. So this is again done by auto scaling. But when you're using auto scaling, you always use the elastic load balancer as well. Why? Because what elastic load balancer does is it distributes your workload equally among the number of servers which are running. So if auto scaling runs or auto scaling spins up a new server, the traffic has to be distributed among the servers that were already there plus one the new server, right? So this is managed by the elastic load balancer. So coming back to my point, we were talking about scalability. So the elastic load balancer and auto scaling solves that problem. So it addresses the problem of scalability, it addresses this infrastructure or this setup also addresses the problem of expense. Let's talk about the monitor and maintenance part. So all the monitoring and all the maintenance of the servers are handled on the part of AWS. You don't have to worry about anything. You just have to work on your application and that is it. Everything else will be managed by AWS. Now this is the beauty of cloud computing, guys. You are getting a lot of benefits and at the same time it is not hurting your pocket as well. These are basically all the services that you would be using in your architecture. Now let's fit these services in this diagram that we saw before and let's see how it will look. So our website URL will point to Route 53, which will convert that domain name to an IP address. That IP address will be hosting your website and attached to that server will be elastic load balancer and auto scaling, which will address your problem of scalability. Now your server will interact with the database for the user's information and the product information, and the product's images and the other executable files are stored in the file system. So this is how your architecture will look. So guys, do you have any questions related to the use case that we just discussed or any questions so far? Anything that you didn't understand? All right, Dhruv says no question. John says all clear. Guys, any part that you don't understand, please throw up a question. I'll be happy to answer your query. Okay guys, since you guys have no questions, let's move along. But before that, let's give it a recap. So you've learned all these services, right? You know all about these services now, but the question is, how will you use all these services, or how will you learn more about these services? Because theory is one part, but until and unless you don't use them actually, that is by practical, you won't know any one of them, right? So how will you learn all of these services? So we have come up with this learning path in which for learning AWS, you first have to opt for AWS training. So congratulations on the first part for opting this training class. So your first part is done. Now this training class would include two sections. First are the training sessions. This session that is happening is your training session. And the next part is yours, which is the hands-on part. So whatever practicals that we are doing today, whatever practicals that we are going to do today are to be practiced by you guys, because that practical session is very important, right? Now, how will you do that practical session? So I will teach you guys how to create an AWS account, right? But creation of an AWS account, but then you will ask me, Hemant, we are creating an AWS account, we have paid you, why should we pay for using the AWS services as well, right? So we have a good news over there for you guys. So AWS understands that without using these services, you won't be able to decide whether you should go for AWS or some other cloud provider for that matter. So for the first year, from the date that you have signed up on AWS, you get the free tier option. And this free tier option is valid for 1 year from the time you have signed up, right? So you can practice all you want in this free tier. We'll talk more about free tier in the next slide. But before that, do you guys have any question related to the training or related to the points that I've just discussed with you? So Dhruv has a question, won't all people keep using free tier? Very good question, Dhruv, but like I said, it is only valid for 1 year and it has its limitations. If you're using it for business, you cannot use the free tier for business. Why? Because the free tier includes all the services at their minimum. In the sense, like if you're using the compute domain, right? So there's a service called T2.micro, or in EC2, there's an instance called T2.micro. Now you can imagine T2.micro as a core-to-duo processor in the AWS cloud world. In the technology that exists today, when we have i3, we have i5, if you want to use core-to-duo for your business purpose, it doesn't make sense. But that core-to-duo would help you if you want to learn about it, if you learn about how AWS functions, right? And that is the purpose of free tier, to help you learn. So does that answer your question, Dhruv? All right, anyone, any other queries, guys? All right, John is asking me, we can create a new ID every year. Yes, John, you can do that, but your aim is to become a AWS solution architect, right? You don't want to practice AWS every year. You'd be learning AWS maybe in the next 3 months, and then you can become a solution architect. So why go to the trouble of creating a new ID, right? Any more questions, guys? All right, since no questions, let's jump on to our next section, which is the free tier. All right, guys, let's now discuss the AWS free tier. This is the free tier. So free tier is of two types, guys. First up is the non-expiring free tier, and the next is the introductory free tier. So what is the difference? The non-expiring free tier never expires. Like I told you guys, the free tier is valid for 1 year from the time you have signed up. But that does not apply to the non-expiring free tier. It only applies to the introductory free tier, right? So the non-expiring free tier includes services like SES, it includes services like Lambda, DynamoDB, CloudWatch. We'll talk briefly about these services in a little while. Let's talk about the introductory feature services as well. We have RDS, we have EC2, S3, and CloudFront. So let's talk about the non-expiring feature first. So we have a service called SES, which is simple email service, which I told you guys is used to send bulk emails to your customers. So you have a non-expiring feature in SES, which I'll give you the details in the next slide. Next up, we have the Lambda service. So the Lambda service is basically a serverless compute service. So it is not used to host an application unlike EC2. It is just used to run background tasks. So what are background tasks? So if you have an application, if you have image processing application and you're uploading an image to your server, and once the image gets uploaded, maybe you have to compress that image, you have to apply filters to it. So all these tasks are background tasks. It happens on the server side, right? So all of these tasks can be executed by Lambda, but this is what Lambda is all about. It cannot host your application. It can only do the background tasks. Next up, we have DynamoDB. So DynamoDB is a non-relational database management service. So it's a management service which manages NoSQL databases for you, right? So it is just like RDS. So it does the same tasks as RDS, but the difference is it manages the NoSQL database. Next up, we have CloudWatch. So CloudWatch is an all-in-one cloud monitoring tool. So we discussed in the domains how CloudWatch can be used. So yeah, that is all about it. In the introductory fee tier, we have RDS. So RDS is a relational database management service. Like I said, it is used to manage your relational databases, and it is there in the introductory fee tier. Next up, we have EC2. So EC2 is a compute service offered by AWS, which is just like a raw server, and it is there in the introductory fee tier as well. Then we have S3. So S3 is a file system which is offered by AWS, and file systems are basically used to store your executable files. So that is in the introductory free tier as well. So whatever free tier options that we are going to discuss in the next slide is going to be valid for 1 year from the time you have signed up. Then we have the CloudFront service. So CloudFront service is caching service. So what is a caching service basically? So if you are accessing a website which is say in US and you are sitting here in India, and you want to access that website will be cached to a location in India so that it becomes nearer to you, and hence the latency becomes lesser. So this is what caching service is all about, and that is what CloudFront is. So guys, any questions related to what a non-expiring free tier is and what an introductory free tier is, and any question about the services that we have just discussed? Alright, so Dhruv is asking me what is NoSQL. Alright Dhruv, so let's talk about MySQL first. So MySQL is a relational database system, right? All data that you store on MySQL is structured. So when I say structured, it can be represented in the form of a table, it can be represented in the form of a structure, right? Let's talk about your Facebook page, right? So if you were to copy everything from your wall and paste it somewhere, right, you cannot make sense out of it, right? When you can't make sense out of some data, it is called unstructured data, all right? And this unstructured data can be stored in a non-relational database, which is NoSQL. So if you have SQL for relational database, it's a MySQL. If you have SQL for unstructured data, that is NoSQL. So Dhruv, does that answer your question? All right, guys, any more questions? All right, John says no questions. Others? Theon says all well. Parvati says all clear. Alright guys, if no questions, let's move ahead. So let's talk about the introductory free tier first. So all these services are free for the first year since you have signed up, right? And these are the things which are free in this service. So let's talk about AWS EC2 first. So it offers 750 hours of free Windows or Linux T2.micro instance usage, right? EC2 offers you 750 hours every month. So basically if you are running one instance, you can run it for 750 hours. But that does not mean you can run one more instance, that is 2 instances for 750 hours each. It means you can run 750 hours in total. So if you're running 2 instances, the time gets halved. So you can run it for 375 hours each, right? So this is what AWS EC2 free tier offers you. And this free tier as well, you can only launch the T2.micro instance type. If you cannot launch any more processor or any more computing power, you can only launch the T2.micro computing power. So the next service is AWS RDS. Now in AWS RDS, you have 750 hours of free db.t2.micro instance usage. So like in case of EC2, in the case of RDS as well, if there's only one instance, you can use it for 750 hours, but if you use more than one instances, the time gets divided like that. Next up, you can use 20 GB of DB storage. So that means you can use up to 20 GB of storage free for the first year. And where can you use this storage? You can use it in either SSD or magnetic. Now what is SSD and magnetic? SSD is basically solid state drive, and magnetic is again a kind of storage. So the difference between these two storage devices is that in SSD you get high IOs, you get high input outputs, and hence higher data transfer. But in the case of magnetic, the data transfer is lower. So either ways, you get 20 GB of free storage for the first 1 year. Next up, you get 20 GB of backups free as well. So on the magnetic storage, you get 20 GB of backups. So obviously if you're using databases, you're taking backups, right? So the first 20 GBs that you'll be using, you can use it for free for the first year. Next up, you also have 10 million IOs free in AWS RDS. So for the first year, you get 10 million IOs free. So guys, any questions related to AWS EC2 and AWS RDS in terms of the free tier that it offers? All right, Theon says no questions. Others, Dhruv says all clear. John says no questions. All right, guys, so let's move ahead. Let's come on to our third service, which is AWS S3. So AWS S3 offers you 5 GB of standard storage on S3. So it means you can save up to 5 GB on S3 for the first 1 year for free. All right. You also get 20,000 GET requests and 2,000 PUT requests. So basically GET requests are those when you are accessing a file from S3, right? Maybe you're downloading a file from S3. So this downloading is one request and it's one GET request, right? So you can make 20,000 of those free, and also you can make 2,000 PUT requests, which are nothing but the uploading requests that you can make. So AWS S3 offers you 2,000 PUT requests as well. Next up, you have CloudFront. So CloudFront, like I told you guys, it's a caching service. So in CloudFront, in the form of free tier, you get 50 GB data transfer out, right? So 50 GB of data transfer out in CloudFront is free for the first 1 year. And then you have 2 million HTTP and HTTPS requests of CloudFront. So you can make 2 million requests for free in the first year, right? So guys, any questions between AWS S3 and CloudFront in terms of free tier? All right, Theon says all clear. Dhruv says no questions. Parvati says all is well. All right, guys. This brings us to the end of the introductory free tier. Let's move on to the non-expiring free tier now. So the non-expiring free tier includes all these services. So the first service is the Lambda service. So with Lambda, you get 1 million free requests per month, right? So this is a non-expiring free tier. So every month till the time you're using the AWS, you get 1 million free requests. Next up, you also get 3.2 million seconds of computing time per month. Now what is computing time? Now like I told you, Lambda is used to execute your background task, right? Now whatever time each task is taking, all that time is computed and aggregated, and if it falls between 3.2 million seconds, these seconds are free for you, right? Interesting, right? So this is the free tier that is offered by Lambda. Next up we have SES, which is simple email service. So in simple email service, you get 62,000 outbound messages per month to any recipient when you call Amazon SES. So you can send 62,000 messages per month for free. Also, you can process or receive 1,000 inbound messages for free for every month, right? So this is non-expiring. So every month you can send around 62,000 messages and you can receive 1,000 messages for free. Next up, we have DynamoDB. All right, before that, any question guys between Lambda and SES? So Dhruv is asking me, do people who don't use free tier get free tier automatically? Dhruv, any new customer which signs up on AWS has free tier activated on their account. So like I told you, like in the case of EC2, if you're using the t2.micro instance, you'll get the free tier. If you're using some other instance, you'll not get the free tier. So you have to be very careful when you're launching instances. Don't worry, we'll be launching instances in a while, and I'll show you guys how you have to be careful when you're selecting instances or which instances to launch in terms of free tier. All right, any other question, Dhruv, or any other question, guys, that you want to ask before I move further? All right, so let's move along. Next up, we have DynamoDB. DynamoDB again falls under the non-expiring free tier, and under the non-expiring free tier, you get the first 25 GB of storage for free, and you get 25 units of read capacity and 25 units of write capacity for free. Now, what is 25 units of read capacity and 25 units of write capacity? When there's a request made on DynamoDB, and say suppose you're reading from DynamoDB, and the number of requests which comes in, as the number of requests rises, the units rises. Say suppose there are 1,000 requests right now to DynamoDB and you're using say around 2 units of read capacity. As the request rises, the read capacity units also rises. Same is the case with the write as well. So you can use 25 units of write capacity and 25 units of read capacity for free in DynamoDB. All right. Let's move on to our next service, which is CloudWatch. So CloudWatch is basically a cloud monitoring tool, like I told you guys. So with CloudWatch, you get 10 Amazon CloudWatch custom metrics and 1 million API requests for free. So it's a non-expiring free tier. So these things are for free for the whole of the lifetime. Next up, you have 5 GB of log data ingestion, which means it can process up to 5 GB of log data for free, and it can also archive your log data up to 5 GB for free. Then you have 3 dashboards with up to 50 metrics each per month. So you can configure up to 50 metrics in 3 dashboards each per month. All right, so this is a non-expiring free tier, guys. So you have this kind of facility for every month in CloudWatch. So guys, any questions related to the services that we just discussed in the non-expiring free tier? All right, so Theon has a question. What is a unit in DynamoDB? All right, Theon, I'll explain you again. Like I said, you have 25 units of read capacity and 25 units of write capacity. Let's talk about read capacity. You'll understand what write capacity is. So when a request is made to DynamoDB, say around 10 requests are made to DynamoDB. So for read, right? So you're reading data from the database. Now these 10 requests will account to say a unit. So it gives an overhead to the database, right? Because you're processing requests from people. So when you're processing, you get overhead. So every 10 requests that you get on DynamoDB, say account to 1 unit. Now let's talk about 10 units. So 10 units would be like 100 requests, right? 20 units would be like 200 requests, and 25 units would be like 250 requests, right? So in a way, so this is just an example to make you understand, Theon, but that in a way you can make 250 requests in DynamoDB for free. As in, you can use 25 units of read capacity for free in DynamoDB. Now same can be applied to the write capacity as well. So if you have 10 requests for write in DynamoDB, so it gives it overhead, right? So with 10 requests for write, you're using 1 unit of write capacity, right? So with 250 requests for write, you'd be using 25 write capacity. So Theon, are we clear now with what write capacity units and read capacity units are? All right, so Theon says clear. Guys, any other question related to the non-expiring free tier? All right, everybody is giving me a go. All right, guys, so let's move ahead. So now we have learned about all the free tiers and the non-expiring free tier, right? Let's now move ahead and perform a demo. So let's look at what we are going to do. So first up, I'll teach you guys how to create an AWS account. So if you'll be creating an AWS account, obviously you'll have the free tier activated in it. And then we will launch EC2 instances using that free tier account. In these EC2 instances, we'll be launching two kind of operating systems. We'll be launching a Windows operating system, and we'll be launching an Ubuntu operating system. Why the two? Because the way you connect to the EC2 instances in the case of these two operating systems, the way of connecting is different. So you should know both the ways, and hence we are going to launch both these instances. So guys, are you excited to launch your first instance in AWS? Are we clear with what we are going to do in the demo now? All right, so Dhruv says yay. All right, Dhruv, I like your excitement. Let's move ahead and start with the demo. So first up, we'll go to the aws.amazon.com website. You'll click on create an AWS account. Now you'll click on I am a new user, enter your email ID here, and click on sign in using a secure server. Now I've already done these steps for you guys for your convenience, and I've taken screenshots. Let's go to the screenshots and it'll be better explained over there. So like I said, you'll be first going to the create an AWS account. Next up, you will click on I am a new user, and you will enter your email ID here, and you will click on I'm using a secure server later. Then you will come on the screen, you will enter your name, your email address, type it again, enter the new password, and then type it again, and then click on create account. Once you're done with that, you'll be asked for your contact information. I've hidden the contact information because I don't want you guys to stalk me. And then I'll tick this sign and click on create account and continue. Once you're done with that, you'd be asked for your card details. You can enter your card details and click on verify card and continue. Again, I've hidden the details. You would understand why. Next up, you would be asked to verify your phone number, right? In the first step, you enter your phone number and then you click on call me now. Once the call is in progress, you will be told code to enter. You'll enter that code and you'll be done with step 2. In the step 3, you can continue to select your support plan. Now these are the plans that you'll be given the option for. You have to choose the basic plan because you guys will be practicing on AWS, right? You're not a business, you're not a developer, you're actually practicing AWS. So you'll click on the basic plan and click on continue. And that is it, guys. You have successfully created your AWS account. You can click on the sign into the console button and enter your email and password and then come on to your AWS account. So once you are in your AWS account, let me show you how it will look. So you'll click on sign into console. Enter your password. And here you don't have to select I am a new user. You have to select I am a returning user and my password is whatever your password is, right? So you click on sign in using a secure server. Now this is the AWS dashboard. You can see all the services which are there in AWS on this page. Since we are going to launch an EC2 instance, we'll click on EC2 under the compute domain. Alright guys, so this is the EC2 dashboard. So you can see I have 2 running instances as of now, but since I have to launch a new instance, I'll click on launch instance. Now these are all the options that I've been given. So I have to choose, since I have to launch an Ubuntu server and a Windows server. So Windows server takes more time to get set up. So let's launch a Windows server first. So over here guys, I told you you have to be very careful, right? You have to select the t2.micro instance because this is the instance which is available in the free tier. Alright, so you'll be selecting the t2.micro instance and then shall click on next. Next up, we will be asked to fill these details. So mostly all the details are filled by default. You don't have to touch anything because you have not learned all about these things. And don't worry, you will learn about these things when we come down to the EC2 module. For now, this doesn't have to do with all your learning. You just have to see how you can launch your first instance, right? So don't touch anything here. Let it be and then click on next. Then you'll be prompted to add storage. So a minimum number of GBs will be mentioned here. So a Windows instance takes about a 30 GB minimum, so it has given that number. You can increase it if you want, but we won't be increasing because it's a demo instance, right? So let's click on next. Now you'll be asked to enter a value. So this value is basically the name that will be reflected in your EC2 dashboard, right? So you have to differentiate your instance with the other instances, right? So we will enter a name so that we can recognize this is a Windows instance. So let's give it the name Windows Demo, right? Let's now click on next. So let me launch a new security group because you guys will also be creating a new security group because it will be your new account. So let it be at the default value and click on review and launch. Alright, now this page helps you review whatever information that you have provided. So everything looks fine to me. You guys don't have to sweat. Just click on launch and you'll be prompted with this screen. So now you have to choose or create a key pair. Now what is a key pair? Key pair is basically a way for you to get authenticated to the AWS servers, right? So if you have a Windows instance running or you have an Ubuntu instance running, you will be provided with a private key and the public key will be kept with the AWS infrastructure. Now whenever you will try to connect with your Ubuntu server or your Windows server, you will be asked to present your private key. Once you present your private key, it will be matched against the public key, and if it matches, you will be authenticated. Now in no case you should be losing your private key, guys. If you lose your private key, you lose access to your instance. So it is imperative that you keep it safe somewhere and it is properly backed up in the sense that there are enough replicas with you so that if one computer crashes, you always have a copy to keep it to connect to your instance, right? So now we'll be creating a new key pair because you guys are doing it for the first time. Let me show you how to do that. The name should be unique, guys. The name is AWS demo for the key pair, and let's click, and after that you have to download the key pair. So you have got the private file now. It has the PEM extension. So this key pair is called AWS demo. So you have downloaded it and the launch instance button is now active. So you click on launch instances. So my instances are now being launched. It will take a while. Let's go back to the EC2 dashboard. Let me show you something over there. So we go to EC2. So when we entered, we had 2 running instances, but now we have 3 running instances because we have just launched a Windows server as well, right? Let's now create an Ubuntu instance because it will take time for a Windows instance to be ready. So let's create our Ubuntu instance. So first of all, you'll click on Launch Instance. You'll select the Ubuntu operating system. You have to select the t2.micro. Remember guys, don't select anything else, otherwise you'll be charged. Click on Next. Like I said, don't sweat about anything. Click on Next. So if you would have noticed, Windows servers were occupying 30 GB of minimum space, but with Ubuntu it's occupying only 8 GB, right? So it's a plus. Let's click on Next. Now you would have to give a name to your instance. Let's give it Ubuntu Demo. Same step guys, nothing is different in any operating system that you're launching in EC2. Let's click on Next. Let's create a new security group again. It is okay, review and launch. And then you can review all the details that you have entered. Let's click on launch, and there's no need of creating a new key pair again. You can choose the key pair that is just created, which was AWS demo, remember? So let's select AWS demo. You have to acknowledge that you have access to it and click on launch instances. So your instance is now being launched. It will take some while, but be patient. It will all happen in a jiffy. So let's go back to our EC2 dashboard and see our instances. So now you have 4 running instances since I've launched an Ubuntu instance as well. So let's click on the running instances and it will give you a list of all the instances running. Our instance is Windows demo and Ubuntu demo. So you can check the status over here. It's still in the initialization phase. So let's give it more time. Meanwhile, I'll tell you some properties which are attached to Windows and Ubuntu. So when you click on your instance, you can see all the details which are there attached to that instance. So you have the public IP address. So you'll be connecting to your instance using this IP address, right? So this IP address has to be kept handy. And then you can see that your instance type is t2.micro. You can check your VPC ID or the subnet ID. So everything is mentioned here. Whatever you have configured, you can see the configuration over here. All right. Same is the case with Ubuntu instance as well. This is the public IP for Ubuntu instance and the other information. Since it's taking more time, let me explain you how will you connect to a Windows instance first. So for connecting to the Windows instance, you have to make a remote desktop connection. When you launch a remote desktop connection, you'll be asked for the IP address. So just copy the IP address from the place which I just showed you, copy it and paste it over there and click on connect, right? Once you do that, it'll ask you for a username and password. So by default, the Windows instances that you launch in your AWS infrastructure will have the username administrator, and the password you can decrypt by using your public key which you have downloaded, which we'll be doing in a little while, right? But if you're connecting to an Ubuntu instance, since it's a command line operating system, you have to create an SSH connection using Putty, which is a software, right? So you'll be downloading Putty and Putty Gen. So in Putty, you cannot use the PEM file extension, which is there for your private file. So you first have to convert this PEM file extension into PPK. So that can be done using the Putty Gen software. So I will teach you guys how to do that. You will load this file in the Putty Gen and save the private file in the PPK format in the same place that you have stored your PEM file, right? Once you do that, now you will be using the Putty software. In the Putty software, you will be uploading your private file and you will be feeding in the IP address that you want to connect to. Once you connect it to the terminal, you have to enter the user. Now, any user that you create, any operating Ubuntu instance that you create on AWS will have a default user called Ubuntu. So you enter Ubuntu and you'll get connected to your Ubuntu instance, and you can use it as if it was your own Ubuntu machine. So these are the ways you get connected to your operating system in case of Windows and Ubuntu. Okay, it shows that our instances are ready now. So let's connect to our Windows instance first. So you'll click on Windows instance, click on Actions, click on Connect, click on Get Password, and now you have to upload your private file, right? So you'll choose File, go to Downloads, select the PEM file that you have downloaded. It's here. Click on Open, click on Decrypt Password. So here is the password and here is the username. Copy the password to your notepad. Alright, I've copied the password. Now I'll copy the IP address. So copy the IP address from here. Go to remote desktop connection. Enter the IP address here. Click on connect. Now you have to enter the administrator as the username, and the password would be what you have stored in your notepad. Right, click on password and paste it, and then click on OK. So if you have entered everything correctly, you will see the screen. Your server is now initializing. So guys, you can now use this server as if it was your own machine, right? So you will be prompted with the desktop, with this taskbar and everything. Now you can install anything that you want on this machine. Like I said, EC2 is just like a raw server. Now you can install any software on this system. You can configure the firewalls to do anything, and that is it. Alright guys, so this was EC2 Windows instance. Let's now connect to our Ubuntu instance. Alright, so we have our Ubuntu instance ready as well. So like I said, for connecting to the Ubuntu instance, you have different options. If you go back, if you want to try, let's click on Actions, click on Connect. So here you don't have that option for getting the password, right? It is explaining you the putty gen way of connecting. So let me show you guys how to do that. So first of all, you have to convert this PEM file to your PPK file, right? Because we entered the same key pair for our Ubuntu instance as well, right? So let's copy this PEM file to our desktop first. So let's launch our putty gen software. This is my putty gen software. Click on Run. I will load my private key over here. So it's in downloads and you have to select all files. Since it's of PEM extension, you'll select the file, click on open. So it will say successfully imported foreign key, right? Click on OK and then click on save private key. So it will ask you, are you sure you want to save this key without a passphrase to protect it? Or say yes, and then save the file in downloads again. So let's name it as AWS demo only. Since it's different extension, it can be saved in the same name. So let's click on save now. So my PPK file is now my PEM file has now been converted to PPK. Let's launch the putty software now. You will be entering your IP address over here for that Ubuntu instance. So let's copy our Ubuntu instance IP address, paste it here. And now for your authentication or your private file, you'll click on SSH, click on authentication, and then you have to browse to your private key file. So click on browse, click on downloads because this is where my PPK file is. Click on open, and this is it. Now when you click on open, it will connect to your IP address using this PPK file. Let's do that. So ignore this warning, just click on yes. So it's asking me login as, so enter Ubuntu. Like I told you guys, this is the default user for any Ubuntu instance that you launch in AWS. Hit enter. And that's it guys, you are successfully connected to your Ubuntu instance. This is your terminal. Now you can use this terminal as if you were using your own Ubuntu machine. So this is how you connect to an Ubuntu server on AWS infrastructure, right? So let's close this connection now. Go back to our presentation. So guys, we saw how we can connect to our Windows instance and our Ubuntu instance, and we also saw how you can create your own AWS account. So any questions that you have, I can repeat any part that you want. Any question guys? All right, John says all clear. Dhruv says no questions. Parvati says all well. Alright guys, if you have no questions, so let's move on to the next section, which is careers in AWS. So in this section, we'll be discussing about the AWS certifications. So let's see what all certifications are offered by AWS. So AWS offers the certifications at two levels. First level is the associate level, and the next level is the professional level. So at the associate level, you have three kind of certifications. The first one is AWS Certified Solutions Architect. You have AWS Certified Developer. You have AWS Certified SysOps Administrator. Right? At the professional level, you have AWS Certified Solutions Architect. You have AWS Certified DevOps Engineer. Now, if you want to become an AWS Certified DevOps Engineer, you have to have an associate level AWS Certified Developer or an associate level AWS Certified SysOps Administrator. But if you want to become an AWS Certified Solutions Architect, you should have a prior certification of Associate AWS Certified Solutions Architect. Alright, so guys, this is basically the kind of certifications that you have, and for the professional level, these are the prerequisites. Are we clear with the certifications and the prerequisites? Alright, Dhruv says all clear. John says all clear. Parvati says no questions. Alright guys, so let's move ahead. Okay, Theon is asking me, can you explain in detail about these certifications? Exactly, Theon, that is what my next slide is all about. So let's move on to my next slide now. So at the associate level, like I said, there are three kind of certifications. You have AWS Solution Architect, you have AWS Developer, and you have AWS SysOps. So let's understand the difference among these three certifications. The job of a solution architect is to design and deploy highly available, fault-tolerant, and cost-efficient systems on AWS infrastructure, right? So your job would be to create such architectures which are fault-tolerant, which are highly available, and are cost-efficient at the same time, right? As a solution architect, for this, you should have a core understanding of all the AWS services. If you feel a use case should come to you, an exact roadmap come to your mind of as in what AWS services should be used, and if there's a use case, as in if there's a particular problem, say suppose you have to choose between EC2 and Elastic Beanstalk, right? If you have a PHP web application and you have to choose between EC2 and Elastic Beanstalk, you would always go for Elastic Beanstalk, given that your instance should be running only one website at that time, right? So if that is the use case, you would go for Elastic Beanstalk. But if there is some other environment which is not PHP, or which is an environment which is not covered by Elastic Beanstalk, you would know you have to use EC2. In no case you would go for Lambda, because Lambda is not used for hosting an application. It is used for executing background tasks. This kind of clarity, if you have in your mind, the solution architect job is going to be more easy for you. So you have to have core understanding. When I say more easy for you, you'll actually not reach there until and unless each and every concept is clear to you. And don't worry guys, with the kind of training sessions that we have planned for you, if you go along with me, you will definitely crack the AWS exam for sure. So just keep your assignments ready in every session and keep up with the hands-on demos that we are doing. Keep on practicing them on your own and you will be set. Alright, so this was the job of solution architect, that you have to create architectures which are fault tolerant, which are highly available, and are cost efficient at the same time. Next up, we have the role of AWS developer. So for the job of AWS developer is to develop applications on this architecture. All right, so using this infrastructure which your solution architect has created, you have to create and maintain applications, right? So this is what AWS developer is all about. Next up, we have the AWS SysOps associate. So AWS SysOps associate is a guy who is basically a system administrator. He is responsible for provisioning, operating, and maintaining highly available systems on the infrastructure that you have created. So the infrastructure that the solution architect creates, right, and the applications that the AWS developer has created. Now the job of a SysOps associate is to maintain these applications and handle them on this infrastructure. So like I said, his job is more of a system administrator, and that is what AWS SysOps associate is all about. So guys, any doubts between any of the three roles that we just discussed? Let me recap. So a solution architect would create an architecture, the developer would create the applications on that architecture, and the SysOps guy would maintain and operate those applications on that infrastructure again, right? So this is how the cycle goes, and this is the difference between an AWS solution architect, an AWS developer, and an AWS SysOps associate. So guys, any difference and any question, any of these roles that we just discussed? All right, John says all clear. Dhruv says no questions. Parvati says all clear. Theon is clear as well. Okay guys, any question that you get between any part of my explanation, please pop up the question. I shall be happy to explain it to you. Alright, let's move on to our professional certifications now. So the professional certifications are two. One is the AWS Solutions Architect Professional and one is the AWS DevOps Engineer Professional. Like I said, if you want to become an AWS Solution Architect Professional, you have to have an AWS Solution Architect Associate certification first, right? Then only you can go and apply for an AWS Solution Architect Professional exam. Now this role is the pinnacle of all AWS certifications. With Solution Architect Professional, you move to the next level of solution architects, okay? You are now more experienced and hence you can handle more complex architectures and hence you become a professional. So if you are in a company, you'll be managing the associate solution architects, and since you are the professional, you'll be the one who will be managing them. You'll be the manager of those solution architects. So it's basically like a promotion to the next level, right? So this is what AWS Solution Architect Professional is all about. Let's move on to the next role, that is AWS DevOps Engineer Professional. So let's talk about AWS DevOps Engineer. So DevOps is a relatively new term in the software development industry, right? It's a culture which is being picked up and is very fast in the development world. You can relate it to agile development, but if we start discussing DevOps, it would totally take us in the wrong direction. We won't want to do that. So therefore, we will discuss about AWS DevOps Engineer in our next session, which is all about AWS certifications. I will explain to you what each role does and what DevOps engineer role is. But the prerequisites of DevOps are pretty clear, which I explained to you. So for becoming an AWS DevOps engineer, you should either be a SysOps Associate certification holder or an AWS Developer certification holder. Then only you will be able to write the exam for DevOps engineer. So guys, any questions in the professional certifications apart from AWS DevOps engineer, which we are going to discuss in our next session? Now John is asking me, didn't we apply for solution architect? Yes, John, you did, but it's always good to know what all other certifications are out there and what next level it is for you, right? You have applied for solutions architect associate certification. The next level for you is a solution architect professional. So you should know what your career path is going to be in the next 2 or 3 years. And that is the reason we have explained these certifications for you. And it's always good to know about all the certifications that AWS has to offer, so that if you change your mind about maybe your career path tomorrow, you would know what to go for, right? Any more questions, guys? All right, so Dhruv says no questions. John says all well. Theon says no question. Parvati says all set. All right, guys, so let's move ahead. So like John pointed out, you guys are here for the solution architect role. So let's discuss in detail about the solution architect role now, right? So as a solution architect, these will be your responsibilities. These are the roles and responsibilities that you'll be carrying out every day. So your job will be to create highly available and scalable systems. So when I say highly available, your application should be available at all times of the day. You should architect in such a way, or your environment should be architected in such a way that your application gets all the resources to be available at all the time, right? Next up, your job will be to implement and deploy in AWS. So you will be deploying services, you'll be implementing architectures, right? So you are responsible for that as well. Now, next up, you should be able to make a decision and select the right AWS service according to the use case or according to the requirement which comes up to you. And that can only be achieved if you are clear with your concept on all the AWS services. So like I said, you have to be clear with each and every service that we are going to cover in our training session. I will make sure that each and every service is clear, and also I will hand out to you assignments so that you can evaluate yourself as well. right? And don't forget the hands-on part, guys. I'm repeating again and again, hands-on is very important because that is the way you learn. Let's move on to the next role, which is disaster recovery techniques. So next up is you should be proficient with all the disaster recovery techniques. So there could be an earthquake, there could be a power failure, right? So you should be able to make decisions in times like these, or you should have a system ready for times like these, so that if a system fails because of any disaster occurrence, your system should be able to fail over to the backup system that you have set up, right? So as a solution architect, it is your job to set up those backup systems, right? The fifth role is to make use of all AWS architectural best practices. Now, AWS architectural best practices are published on the AWS website, right? Best practices have actually been provided by AWS, keeping in mind how they have made their environment or how they have made their infrastructure, right? So if you follow these best practices, these have also come out of the experience that AWS solution architects have put in, right? So since AWS exists since 2006, so solutions architects have also been around since the same time. So with their experience, they've learned a lot of things and they have come up with best practices that you guys should follow. Since you guys are newbies, when we talk about solution architect or architecting a solution, you should always follow the best practices without asking any questions. All right, guys, so these are the roles and responsibilities of a solution architect. Are we clear with each and every role over here? Any questions so far? Anything you want me to repeat? Anything you didn't understand, guys? All right, guys, you guys are giving me a go. All right, let's move ahead then. Next up, let's discuss about the jobs, because ultimately you are doing this certification to get a job as a solution architect, right? So let's look at the jobs. So in 2012, you can see the graph, and after that, the growth has been exponential, right? Since 2012 to 2016 and still going on, the growth has been increasing. The demand has been increasing for solution architect, and I can tell from my experience as well that it will be increasing furthermore, because the demand for cloud computing is increasing at a rate that you cannot imagine right now, because every company today is making a move to the cloud. Because obviously if you're starting a startup, you have less risks, you have everything in the cloud because you don't have to buy anything, right? Keeping that in mind, every new company which is coming up today is trying to make a move to the cloud. And because of this, the cloud industry is increasing, the cloud industry is expanding, and since AWS holds a major chunk in the cloud computing market share, AWS is bound to grow again, right? And if AWS grows, the requirement for solution architect also grows, right? So it's good for you guys as well. So this graph is going to go up in the future as well. So guys, any questions so far regarding the solution architect role? Everybody seems happy to look at the graph. Okay guys, let's move ahead. So our next section is about AWS competitors. So you guys know the cloud computing industry is very big, right? So it is bound to have a lot of competition. So AWS also has a lot of competition. So these are the competitors which are competing with AWS. You have Rackspace, you have DigitalOcean, you have Joint, you have Microsoft Azure, you have Google Cloud Platform, VMware, IBM Cloud, right? So these are all the competitors are closely aligned with AWS success path. Now, the AWS would be very modest if they say they are closely aligned with their growth, because AWS is leading by a very large number. What number? Let's look at that. So let's look at the market demand for AWS. If we talk about the global cloud computing market share, so AWS alone has a share of 31% compared to its other cloud providers, which is 69%, which now will you say that 69% is greater than 31%? What's the big deal? But you have to understand that AWS alone has a share of 31% of market share. No other cloud provider is even near to what AWS market share is right now. And that is the reason that AWS is still a leader, right? Let's talk about server capacity. This number will blow your mind. All of its competitors combined, let's imagine they have a server capacity of X. AWS alone has a server capacity of 6X, which is 6 times the server capacity of all of its competitors combined. Guys, this is a huge number, Right? Imagine yourself as a client. You have a very successful application that you have been hosting on your own private data centers. Now you know that your application is successful, and you know that your application will be more successful in the coming years, right? If you were to make a move to the cloud, which cloud provider will you choose? Wouldn't you choose AWS, which has 6 times the server capacity of all its competitors combined? Your application can easily grow on that kind of infrastructure. So it would be a safe bet to make a move on AWS, and that is the reason that people still believe in AWS and why AWS is still a leader in the market. But these are all current statistics. This doesn't mean that the times will not change. Maybe 4 years or 5 years down the line, Azure will also come up at par with AWS. But if we see the current scene, AWS is the cloud provider right now. There is no one who can touch AWS, and that is the reason that we are talking about AWS today. That is the reason I'm teaching you guys about AWS, and that is the reason that you guys want to become solution architects for AWS. So guys, any doubt regarding why are we learning AWS today, or why you guys chose to become solution architects? I mean, although it's too late, but then if you had doubts, are we clear with the doubts now? All right, Dhruv says no doubt. John says all clear. Parvati says thank you. You're welcome, Parvati. All right. Okay guys, so this brings us to the end of our session. Let's recap what all we did today. So we learned what is AWS, and then we saw the different domains which are there in AWS. Then we discussed the AWS certifications, followed by the AWS free tier. And then we also saw a demo where we launched an Ubuntu instance and a Microsoft Windows instance as well. Then we took a look at AWS competitors. We saw all the competitors, and we saw how AWS is leading them. Right? So guys, any doubt in any of this part, I can explain it again, no issues. Anything you didn't understand throughout the session. All right, John says everything is clear. Thank you. You're welcome, John. Parvati says all well. All right, guys, if you don't have any other questions, shall we wrap up this session? All right, guys, so thank you for attending this session today. I hope you guys learned something new. I'll be handing out the assignments in your LMS. Please complete your assignments and come back in the session. Please practice the hands-on part. Again, I'm telling you guys, it's very important that you practice the hands-on. If you have any problems, you can always contact our support team. They are available for you 24/7. So thank you guys for attending today's session. See you in the next session. Have a good day.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!
Good morning everyone, and welcome you to your Amazon Cloud webinar today. The agenda for today's session is going to be, we'll be covering what is cloud computing, followed by the different service models which are available within cloud computing. And then we'll also discuss about the deployment model that you can choose in case if you want to move your workload over to the cloud, what are the strategies that you should adopt and what are the different deployment models that you can go ahead with. And then we'll talk about what is AWS. We'll give you an introduction of AWS Cloud and why it is the #1 infrastructure as a service cloud in the market. Then followed by the service models which are available within AWS Cloud and what are the deployment models that you can choose in AWS as well. Then last, we have planned a quick demo for you guys as well, in which we'll launch an Elastic Beanstalk application and we'll show you how those, how your application interact with your database. So primarily the agenda of this particular demo is to show you that how various components interact with each other and how you can create your own private environment within AWS and make it more secure. So we'll deploy 2 different application environment. So one, we will try to connect with the RDS instance or the database instance which is in the same environment, and the second application will try and deploy it in a separate VPC and see whether it connects or not. So primarily just to show you the security options which are available in AWS to to deploy your applications. Then lastly, we'll talk about the use cases as well. What are the different use cases that you can adopt and how you can move. So what is cloud computing? So we have heard this term quite a number of times. So primarily it is the use of servers which are deployed not in your local data center, but primarily it is deployed in some other data centers. We can also call them as remote servers, and you can connect to those data center environment, or you can connect to those servers using internet. So it is a use of remote servers on the internet to store, manage, and process your data rather than a local server or your personal computer. So the servers that you're going to deploy in the remote data center or the cloud environment, you can use it for any purpose which is feasible for you. So either you're using it for storing some business critical information, or you want to manage some of the processes in the cloud environment, or you want to process some business critical data or test or development data in the cloud rather than keeping it local within your data center or your personal computer. So whenever you are not keeping everything local and you are storing or managing or keeping your data outside of your local data center, so that term can be used as cloud computing. Of course, there are different variables within cloud computing as well. So in case if some private company is hosting your infrastructure in their particular data center, so that will fall under private cloud. In case if you are deploying it in your public data center, so public means the companies who are hosting data from multiple companies and they are keeping it, you can access this data over the internet, so that will become your public clouds. So what are the different service models which are available within cloud computing? So primarily there are three different variants which are available in cloud computing. They are infrastructure as a service, they are platform as a service, and software as a service. So these three models are the prevalent in the market. Of course, if you will research a little bit more on these topics, you will find out that most of the cloud companies they are also coming up with their own versions or their own iterations of as a service model. So anything which is not infrastructure, which is not platform, which is not software, we normally term it as X as a service. So depending upon what service those providers are trying to create. Primarily, there are three different types of models which are available, which is infrastructure as a service, platform as a service, and software as a service. In infrastructure as a service, any computing provider or cloud computing provider who is providing you this service, they will provide you virtualized compute resources over the internet. So all those computing resources or servers or instances will be deployed in their data center. And of course, you can choose to have your own physical servers as well. But most importantly, the reason why you're going to the cloud is to cut down the cost. And in that case, you will normally be using virtual machines or virtual server instances. So they will provide you virtual compute resources over the internet, and you do not need to worry about any of the underlying physical machines, because you have been provided virtual machine as a service in this case, or compute instance as a service. You do not need to worry about what the underlying physical host is doing, how it is connecting, whether it has the required capacity or not. Basically abstracts the users from the physical machine. So all you have is a virtual machine. You will always treat that virtual machine as your physical machine, and you will deploy your resources on that VM instance as if it is a physical machine lying in your local data center. The only thing which is changing is, rather than connecting it locally, you are connecting it remotely over the internet using different utilities that we have, like RDP, SSH, or for that matter some third-party tools as well. When it comes to platform as a service, it will give you a runtime environment. So let me go back on infrastructure as a service. Primarily in infrastructure as a service. So what is infrastructure? Your compute, your storage, your networking, your databases. All of these are abstract resources that you can combine and create your own application environment. So for example, you can pick and choose whether you want to deploy, a very simple example, whether you want to deploy a WordPress website on a single instance, or you want to deploy a highly available, scalable, and secure WordPress website. In that case, you can choose different tiers. So you will have your web tier where your web servers are sitting, and then you will have your database tier where you will be deploying your separate databases. So you're separating your database from your server instances. So depending upon the environment that you want to use, depending upon the budget that you have, and depending upon how critical that application or your website is, you can pick and choose what services you want, and you can create your own architecture using infrastructure as a service model. So it gives you complete freedom in terms of what resources you can pick, what resources you can use, and how you want to design your application. But when we talk about platform as a service, in platform as a service, you do not have any control over the underlying architecture. Of course, you will have control of the resources that are going that will be deployed under platform as a service, but the architecture will always be same. platform as a service model is primarily, targeted for developer community. So for example, if any developer who want to deploy a PHP application, or for that matter Node.js application or Java application and so on, every time they have to go through the same step, that they will create a web server, they will deploy PHP, they will deploy MySQL server, they will deploy your PHP runtime environment, they will deploy your Apache web servers and so on. So all these things are repetitive in nature, and for each and every PHP environment you would need these things again and again. So what these cloud computing providers are doing, so that they are giving you this environment as a service, so we can call it as platform as a service. So you have a PHP platform, you have a Java platform, you have a Node.js platform and so on. So the moment you select that I want to deploy the Node.js application or a PHP application, the underlying architecture will automatically be selected for you. All you have to do is upload your application code, and then the underlying architecture in terms of, for example, your web servers, your database servers, your security groups, your VPC, etc. Everything will be deployed automatically by these providers. So it helps you in increasing your developer productivity, and it helps you in achieving in go-to-market scenario where you want to deploy your application and you want to make them live very quickly. The cloud providers in this case gives the ability to the customer to deploy your applications using programming languages or tools that are provided by the cloud provider. So you cannot change the underlying architecture. That's the key word which is associated with the platform as a service, that every time you will deploy this application, every time you will get the same architecture. You cannot change the architecture. Whereas if we talk about software as a service, it goes even a step ahead. Your cloud provider in this case will also deploy the application onto their environment. So apart from the infrastructure, including your compute, your networking, security, databases, etc., they will also deploy the runtime environment, which is usually associated with platform as a service. So in terms of creating a web servers, creating deploying your Apache, PHP, etc. And then on top of it, they're also deploying their application. So the perfect example I can give for software as a service is, for example, Salesforce.com. They have their own cloud, and they are providing their CRM application directly from their cloud environment. The drawback is that you do not have any control on any of the architecture of application, any architecture on the infrastructure, or any architecture of your platform as well. You are getting that software as a service, and in fact the data, which is your data, is also be stored in the cloud provider. So your cloud provider will be responsible for managing your data. So your data is not going to stay locally in your environment. That data will also be stored in the software as a service cloud provider. Examples of, apart from Salesforce, other examples that I can think of is, so you have, for example, Microsoft Exchange as a service now. You have Office 365, where all of your Office tools are being run in the cloud environment, and everything that you are doing in your emails, etc., they are all stored in the Microsoft Cloud itself. Then moving on, we also have, so apart from the services model, so again, just to recap, we have three types of service model: infrastructure as a service, platform as a service, and software as a service. Now moving on, we have three types of deployment models. We have public cloud, private cloud, and hybrid cloud. A service provider will always make the resources such as application storage, networking, etc., available to the general public over the internet. It is very, very easy and inexpensive setup, because any underlying infrastructure like hardware, application, bandwidth, etc., they will be covered by the provider, and there will be no wasted resources, because normally you will pay for what you use. So that's your public cloud. Primarily, you will deploy your environment in public cloud because you want to save your cost and you want to bring your IT budget lower, right? So every public cloud provider, so we have multiple public cloud providers which are available. So AWS is the leader in that segment, followed closely by Microsoft Azure. Then we have Google Cloud, which is really coming up nicely. Apart from it, there are a lot of other players like Rackspace, Box. There is a cloud from VMware as well. So there are a lot of other entrants in the market, but primarily your public cloud is, whenever you talk about public cloud, primarily you will hear about three public clouds. They are AWS, Azure, and Google. Now, in this public cloud environment, as I said, any of your resources will be deployed on to your public cloud provider environment, and you will access those resources over the internet. Any cloud provider that we talk about, they will always, you will always have pay-as-you-go model for most of the services. There is no upfront cost associated with any of the resources. If you want to deploy a server instance, you can just go ahead and deploy the server instances, and then you can start paying in the monthly billing. Now, of course, there are some variations in terms of pricing as well. So, for example, your AWS cloud, they bill your server instances based on per hour usage. Then you have Microsoft cloud that I think bill you on per minute usage. Then you have Google cloud, which gives you sub-second billing as well. Everybody has their own variations of pricing, but the main focus here is that everybody is giving you an option to pay for what you use. And this applies to not only compute instances, this applies to primarily most of the services that they have. But whether we are talking about platform as a service, whether we are talking about your database instances, whether we are talking about storage, all this you will only pay for what you use. Whereas if we talk about private cloud, so what are the examples of private cloud? So companies like HCL, your companies like Wipro, companies like TCS, companies like IBM, companies like CSC, companies like Rackspace, Fujitsu, all of these companies, they also have their own data center as well, which they normally own and operate. Either they own those data center or they lease it from some third party, but they run that data center on their own. So in case if you want to deploy your infrastructure in their data centers, so that becomes, for you, it is still a cloud because you are not deploying it locally in your environment, but you are keeping it in some other data center environment. So that becomes a private cloud environment in this case. All the private cloud providers, they offer hosting services to only a limited number of people behind firewall. So it minimizes the security concerns. Private cloud, it also gives the enterprise or companies direct control of their data because you can manage or you can decide what architecture that you want. You can decide whether I want to keep it in one rack, whether I want to keep it in multiple racks. You can decide where exactly I want to deploy my environment. So you will only choose. So let's say that you are a company working in EMEA region and you want that my data center should only be deployed in, let's say, Frankfurt region. So you will only pick the private cloud companies who have data centers in Frankfurt region only. So you get to decide where you want to deploy. Compare it with public cloud providers. They normally have listed out their data center that we have data centers only in these locations. And apart from it, even if your requirement is to deploy it somewhere else, you do not get that option. Whereas in private cloud, you will select the company whose data center is probably where you want them to be. But keep in mind that with private cloud companies, cost is usually more than the public hosting cloud providers. They offer leasing services most of the time, but of course that leasing services comes at a premium. And in most cases, your private cloud companies, there is some kind of upfront cost associated with it. That upfront cost can be in terms of purchasing new equipments for you. That upfront cost can be in terms of transitioning your resources. That upfront cost can be setting up your internet connectivity or setting up your MPLS or IPsec connectivity and so on. And you will pay for each and every element that you're using. So that you may have to pay for the rack spaces, you may have to pay for the power cooling charges, etc. And you will also have to pay for the data that you want to deploy or migrate from your location to the private cloud environment as well. So in terms of pricing, definitely it comes a lot expensive, but it gives you the freedom to decide your own architecture. So you may want that my web tail should have a separate firewall, your applications environment should have a separate firewall, and your database should have a separate firewall, as well as IDS and IPS requirement. So you can pick and choose, or you can decide what architecture you want, and your cloud companies will oblige in terms of what architecture that you are looking for. The last environment that we want to discuss is the hybrid cloud environment. So as the name implies, so companies who are making use of both the cloud environments, you have your public cloud environment as well as your private cloud environment. If you are making use of both those environments, then it becomes a hybrid cloud. So this is a cloud computing environment which uses a mix of on-prem, private cloud, third party, or public cloud. So it is not just private cloud as well as public cloud. Even if you are keeping some, so typically any company that you talk to, the way they start off with public cloud is they do not move all their workload onto the public cloud immediately. They always start low and slow and items which are non-critical in nature. So typically they will always start with moving their dev and test environment onto the public cloud. And once they get hand and feet dirty, and it's they're more familiar with public cloud environment and they're more confident on public cloud environment, then only slowly and gradually they start moving their business critical applications as well. Now, in terms of keeping your business critical application, you have multiple options. One, you can keep your business critical application within your own data center or within your own locations. We normally call it as on-prem locations or on-premises location. Or you can, you don't want to manage the data centers on your own, then you can use some private cloud companies and you can host your business critical application in those environments. Or probably you're using some third-party leasing services where the data center is being leased by someone else, but you are managing the entire data center operations on your own. So all this, whenever we have mix of these environment, whenever we have mix of public as well as private or on-prem or third-party, we call it as a hybrid cloud environment. Why any company would want to go for hybrid environment? Because it gives you best of both worlds. By moving your dev and test environment on the public cloud environment, you are bringing your IT budgets low. It gives you more flexibility, it gives you more scalability, it increases your speed of go-to-market since you can develop and test your applications very quickly on the public cloud environment. But by keeping your business critical applications or your production environment onto your on-prem versus or your private cloud environment, you're making sure that you are following the architecture that you want to follow, and you're keeping your environment more secure. So rather than connecting your production environment over internet, you are connecting to your private cloud environment using some more advanced security features like IPsec, VPN, and so on. However, all these features are now available on public cloud environment as well. You can extend your own connectivity to public cloud environment. You can have your own private connectivity to your cloud environment as well. But still, there are companies who are kind of cynical about security and they don't want to deploy their environment on public cloud providers. So they can follow the model of hybrid cloud model, which is giving them the benefit of price reduction and everything for their dev and test environment, whereas still keeping the security environment in their private cloud environment. All right, so let's talk a little bit about what is AWS. So AWS is a secure cloud service platform offering compute, database, storage, content delivery, and other functionalities, which helps to keep your business, which helps in businesses to scale and grow. So this is a public cloud provider that we are talking about. But as I said, that most of the cloud providers, they also have all the features which are closely aligned with your private cloud as well. So let's take a look at what AWS is and what are the different service models and deployment models that you can adopt in AWS as well. In terms of service model, so typically you can use your AWS service cloud either as a public cloud or as a hybrid cloud as well. So public cloud, when you are deploying all your environment, your dev and test environment on on AWS, so this becomes your public cloud. In case if you're keeping your business critical applications on-prem and you're using your dev and test environment on AWS, so then you're following the model of hybrid cloud. Of course, AWS is not a private cloud. It cannot be a private cloud. You cannot decide where you want to deploy your infrastructure. I mean, of course, there are regions, availability zones available for you to choose, but still the architecture, or you do not have underlying excess of the architecture that you can do. So there are some designs limitations in terms of what you can or what you cannot do on AWS. So it is not your private cloud environment. In terms of deployment models, primarily, so this is one area where there is a lot of confusion, and students do get confused on whether AWS is an infrastructure as a service model, platform as a service model, or a software as a service model. Whenever you look at the Gartner report for cloud companies, the Gartner report always say that your AWS is a infrastructure as a service model. Why? Pretty simple, that you can go into AWS console, you can pick which resources you want. Maybe you want to deploy it on one server instance, or maybe you want to deploy multiple server instances. Maybe you want to deploy a database instance and so on. So you can pick and choose the environment or the infrastructure variables that you want. So this fits the category of infrastructure as a service model. Whereas there are some services which are available within AWS, and in fact we have planned our demo today for that as well, which fits the category or the definition of platform as a service as well. So for example, there is a service called Elastic Beanstalk, where you can just go and select the runtime environment that you're looking for. So maybe you want to deploy a Java application, PHP application, Docker, Go, Python, etc. So you can select the runtime environment, it will automatically select the underlying architecture for those environment. All you have to do is upload your PHP or your Java or your Go or your Python applications, and it will automatically deploy the underlying environment or underlying architecture. So this fits the definition and category of platform as a service model as well. Thirdly, software as a service model says that you can all your application, even your application will be deployed in the cloud, and you will just get your application as a service. There are numerous companies which are available in the market who are deploying their software on AWS, and they are offering that software as a service to their end customer, right? So example that I can give you is, for example, there is a service called Microsoft Workspace in AWS. So Workspace is nothing but your dynamic desktop in the cloud. Now all your data will be stored in the cloud. Each and every client who opts for this service, they will get the same look and feel of that application. In this case, the application we are talking about is a dynamic desktop. Similarly, you can have your other applications. So for example, you can deploy your, let's say, Exchange in the cloud or your Active Directory in the cloud. So all these things will come under the category of software as a service model. So your AWS model can be equivalent to an infrastructure as a service, platform as a service, as well as software as a service model. But if we look at the report, or if we look at the Gartner report, typically your AWS is infrastructure as a service model, but there are some services which will fit into the category or definition of platform as a service and software as a service as well. So keep in mind going forward, whenever someone says that AWS is only infrastructure as a service model, so you can give those definitions or examples of the services that can fit into the category of PaaS and SaaS as well. All right, so AWS is an infrastructure as a service because it provides infrastructure in the form of its AWS services. So things like EC2, RDS, VPC, S3, EBS, and so on. So all this is infrastructure as a service. Platform as a service. So I gave you an example of Elastic Beanstalk. So again, with Beanstalk, you can focus on the deployment part or the development part of your application. All you have to do is select the runtime environment, and then you upload your code, and everything underlying will be deployed by the Elastic Beanstalk itself. So this fits the category and definition of platform as a service. So as I said, AWS is not a software as a service in itself, but there is a marketplace in AWS where you can discover and subscribe to dozens. In fact, there are thousands of applications which are available on AWS marketplace. So typically those applications will be in the form of AMI. Okay, so this brings to our demo part, that how do different services interact in the Amazon cloud. So in AWS, you can use various services which work together to form an application. But how do those services interact with each other? So typically you will always create a VPC in your AWS cloud environment. So using that VPC, you can control which particular instances that you are going to deploy in that VPC will have access to the internet, or which can be accessed from the internet, which instances will be able to talk to each other, and how you can isolate your resources from the rest of your AWS. So the demo that we are going to show you is, we will be deploying a very simple PHP application which will connect to a database instance. In this case, we will be using an RDS instance for this. And what we'll do is, initially we will deploy our database instance. We'll deploy our RDS instance in one VPC. Then we'll create that Elastic Beanstalk application in same VPC and see whether they connect to each other. And then we'll create another Elastic Beanstalk application, this time deploying it in a separate VPC, and then we'll see whether it can connect to that RDS instance or not. So we are trying to show you that when you create a VPC, or when you create separate VPCs, the resources within those VPCs do not talk to each other by default. Of course, you can make them talk to each other, but for that you will have to open some security configuration so that they can talk to each other. But the very definition of VPC is that it offers you segmentation within your public cloud. So you can create your own private environment within the public cloud, and those environments will be isolated from each other. All right, so let's go for a quick demo. In interest of time, what I've done is, I have already deployed this MySQL database instance. So just to show you the steps that we have done, so all you will have to do is click on launch a database instance. Select the MySQL database instance. Make sure you stay with the free tier account. click on select just for testing purpose. So we are going to do it at dev and test. The only difference between dev and production environment is that this gives you option of multi-agent deployment. You can use that multi-agent deployment feature over here as well. But dev and test environment you can primarily be using for single instance. Then you'll select the general public license, which database version that you want to choose. Select the instance class. So T2 micro is the one which is covered under free tier micro. If I choose anyone else, even for example T2 small, so it will give me this this small little warning box which will say that this is not covered under free tier. So if you want to stay within free tier, you need to select T2 micro. This is the feature that I was talking about, the only feature which differentiates whether you want to deploy in production or whether you want to deploy in dev and test. If you select on yes, so it will deploy 2 database instances, one in each availability zone. If primary database instance goes down, it will automatically switch to the secondary database instance. So this is primarily your high availability requirement. So we're going to say no. Storage type, so there are multiple storage types available. You have general purpose SSD, provisioned IOPS, and magnetic. Magnetic is the cheapest one, but it gives you very low IO. Your general purpose gives you 3 IOPS per GB, so and you can burst up to 10,000 IOPS in general purpose SSD. In case if you want more than 10,000 IOPS, then in that case you will have to select the provisioned IOPS. For provisioned IOPS, you will have to go for minimum 100 GB storage. If I select 50 GB, it will give me an error that I need to select minimum 100 GB. So I will stick to the general purpose one, select maybe 5 or 8 GB since it's just for testing purposes. Then you will have to configure your database instance. So this is the name of your database instance, then your username, your password, and so on. So typically if you deploy it, it normally will take anywhere between 7 to 10 minutes to deploy that RDS instance. So in interest of time, I have already deployed it. So we'll show you that instance that we have deployed. So this is the database instance that we have deployed. So as you can see, we are using T2 micro SSD 5 GB, and then this is the name of the database instance. This is the username. Then we have the password. We have configured a security group. So quickly show you the security group as well. In this particular security group, we have enabled SSH traffic and your MySQL Aurora traffic. I have only enabled this MySQL traffic from my IP so that I can access this database instance. And secondly, I have allowed it from WebDMZ security group. So there is another security group that we have configured, WebDMZ, which is primarily taking all your traffic from the internet on port number 80 and 443. So what we are trying to do over here is that we are launching our web server. So in this case, our web servers will be launched by the Elastic Beanstalk application, but that web servers will take traffic from the internet, and we are allowing your database traffic only from that particular security group which has your web servers. All right. So this is already done. It is available. Now let me go to Elastic Beanstalk. So you can click on services and go to Elastic Beanstalk. Make sure that you are in the same region. So I'm in North Virginia region. Again, in interest of time, I have already deployed both the application, but just to show you the step, you can click on create a new application, type new whatever name that you want to give, click on create, and then you will have to create the environment. In this case, select the web server environment. Here you will have to select. So I have the application. Let me show you the PHP application that I'm going to deploy. So this is the PHP application that I have. It's a very simple PHP application. We have a form which is taking some kind of input, and that input will be stored in the database. We have the username. So this is our RDS instance DNS name. So this is the RDS instance DNS name or the endpoint where we want to connect. Then you have the username, password, and the database name. Then we have a table within this database name which is called image. Okay, and the connection string is saying that if you connect, then it will show you this form where you can enter anything and it will directly be deployed or directly be stored into the database table. If you are not able to connect, it will die saying that unable to connect to the database. Okay, so again, just to show you the steps, you select the PHP application. This is the environment that we are going to select. you select upload your code and click on upload, and then select the index.php. Make sure whenever you are uploading any application on Elastic Beanstalk, you upload a zip file of it. So this is the zip file that I want to upload. Okay, click upload, and then you can go into configure more options, and this is where you can select which instance I want to use. So maybe you want to use the T2 micro, which is covered under free tier. Okay, maybe you want to change the security groups, or you want to change the VPC. So by default, if you do not select this VPC, it will automatically deploy in the default VPC. I have created two VPC. So one is the default VPC. I have created another VPC, which is a new VPC. You can select which particular availability zone your instances will be deployed, and you can select the security group on these VPCs as well. So I have already done that because it will take around 7 to 10 minutes to deploy an Elastic Beanstalk application as well. So the first environment that I have selected, in that environment I'm selected the main VPC or the default VPC, and in that I have launched my Elastic Beanstalk application in a web DMZ. Okay, once you do that in your databases, so we are not going to select anything because our PHP application is automatically connecting to the database. So let's click on cancel here, and let's go back to the previous environment. So this is your first environment. Okay, if you want to see the configuration, you will see it is a single instance, T2 micro instance. Then you have your VPC environment, in which I am using the main VPC, and I have selected all the subnets. So in case if I want to deploy in any of those subnets. Okay, and lastly, in terms of database, I have not used any database because my PHP application is automatically connecting to the database. Now this application, as you can see, is already deployed. Okay, so once you click on that application, it will give you the URL. So you click on this URL, and it is this PHP application is asking for the form. So if I want to give the name, so maybe I want to add this record. First of all, let's see the database table. So for that, I'm using the utility called MySQL Workbench. With this utility, I can connect to the RDS database instance and see what are the tables inside it. So the database instance is test database instance that I have included in my PHP application. Within that, there is a table called image. If I run this query, select star from image, it is showing 3 rows as of now. I'm gonna add one more record in this. Let's see if this record is getting added. Let's run this query. It is running this query on the database, and as you can see, it has added some more records as well. So I may have added some more records in the past, so it is showing you 6 rows as of now. If you run it one more time, you will see the number of records are 6. Let me add one more. So this is demo lab, and it will add another records to the rows as well. Okay, so this is working. Now let me close this particular one. Then I have deployed another application, which is my Beanstalk 2. Now what I did in this application is, rather than keeping it in the same VPC, this time I have deployed it in a separate VPC. So if you see in the VPC section, I have deployed 2 VPC. One is the custom VPC, the default VPC, and one is the new VPC that I have deployed for testing purpose. In this particular application, as you can see, I have only selected 2 subnets. Okay, so that my application will be deployed in this. I'm using a T1 micro in this. I should have used the T2 micro to stay within free tier. Okay, now if I select this particular environment, let's see if I'm able to connect to the database instance or not. Because my security group that I have configured for my RDS or database instance, that security group is only allowing traffic from the security group of my previous VPC that I have configured, or the default VPC. That's why it was allowing connection from the previous Elastic Beanstalk application. But since now it is taking connection from the outside of this VPC, which is not covered under this security group, it will not allow it to connect. So as you can see, it is still not connecting. It will try for some time, and after that it will display the message that unable to connect to that particular database. Okay, so it will try a couple of times, and after some time it will show you display the message unable to connect to the database, please try again later. So that's our PHP application, the way we have configured it. All right, let's wait for a moment. In the meantime, if there are any more questions from anyone, we can take. All right, so let's continue with our slides. And as you can see, it has already shown you unable to connect to the database, please try again later. So it will not allow you to connect. So this is where your security is coming into picture when you deploy your resources in separate VPCs. By default, they will not allow you to connect the instances or connect the resources to each other. Okay, so primarily the use case for the VPC is to segment your infrastructure or segment your environment within the public cloud. It is used as primarily for making sure that you are, keeping your environment secure. The second use for the VPC is in case if you want to extend your current data center environment to the cloud in terms of what IP addresses that you're using. If you want to follow the same IP schema in your cloud environment as well, then you can create your custom VPC and you can use the same IP address schema that you're using in your private environment, and you can continue to use the private IP addresses to talk to your instances or your resources which are sitting in AWS. Of course, for that you need to have some kind of private connectivity between your data center environment and AWS environment as well. So you can use direct connect and use MPLS or lease line or IPsec connectivity to talk to those instances as well. All right, so let's do a quick recap of our session. So what we did, so first of all, we started off with a definition of what is cloud computing. So primarily, the very definition of cloud computing is when you are deploying your servers or your storage or your resources outside of your local environment, then you are using the cloud computing services. Initially, we used to call it as a hosting environment, but now it is called cloud computing environment. In terms of service models, so there are three types of service models, which is infrastructure as a service, platform as a service, and SaaS, software as a service. We called it as IaaS, PaaS, and SaaS. In infrastructure as a service, you can pick and choose the infrastructure and you can create your own architecture that you want. In platform as a service, primarily the underlying architecture is predefined or pre-populated for you. You can just go ahead and deploy your application. Even the underlying runtime environment in terms of whether you need an Apache server, PHP, or any dependencies for that matter are already taken care by you. Primarily targeted for developer community who can just go ahead and deploy and develop their applications on Elastic Beanstalk. Software as a service, when even the software that you want to deploy is already pre-deployed on your compute instances or on your cloud computing. The example that I gave you was Salesforce.com, who has their own software as a service cloud in which they give you CRM, their CRM application as a service. In terms of deployment model, there are three types of deployment model: public, private, and hosted. Public, in case if you are going at with the famous cloud providers like AWS, Google, Azure, and so on. Private, when you're using either some of the big companies like this TCS, Wipro, IBM, Dell, HP, CSC, etc., or when you are using some other hosting companies to deploy your infrastructure. For that matter, you can also have your own on-prem environment as well. That is also be considered as a private cloud. And the third deployment model is hybrid cloud. When you are using a combination of public as well as private cloud, that's called a hybrid cloud environment. Most of the companies will always have hybrid cloud environment with business critical applications running in private cloud and the dev and test environment or non-critical applications running in public cloud. In terms of service model for AWS, so I gave you a definition that AWS is mainly an infrastructure as a service model, but there are some applications or there are some services which fits into the category and definition of PaaS and SaaS as well. So you can argue whether it's not purely an infrastructure as a service model. There are some services which can also fall under PaaS and SaaS model as well. In terms of deployment model, again, it is not a private cloud environment. You can either use it as a public cloud deployment model where you're keeping everything on AWS, or you can use a hybrid model where you're keeping business critical applications on your on-prem environment and extending your dev and test or non-critical environment to AWS as well. In terms of use cases, so we have shown a quick demo by deploying Elastic Beanstalk application in one VPC and keeping our RDS instance in the same VPC. We showed you that it was, this application was working and but was able to connect to the RDS database instance. But the moment I deploy that application in a separate VPC, I was not able to connect. Reason being, by default, your VPC will not allow connectivity between each other. If you want to enable connectivity, there are some additional features that you want to implement. Maybe you want to, implement VPC pairing, or maybe you want to open your security group in such a way that they should be able to connect through the internet as well. All right, so thank you so much for your time, and I hope you have enjoyed your demo. And make sure that you check out Adureka as well. We have a very nice courses lined up for you in case if you want to continue your journey in AWS Cloud. Thank you so much, and I'll see you sometime later.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!
Cloud computing technology is spreading through IT sphere like a wildfire, and the top 3 providers of this cloud computing technology are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Choosing one amongst these top contenders is always a difficult task. Hey guys, I'm Archana from Edureka. Today, we'll be comparing these 3 powerful cloud platforms and see how they stack up against each other. So let's get started. Before we dig in, here's the quick intro. Amazon Web Services was established in year 2006. With 12 years of experience, it's the most popular player in the market. It offers a wide range of services across storage, compute, analytics, database, and many other fields. And like 6 to 7 years after AWS, Azure was launched by Microsoft. Though it's way younger compared to AWS, it has quickly built a reputation for itself in the market. And just like AWS, it offers a complete set of cloud services. And in the same year as Microsoft Azure, Google Cloud Platform was launched as well. The main reason of introducing GCP was to power their own services like YouTube and Google Search. But later on, they built enterprise cloud services as well. So you can say that Google Cloud Platform is still an evolving cloud computing platform. Now that we have an idea of foundation of these cloud providers, let's see where they stand in terms of market share. So here's the snippet of media interpretation. And you need to keep in mind that this information is with respect to first quarter of 2018. So Amazon Web Services delivered a 49% increase in sales, that is up to $5.44 billion. Then Microsoft Azure showed an increase of 17%, that's up to $7.9 billion. And Alphabet, Google's parent company, said that the division, which had GCP along with other services like Google Hardware and Google App Store, saw a revenue growth of 36%. That's up to $4.5 billion. And with all these stats, I can confidently say that Amazon Web Services is still in the lead and holds lion's share of market. So if I have to tell that in form of numbers, then Amazon holds 33%, that's almost about 1/3 of the total market. Then we have Microsoft, which holds about 13%, and finally Google, which holds about 6%. So to conclude, Amazon Web Services market share is bigger than its next 2 largest competitors combined together. Now that we know who leads the market, let's compare these cloud providers based on the services they offer. So first, let's consider compute services. The compute services offered by all these 3 cloud providers are equally powerful and yet unique in their own way. Amazon's primary compute service is EC2, which is Elastic Cloud Compute. As for the Microsoft, its primary compute service is known as virtual machine. Unlike Amazon's EC2, this virtual machine provides enhanced security, hybrid cloud capabilities, and integrated support for Microsoft software. Similar to Amazon's EC2 and Microsoft Azure's virtual machine, Google Cloud Platform offers Compute Engine. This Compute Engine offers automatic price discounts and it runs on an infrastructure that uses half the energy of typical data center. Well, that's about the primary compute services. Now let's take a look at additional compute services. I'm sure you know that all these cloud providers provide a combination of IaaS, PaaS, and SaaS services. But to say platform as a service is strong suit of Microsoft. So Microsoft Azure offers Azure Cloud Services using which you can easily deploy, scale, and run an application on cloud. Amazon's Elastic Beanstalk and Google's Google App Engine are similar to this Azure Cloud Services. Moving on, let's say you want to deploy a virtual private server without bothering about the underlying infrastructure, then Amazon Lightsail is the best option. Similar to Amazon Lightsail, Microsoft Azure offers Virtual Machine Engine, and Google Cloud Platform is yet to launch one such similar service. So all these cloud providers also support container platform, and they offer their own unique serverless computing services as well. To conclude, in terms of compute, all the three cloud providers offer equally powerful compute services. And yet, I can say that Google Cloud Platform is still lagging behind in some areas. Now, moving on to storage services, AWS offers a long list of storage services. To name some, it offers Simple Storage Service, Elastic Block Storage, and Elastic File Storage. Talking about database options, it offers Amazon Aurora, a high-performance relational database, Amazon RDS, and DynamoDB, managed NoSQL database. AWS also offers a cloud-based data warehouse, which we know as Amazon Redshift. Though it doesn't offer a backup service per se, it offers Amazon Glacier for long-term archival storage at very low rates. Then talking about Microsoft Azure, it offers way more storage services than compared to AWS. And just for the basic storage, it offers 4 options, and for database, it offers 6 to 5 options. And like AWS, it also offers cloud-based data warehouse, which we call Azure Data Warehouse. And unlike AWS, Microsoft offers an actual backup service called Azure Backup. In addition to this Azure Backup, it also offers site recovery and archival storage. A final contender, Google Cloud Platform, when compared to AWS and Microsoft Azure, offers less number of storage services. But the storage services like Cloud Spanner and Cloud Bigtable are quite popular. And it doesn't offer backup or any archival storage service. So in terms of storage, Amazon Web Services and Microsoft Azure stand neck to neck, whereas Google Cloud Platform has still a long way to catch up with Amazon and Azure. All these vendors are actively launching services aimed at cutting-edge technologies like serverless computing, machine learning, analytics, and IoT. If you're talking about Amazon Web Services, it offers Athena and QuickSight, using which you can get data insights. It also offers a machine learning service called SageMaker and Lex, using which you can build voice and text chatbots. And as for the IoT devices, it offers GreenGas IoT messaging app. And as for Microsoft, it has invested heavily in artificial intelligence, and it offers a machine learning service called ML Studio and a bot service called Azure Bot Service. In addition to this, it also offers cognitive services like Bing Search API, Text Analytics API, Computer Vision API, and many other services. And then Google. Google Cloud Platform is known for its analytical background. I'm sure you might have heard of a service called BigQuery that enables interactive analysis of massively large data sets. In addition to all this, it also offers IoT and serverless computing services, but still they are in beta version though. One of the major benefits of most cloud providers is their competitive pricing strategies. And all these 3 cloud providers follow pay-as-you-go model. It means you need to pay on the basis of usage. Wherein Amazon charges you on hourly basis, Microsoft Azure and Google Cloud Platform charge you on minute basis. And all these 3 cloud providers offer you on-demand pricing. That is the standard price you pay when you access their services. And then in addition to that, Amazon also offers you spot instances, reserved instances, and dedicated hosts where you are liable to get certain discounts based on some conditions. Then as for Azure, it offers special price for developers and something called Azure Hybrid Benefit. Suppose your organization runs some sort of Microsoft software on its own data center, then using this Azure Hybrid Benefit, you can get 40% discount depending on the type of Microsoft software you're using. And as for Google, it offers customer-friendly pricing compared to Azure and Amazon Web Services. It offers different type of discounts. To name some, you have sustained use discount. These type of discounts usually kick in automatically when you keep using same instance for most part of the month. Then you have preemptible instances, which is similar to Amazon Spot instances. And one more thing is that all these 3 cloud providers offer you long-term discounts. So if I have to conclude, Google Cloud Platform is almost always the lowest cost provider. Then you have Azure, the second least expensive. and its prices are usually close to Amazon's. And if you're looking for long-term discounts, as in Amazon Web Services is the best option. The big takeaway here is that you won't know which vendor is least expensive until you know what you need with these cloud providers. So now that we've looked at the features and pricing, let's see which one of these cloud providers are easy to get started with. So any guesses? Well, if you're guessing AWS, it's right. AWS provides this nice and easy page to start using their services. You can see that they break it down by platform you want to work on. So whether you're making an iOS app or writing in PHP, they provide you some sample code so that you can easily get started with. And as for Microsoft Azure and Google Cloud Platform, the segregation of services here is not that great when compared to AWS. That's mostly because they are less experienced, so you need some getting used to before you feel comfortable to start using their services. So there you go, guys. We've compared all these cloud providers based on their market share, features, pricing, and implementation. To conclude, Amazon Web Services still remains to be the most popular cloud provider, mostly because of the 7 years head start it has over its competitors. And AWS services are far more evolved and functionally rich when compared to other services. It has its weak points as well. It doesn't support hybrid cloud strategy. And its counterpart, Microsoft Azure, though it was launched several years after AWS, it's doing fairly well in the market. It has its firm foundation and is actively competing against Amazon Web Services. You shouldn't be surprised if it overtakes Amazon Web Services in near future. And then our final contender, Google Cloud Platform, when compared to AWS and Microsoft Azure, is still not that popular, but it's known for its pricing strategies and machine learning analytical tools it offers. But other than that, it has a long way to meet up Amazon Web Services and Azure. So guys, every cloud computing platform has its ups and downs, but the best cloud computing platform or the one that's suitable for you usually depends on what you expect from these cloud providers or what kind of services you need from these cloud providers. So I personally prefer AWS, but please do let us know if you disagree or agree with me. If you have any queries, you can post them in the comment section below. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
Today's session is going to be more of an introduction on AWS certification. So today's agenda will be, first of all, we have an introduction of what AWS is all about. So we'll have a look at AWS as a cloud and where it stands in the market today, followed by what are the job trends in AWS market, what are the different certifications which are available for the students to pursue in AWS. And we'll also give you some introduction on the different exams which are available and how they are structured, from certification perspective, and of course how you can prepare for those exams and what are different learning paths which are available for you if you want to pursue your career in AWS. So first of all, AWS is a cloud computing platform on which AWS offers its cloud services. These services operate from 16 geographical regions across the world. So one of these regions is dedicated for US government customers. So for any other users, only 15 regions are available. AWS is primarily an infrastructure as a service company, which means you can decide and you can pick and choose which infrastructure services you are interested in, and you can design your solution accordingly. Having said that, AWS is the #1 leader in cloud computing space, and here AWS has been the leader in this space from quite some time. I think ever since its inception, it has been leading in this category. And the first thing that I would like you to have a look at is the Gartner report. So Gartner is again, Gartner is something which most of the IT industry folks, they do follow this report in case if they want to see which particular company is doing good in a specific environment. I have a question from Hemant, that is AWS not platform as a service as well? Well, if we look at infrastructure as a service model, I mean primarily AWS is infrastructure as a service model, but for platform as a service model, there are some services which can definitely fit into the definition of platform as a service. The first service that comes to my mind is AWS Elastic Beanstalk. So Elastic Beanstalk is a computing services in which developers need not worry about any of the infrastructure underneath it. They can just go select the runtime environment they're interested in. That runtime environment can be Node, Node.js, Java, PHP, Go, Docker, etc. and they can just upload their application code, and all the underlying infrastructure will be deployed automatically by AWS. So that fits the definition of platform as a service model. But if we take AWS as a whole, it is infrastructure as a service company, not platform as a service company, even though they do have some services which will fit into this definition. All right. So having said that, let's take a look at the demand of AWS's market. So if we compare with all other cloud providers that are available in the market, and that there are quite a few which are operating in this particular capacity, AWS owns 31% share of the complete cloud computing market today. Now 31% is being owned by one single company, which is AWS, and 69% is what is split across all other companies like Microsoft, companies like IBM, HP, companies like Dell, Rackspace, Facebook, Google. So there are lots and lots of companies which are operating in the in the cloud computing space. But right now 31% market share is owned by AWS. Microsoft is something which is definitely catching up with AWS, but in terms of execution capacity and in terms of visions, AWS is still far ahead than Microsoft. But having said that, AWS and Microsoft Azure are the only two cloud providers which are sitting in the top corner of your Gartner metrics. In terms of server capacity, all competitors combined, AWS owns 6 times the capacity of all servers which are running in all the competitors combined. So all your competitors are running, let's say, 1 million servers computed today. Just for an example, your AWS is running 6 million server capacity across the world. So this is a huge achievement, and that shows you the breadth of AWS reach and execution capabilities, and how much how many companies are trusting AWS to move their workload onto the cloud. So why do we need AWS certifications? So first and foremost, it helps in the screening process, because whenever and we all know that how the screening process works in the IT industry. So primarily they will not call you directly. Most of the time it is the consultants which are sitting in between who will screen the profiles, and once they screen the profile, then only they will share the shortlisted profiles with the different companies who are posting their jobs. So most of the consultants, of course, they are non-technical in nature, so they don't know what you have worked for, what your experience is. All they will do is they will shortlist your profiles based on some of the keywords that that the other companies may have told them. So those keywords in terms of AWS will be some of the certification, like whether you are an AWS certified solution architect or a SysOp or a developer or a professional, and so on. So if you are certified on AWS, it definitely helps in the screening process. So you definitely clear the first step. And most importantly, if someone is seeing an AWS certification logo on your profile, it gives a recognition that you are well aware of the subject, right? And also, this certification is relatively new in the market, so there are not many professionals out there who have got this AWS certification. So I mean, by clearing this certification, you are already marking yourself ahead in the pack. Most of the AWS partner networks, like all other OEMs, AWS also has some kind of stringent requirements in terms of being an AWS partner. So one of those requirements is the number of AWS certified professionals that you hire in a company. So most of the APN partners or AWS partner networks, they will always try to hire resources who are certified with AWS. So if you are certified, your resume definitely holds a much importance to them as well. And as I said, there is an acute shortage of AWS certified professionals in cloud industry. So if you are pursuing your career in AWS, you are definitely going ahead in the market, and it will definitely help you in your job prospects as well as in your career progression as well. Okay, Hemant has a question that is it only recognized by APNs? Well, not really. I mean, APNs is just one part of it. So APN are the AWS partner networks who are delivering their services on AWS. So those partner networks may be, implementing services on AWS cloud, but that does not mean only the APN partners will recognize the certification. Even if you are working in, let's say, software as a service company, who are, and most of the, by the way, Fortune 500 companies have already said that they're looking forward to moving their infrastructure on the cloud. Even if they're not APN partner, they would still want some of the AWS certified professionals in their ranks. They can use their knowledge in making their decision on what products or what features or what services they would want to move onto the AWS as well. So it is not only recognized by APNs, but overall in the market, it holds a lot of value. All right, so let's have a look at some of the certifications which are available to us. So first of all, it's a two-tier certification process, and in fact, they have introduced some more specialty certification in this year as well. But if I talk about the levels, the first level is an associate level, and the second level is a professional level. In terms of associates, there are three types of certifications which are available: AWS Certified Solution Architect Associate, AWS Certified Developer Associate, and AWS Certified SysOp Administrator Associate. Now, in case if you want to go to another level, the second level is a professional level, and there are two certifications in professional level: AWS Certified Solution Architect Professional and AWS Certified DevOps Professional. Now, for professional, there is a prerequisite that you need to hold a associate level certification before you can appear for your professional level certification. And you can take any associate level certification to go to a professional level. Even you can clear AWS Certified Solution Architect and then appear for your DevOps professional as well. But in terms of learning paths and in terms of the curriculum which is closely aligned, it is always recommended to either do a Certified Developer Associate or a SysOp Associate in case if you want to go for DevOps professional. But for Solution Architect Professional, Solution Architect Associate is the prerequisite that you should be clearing. In terms of a very brief introduction of what each certification will include. So for Solution Architect Associate, anyone who wants to appear for that certification or the job role for a Solution Architect, they will have to design and deploy highly available, cost-efficient, and fault-tolerant systems on AWS. So the concept is very much, how you can design applications. So in terms of designing, the key things that they are looking forward is how you can design highly available, which means even if you always have some kind of active scenarios, so you are doing some kind of load balancing, you are doing some kind of auto scaling in this, how you can design cost efficient application or environment. Again, cost efficient is something that whole of the IT industry is buzz with. They all want to optimize their cost. They don't want to implement services in such a manner that it is increasing their IT revenue. The only reason why they're looking forward to moving their workload on the cloud is to reduce their overall TCO of IT budget. So that can only happen if you can design cost efficient environment or cost efficient applications while deploying on AWS. And the last part is fault tolerant. Of course, cost is just one part of it. You don't want to reduce the cost and bring in downtime as well. All the IT companies, they always are very skeptical of, even if they want to move their infra services on cloud at a lesser cost, they don't want their services, application or websites to go down. And that can only happen if you're designing fault tolerant system, that even if there is some kind of failure that happens in the environment, there should be a process which will automatically bring the services up, or it shouldn't bring any downtime at all as well. So that's the job of a solution architect, to make sure that they're designing solution in such a manner that it is highly available, it is fault tolerant, and at the same time it is still cost efficient compared to traditional IT infrastructure as well. In terms of developer associate, so as the name specified, it is primarily focused for developers. So AWS developer has to design and maintain applications on AWS infrastructure. So again, just to set the expectations right, it is not about development. It is not about which programming languages you can design applications in PHP, you can design applications in Node.js, you can design applications in Java or whatever. But the purpose of this particular exam is to, whichever language that you are using to deploy your application, you should know how you can use those languages to deploy your applications on AWS infrastructure. So the focus is more on the different software development kits which are available with the AWS, and how you can make use of those development kits to deploy your solutions on AWS infrastructure. The last exam on associate is your SysOps one. So SysOps primarily is, again, as the name specified, the prime function of a SysOp associate is to maintain the system. So person will be responsible for provisioning, operating and maintaining highly available fault-tolerant system on AWS infrastructure. So again, they have nothing to do with designing, but the solution has already been designed, but they need to provision that system, they need to operate that system, and they need to make sure that the system is maintaining its high availability and fault-tolerant architecture as it was decided earlier. The next level, which is AWS, professional level, solution architect professional and DevOps professional. For solution architect professional, it is a continuation of your solution architect certification. So most of the curriculum is the same as solution architect associate as well. But this is more for experienced solution architects who are able to design and deploy more complex architecture. In terms of DevOps professional, they focus more on continuous delivery and designing and maintaining tools to automate the operational processes. In terms of continuous delivery, what they're trying to convey over here is that how much automation you can bring into your development environment. That automation can be in terms of how you want to deploy your code, how you want to, for example, integrate your deployment with GitHub repositories and so on. Right, so question from Hemant again, that SysOps could be more of a system administrator. Well, SysOps associate would be more of system administrator. You're absolutely right. But if we are talking about DevOps professional, it is a combination of your developer associate and SysOps associate. So it's not only about how to maintaining your environment, but also to deploy your environment for deploying your applications and deploying your code. But if we're talking about SysOps associate level, yes, it is more often system admin environment than anything else. But keep in mind, because typically when we say system administrator is normally associated with tasks like that they are managing the servers, or maybe they're managing the storage environment only. Right, so these are the only 2 or 3 tasks that normally a system administrator is responsible for. But when it comes to AWS, because it is infrastructure as a service, a system administrator will be responsible for all the facets of your infrastructure. So that includes your server infrastructure, that includes your storage infrastructure, that may include your networking, your security, that may include your databases as well. I'm not saying that for that you need to know all of these things in depth. But since most of these technologies are made as a service for you, so for example, there is a database as a service, there is a security groups which are kind of very easy to deploy with in terms of increasing your security. So you need to be aware of all those services. And a system administrator in terms of AWS will be responsible for maintaining the complete environment, not just your servers, not just your storage, and not just your databases as well. So it includes and increase the breadth of operations for a typical system administrator. All right. So in terms of certification, again for associate, you can choose which certification you want depending upon what experience level you are in the industry. But in terms of difficulty, that's my personal opinion, but I think developer is the easiest one, followed by SysOps, and the solution architect is the toughest of all these 3 certifications as well. All right, so then another question from Hemant, that let's say auto scaling is there and it has been deployed by architect. What will a SysOps guy do? All right, so a practical scenario, first of all, it depends on the company to company whether a solution architect is deploying the solution or a SysOps guy is deploying the solution. Because as I said, typically as definition says, your solution architect is only responsible for designing the solution. He will just maybe create an architect diagram which says that you need to deploy, for example, your web tier as an auto scaling one. Maybe your SysOps guy is the one who will deploy it, or your solution architect is a guy who will deploy it. But in either cases, your SysOps guy is the one who will be responsible for making sure that it is operating as desired. So for example, SysOps guy will be the one who will be monitoring your CloudWatch alarms, so that in case any of those servers are going down, whether auto scaling is operating properly, whether it is launching any new instances. At the same time, he also will be responsible for seeing the CloudWatch alarms, that why any particular instance is going down, and if there is anything to do with the configuration, if there is anything to do with the with the resources, So he need to make sure that it is operating as desired, just not just that the solution architect has deployed. He needs to make sure. So there may be a case that maybe the instance size that you have selected is not sufficient for the environment that you have provisioned for. So SysOp guy probably will be the one who will tell that every time the instance is going down, this is going down because of XYZ reason. That reason can be that your memory is failing or your CPU is failing, etc. And the recommended action is to increase the instance size. So they will work in a very cohesive manner so that ultimately the application that you're deploying on your environment is working as desired. All right, so in terms of your exams, Solution Architect Associate will be a multiple choice and multiple answer questions. Most of the questions are going to be scenario based question. When I say scenario based question, they will not ask you to do any deployment task, so there is no console that you will get access to, and they will not ask you to deploy anything as such, but they will definitely test your knowledge on what are the different services which are there in which are part of the curriculum of AWS Solution Architect, and whether you know how to deploy those services, whether you know how those services operate. The exam is going to last for 80 minutes, and trust me, this 80 minutes is just enough. I mean, from my personal experience, when I did my exam, there was around 14 to 15 questions that I have marked for review, and when I finished my exam, I could not review all my questions. So I was only able to review probably 6 or 7 questions, and then all the rest of the questions I had to skip because the time was over. The reason is because most of the questions are scenario based questions. The length of the question is pretty big. You may take almost a minute to read through those questions and understand those questions, and then you will have to read through the response sections as well. So make sure that you practice reading as much as possible because it's really important that you read it once and understand what is being said. Exams are available in different language, including English, Japanese, Chinese, etc. There is a practice exam which is available. It's hard, just USD $20. I think there are 20 or 25 odd questions which are there in a practice exam. A lot of students ask me that the practice exam is how important it is for appearing in a practice exam and how closely it is associated with the real exam. In terms of questions, I don't think so that you will get even a single question from the practice exam directly. But what practice exam does is it prepares you mentally on what to expect in an exam. So things like how the question will be structured, what type of questions they will be. So maybe there will be a couple of scenario based questions, couple of one-liner questions, couple of true false questions, couple of multiple choice versus multiple answer questions. So it will prepare you mentally on what to expect in an exam. But again, never compare your practice exam directly with your real exam. The question in real exam will be much tougher than the practice exam, and there will not be a single question that will appear from practice exam directly into the exam as well. Exam registration fees is $150. Again, compared to other certifications which are available in the market, I think it's very reasonably priced. And in case if you want to get ahead in your career, I think this is a very minor investment that you can do on yourself, and definitely the returns are much higher if you clear those exams as well. Okay, so if you have a look at the exam blueprint of AWS Solution Architect Associate level, the exam is distributed in 4 different categories in terms of the questions. So as you can see, 60% of the questions are based on designing part. Because it's a solution architect, you're mostly responsible for designing. So designing highly available, cost efficient, fault tolerant and scalable systems. So 60% of the questions will test your knowledge on whether you know how to design highly available or cost efficient or fault tolerant or scalable, or all of this combined together as well. There are only 10% question on implementation and deployment, and normally these are very simple. There are around 20% question on security. So security is again another aspect which is really important. So there are some white papers which are recommended for everyone to go through before preparing for the exam. But whether you're working as a SysOp architect or a solution architect or a professional, I think security is something that everyone should be aware of. Then there are 10% questions which are dedicated to troubleshooting parts. So if things do not go as planned, so what are the troubleshooting steps that you should follow? So again, in terms of complexity of the questions, I think troubleshooting and implementation are probably going to be the simplest of all. Security, in case it's mostly theoretical in nature, but if you read the white papers thoroughly, that again those 20% are I will say they are like low-hanging fruits. So 60% of the exam, which is focused on designing part, is where the whole focus should be. All right. So if we are talking about designing part, what all topics it will comprise? Definitely, if you are designing highly available or fault-tolerant system, so you need to monitor the environment as well. That in case if things do not go as planned, so unless you know that the things have not gone as planned, unless you are monitoring your environment, you will not know whether anything has failed or not. So monitoring and logging is definitely important. So there are services like CloudVoid, there are services like CloudTrail, which you can use to monitor and log your environment as well. Hybrid IT architecture, again things like direct connect, storage gateway, VPC. So VPC is is a networking feature where you can create your own virtual private cloud within a public cloud. So again, very, very important both from security perspective as well as for creating hybrid IT architectures. So hybrid in the sense because most of the companies will not move all of their workload onto AWS immediately. They would typically start with non-critical applications like development and test environment, and they will move those environments first on cloud. And once they are comfortable working on cloud environment, then only they will start talking about moving their production applications on AWS. So in all probability, all the companies who are moving their workload on the cloud, they will always start their environment with hybrid IT architecture, and then probably they can go 60, 70 or even 100% on cloud as well. So it is very important for a solution architect to understand how to create those hybrid IT architectures and how to connect or extend your data center environment to AWS as well. You should also know about the architectural trade-off decisions. So trade-off decision means, it is very easy to say that I want to design a highly available and fault-tolerant and scalable system, but everything comes at a cost. So you need to be very careful of the, budget constraints as well. And based on those budget constraints, you should design your solution. So this is what a trade-off decision means, that you may have to let go certain things or certain features for for cost part or for fault tolerant part or for scalable part as well. Elasticity and scalability, again, it is a public cloud. So most of the services are, there is no constraint in terms of capacities which are available. So you can launch, for example, 1 instance, 2 instances or 1,000 instances at one go. So there is no capacity constraint as such. And you can scale your infrastructure either up or down depending upon your environment and your requirement as well. Then developing to clients specifications, including pricing and cost. So again, as I said, the very first reasons why most of the companies want to move to a cloud environment is to cut down their IT budget. So you need to understand their pricing and cost constraints before you start designing your solution. There are some best practices for AWS architecture. So you need to know those best practices, how you can plan and design infrastructure, and how you can design your cloud services. So these are the questions or topics which will feature very heavily in the 60% of the exam. In terms of implementation and deployment, so as I said, these are like low-hanging fruits. So things like how you can configure an AMI, how you can identify appropriate techniques or methods using various services, how you can configure your services to support any of the compliance requirements. So those compliance requirements may be your data compliance requirement, that whether your data can move or stay in one region, or whether you can move your data from one region to another or not, how you can launch your services in AWS environment, and how you can configure IAM and what are the best practices for IAM. IAM is your identity and access management services. So anyone from Windows background, for example, will appreciate this, because this is kind of a directory environment that was followed in AWS in Windows environment as well. So things like you can configure your users, you can configure your roles, and you can configure policies as well. You can either apply permissions or policies directly at user level, or you can apply it at group level as well. Then how you can operate and extend your service management in hybrid IT environment. So again, service management means what tools you are using currently, whether you can use those tools to monitor and manage your environment within AWS. So primarily, they will test you on services like EC2, which is your server instances, services like S3, your simple storage service, Elastic Beanstalk, CloudFormation, OpsWorks, VPC, and IAM. As I said, these questions are going to be pretty standard if you have enrolled in a specific course, and if you have practiced most of your demonstrations, then these are really, really simple to answer. Security, again, very important topic. 20% of the exam questions will be on security. So primarily you need to recognize and implement security practices for optimum cloud deployment and maintenance. So there will be services like CloudTrail, CloudWatch, services like IAM, Trusted Advisor, VPC, and most importantly, your encryption solution as well. So there are a couple of services on AWS which supports encryption. So you need to know which services are those and what type of encryption they support. There are some, so first and foremost, you need to understand one thing very clearly, that security is not only the responsibility of AWS. If anyone is deploying their solutions or their workload on AWS, security is something which is a shared responsibility model between AWS and the client as well. So, if you're deploying your environment on AWS, you cannot say that if your environment is hacked, that AWS is the only one who is responsible for it. No, all the features are there, all the services are there. You as a user need to decide how secure you want your environment to be and what all services you want to deploy and what all services you want to pay for as far as security is concerned. For example, there are security groups which are acting as a virtual firewall. Those security groups are available for you, but ultimately you as a customer is responsible for configuring those security groups, that which ports you want to open, from which particular IP addresses you want to allow your traffic, and so on. Tomorrow, if you keep your security groups open and then say that my environment has been hacked, so AWS is not responsible for it because they have given you security group. You need to deploy those security groups. All right, so in terms of fault tolerance, so I think disaster recovery is something which is again a very important topic, something everyone should understand. So there will maybe content that includes services like storage gateway, import export, Route 53, and validation of data recovery methods. So as a solution architect, there are some key terms that you need to understand. What is the RTO and RPO? RTO is your recovery time objective and RPO is your recovery point objective, and how you can design your AWS environment in such a way to meet your client's RTO and RPO requirements. There are some volumes, there are multiple storage options available within AWS environment as well. So storage option like EBS volumes, which is your elastic block storage devices, services like S3, which is object-based storage, services like EFS, which is elastic file storage, services like storage gateway, which helps you to extend your storage environment from data center to the cloud, and services like import and export in case if you want to move your bulk storage from cloud to your environment or from your environment to cloud as well. So you need to understand each of these services and how you can make use of these services to create a DR environment as well. Troubleshooting, as I said, there are very general questions. In case if things are not working, what are the steps or processes you should follow to troubleshoot it? It only comprises 10% of the questions, and again, just like your implementation, they are like low-hanging fruits, so you should easily be able to crack those questions. Typically, it is always recommended that you have at least 1 or more years of hands-on experience designing highly available, cost-efficient, fault-tolerant, and scalable systems on AWS. Again, this is a recommendation, not a prerequisite. So even if you do not have any experience on AWS and you have enrolled in certain courses, you can still clear those exams. But as a recommendation, it is always recommended that you have at least a year of experience on AWS before you appear for at least for architect level exam. You need to have in-depth knowledge of at least 1 high-level programming languages. Again, a recommendation, not a requirement. Ability to identify and define your requirements for AWS-based applications. Experience with deploying hybrid systems with on-prem and AWS components. And capability to provide best practices for building secure and reliable applications on AWS environment. So again, keep in mind, these are just the recommendations, not the prerequisite or not the requirements. All right, question from Heyman, that do companies hire if I don't have any experience but I have earned the certification? Well, the companies may hire depending upon the budget, because there are all sorts of companies out there. There are MNCs and there are startups as well. So startups are definitely very budget conscious. So imagine, of course, if you're going in an MNC, they would know, and they have a huge budget, they will definitely want a guy who has a certification, and as well as they do also have the experience as well. But most of the startups, they take guys on the face value as well. So if you have earned the certifications, they know that you have got some skills on this and you can learn very quickly as well. So they can hire as well. I'm not saying that MNCs will not hire at all. Again, it totally depends on the job profile, the budget that they have, and what kind of guy they're looking for. So it's a catch-22 situation. So either you get experience first and then do certification, or you get certification first and then get experience. In my view, if anyone is a fresher who do not have any experience at all, if they clear this certification, at least they will have something to write on their profile, to write on their CVs, and they have something to look forward to. So in my view, if you are a fresher and you are already enrolling yourself into AWS certification and clearing those certifications, you have already chosen the path that you want for your career. So I think it's always recommended to do that, rather than companies and jobs define which career path you want to take. All right. So in terms of percentaging, which are matching your job positions, so as you can see, it is very, time has progressed. The demand has really picked up for solution architect. There are around 30% companies who are looking for hiring solution architect in 2016 onward, and this will go higher as we speak, because there are new technologies which are coming in the market, IoT, big data, and all of these services are going to need cloud environment to prosper as well. So all these three services combined together will probably be something that you should look forward till 2020 as well. So definitely something to look forward to. All right, so let's talk about the AWS developer certification now. Again, multiple choice question, 80 minutes to complete, available in multiple languages, practice exam $20 and $150 of the exam fee. In terms of blueprint, so as I said, developer is probably going to be the simplest of all. So fundamentals is 10%, designing and developing is 40%, deployment 30%, and debugging 20%. Fundamentals, you need to identify and recognize your cloud architecture considerations, such as what are the different components that you're using and how are you designing your solutions on AWS. So basically how to design your cloud services, very simple concepts of databases, planning and designing, some of the services like S3 and how to use different storage classes within S3, how to use simple workflow services to create a loosely coupled environment, how you can use messaging for notification, elasticity and scalability, how you can use services like DynamoDB, Beanstalk, and CloudFormation for designing highly available environment. And primarily the three services like DynamoDB, Elastic, Beanstalk, and CloudFormation, they are more focused for developers who do not know anything about the infrastructure. So we are taking concept is creating infrastructure as a code. So rather than deploying those infrastructure manually, you can just write those scripts, and those scripts should be able to deploy your infrastructure. Similarly, architectural trade-off decisions. So whether you want to deploy an RDS versus installing your own database on an EC2 instance. So all those things you need to be aware of going into your developer associate exam. In terms of designing and developing, so again, you need to be aware of different techniques that you can use to deploy a cloud solution. Now, those techniques of deploying a cloud solution mean, rather than using console, how you can use your scripting languages, how you can use your programming languages, or how you can use your software development kits to talk to your AWS services by virtue of your APIs, and how you can deploy your solutions on AWS through these API calls as well. The content in terms of deployment and security, again, what are the best practices for deploying a secure environment on AWS? So cloud security best practices. Again, there is a white paper for it. If you go through this white paper, these 30% of the questions are very, very easy to crack. You need to recognize and implement secure procedures for optimum cloud deployment and maintenance. So as long as you are following best practices written in AWS tutorials or AWS guides, these things will be very, very, these questions will be very, very simple to crack. As I said, there is a white paper dedicated for it. All of those 30% of your questions will appear directly from that white paper. Lastly, you need to demonstrate your ability to implement the right architecture for development environment, testing environment, and staging environment. So again, the requirement of development and testing and staging will be kind of similar but still different. But all these three environments combined together will be definitely very, very different than your production environment. So you need to know which particular environment would need what type of services and how highly available or scalable infrastructure needs to be for different types of environment. In terms of security, as I said, that security is a shared responsibility model. So I think one thing that I missed is your solution architect associate, your developer associate, and your SysOps associate. I think 40 to 60% of the course content is absolutely same. So you will see things which are common across all these three exams put together as well. So for example, things like shared security responsibility model, things like IAM, things like VPC, things like AWS security infrastructure, things like storage services, all these things will focus on almost all each of these three exams. You need to be aware of CIA and AAA model. So CIA is your confidentiality, integrity, and availability, and AAA is your authentication, authorization, and you need to be aware of ingress versus egress filtering and which AWS services and features can fit into those models. VPC again is something which will feature very heavily in each of these three exams. So VPC is that important that I can very safely go ahead and say that in case if you are not comfortable with VPC, do not even bother sitting in the exam, because you will not be able to clear it if your concepts of VPC is not clear. So VPC is very, very important irrespective of which exam you are appearing into. Lastly, 20% of the exam are debugging. So these are nothing but your troubleshooting exam. But of course, in terms of developer, they are more into debugging. So you need to be aware of how to read API calls, how to read the log files, and how to make sense of those log files, that where a particular a process has stopped or where the error has come, and how to debug those errors and make changes into your environment. So these are really general troubleshooting. Anyone who from development background should very easily relate to it. Again, the recommendation is for 1 or more years of hands-on experience designing and maintaining your AWS applications, in-depth knowledge of at least one high-level programming languages, understanding of core services, uses and basic architecture and best practices, and you need to be proficient in designing, developing, and deploying cloud-based solution using AWS. You need to have experience with developing and maintaining applications written for services like S3, DynamoDB, SQS, SNS, SWS, Beanstalk, and CloudFormation. CloudFormation is basically nothing but a scripting engine, so you can create your own template configurations on CloudFormation. So you can just write your infrastructure in JSON script, and your JSON script will be able to deploy infrastructure for you. Beanstalk is one service which fits the definition of platform as a service, in which you can just select your runtime environment and it will automatically deploy the underlying infrastructure into it. So you just need to select whether you are deploying a Java application, Node.js application, etc., and then upload your code, and Beanstalk will deploy all the underlying resources for you. SWS is actually SWF, which is simple workflow service, which you can use to create workflows on AWS as well. These workflows can also include human element as well. In fact, this is one service which AWS or which Amazon is using into their own Amazon.com environment for shipping products which are ordered from Amazon.com from their warehouses as well. SNS is a simple notification service. Something that you can use with multiple services to notify of any event. That notification can be in the form of SMS, can be in the form of emails, can be in the form of HTTP or HTTPS endpoints as well. SQS is your simple queue services. So again, in case if you want to develop an application, a loosely coupled or a distributed or a decoupled application environment, you can make use of SQS queues, so that one process is writing to one queue and the other process is reading from those queues. All different processes will not have any interdependencies on each other. Then you have DynamoDB, which is a NoSQL database. Again, in case if you are working with semi-structured or unstructured data and you want to store it in a database, then DynamoDB is the database that will fit for your need. S3 is an object-based storage, so you can upload any objects that you want on S3. So just a quick fact, in fact, Dropbox is using AWS for their environment. So mostly if you have a Dropbox account, you know that you get, I think, 2 or 3 GB of data capacity free on Dropbox. You're not getting that capacity on Dropbox. Dropbox was using S3 services at the backend. So when they are assigning you a free capacity, they are giving you an S3 bucket which is dedicated for you, and on that bucket you can upload any of your code or any of your object. It can be a file, JPG, it can be a Word document, PDF, anything that you want. Again, the job trends. So as you can see, again, there are 18 to 20% of upward trend for jobs for AWS developer, which will continue to pick up in the coming years, depending upon what applications or what application languages that you are proficient in. Next, we want to talk about is SysOps administrator exam. So again, multiple choice, multiple answer, 80 minutes, available in multiple languages. Practice exam $20, registration fee of $150. Now, this is more focused on maintaining the environment rather than deploying. So as you can see, 15% is dedicated on monitoring and metrics. So monitoring and metrics basically means how you can monitor different AWS services. So there are metrics available for you for each of these services. You can use those metrics to monitor your environment. High availability, how you can make sure that your environment is running in a high available way. Analysis, how you can analyze different log files which are available for you. And deployment and provisioning. So as I said, SysOp may be responsible for deployment as well. So there are only 15% questions dedicated for this. Again, very simple to answer. Data management, what type of different storage services you are using on AWS Cloud and how you can manage your data in terms of using different storage classes or storage tiers and different storage services which are available to you. Security, again, the white paper that I keep on referring to. So there is a shared responsibility model. So in case if you go through that white paper, security is something which you would easily crack. Networking, primarily talking about VPC and how you can deploy your environment on a VPC. In terms of monitoring and metrics, you need to demonstrate your ability to monitor availability and performance requirements, and you should be able to monitor and manage billing and cost optimization processes as well. Now keep in mind, when we are saying monitoring and managing billing, we are not saying that you are directly responsible for or you will have permissions to look at the billing management as well. But what we are saying is that using your CloudWatch monitoring metrics, you can also create billing alerts that whenever your environment is going to bill you more than, let's say, X dollars, then you should create an alert, and that alert should go to the relevant stakeholders who are responsible for making sure that you are sticking to your budget. Okay, so as a SysOp administrator, you should have the ability, you should have the knowledge on how to create and manage those billing alerts as well. High scalability, how you can implement scalable and elastic solutions on AWS based on different scenarios. Ensure you have a level of fault tolerance based on business need. So again, fault tolerance, elasticity, scalability, high availability, they all come at a cost. So you need to understand, what is the requirement and how much you want to pay for that particular requirement. Analysis, how you can optimize your environment to ensure maximum performance, so that you will only be able to do once you are monitoring it and when you are analyzing it. How you can identify performance bottlenecks and how you can implement those remedies, and in case if there are any potential issues on a given application deployment, how you can identify those issues and how you can suggest changes to be made in your environment as well. Deployment and provisioning, again, something very, very easy as far as your exam is concerned. You need to demonstrate the ability to build environment to conform with the design, and you need to demonstrate the ability to provision your cloud resources and manage implementation automation as well. Data management, how you can enforce compliance requirement, how you can create backup from different services, and how you can manage your backup and DR environment. So primarily it will include services like S3, services like storage gateway, services like Glacier. So you need to be aware of how you can create backups and how you can store those backups in a cost efficient manner, and how you need to make sure that you are meeting your compliance requirement as far as your data is concerned, whether you are moving your data from one environment to another or one region to another, or whether you want to keep your data within a single region as well, and how you can meet compliance requirement of high availability as well. So assuming one of the availability zone goes down, whether your data will be still available or not. Security, again, the shared responsibility model. You need to be able to implement and manage security policies. You need to demonstrate the ability to prepare for security assessment and ensure your data integrity and access controls when using your AWS platform. Networking, again, you need to demonstrate your ability to implement networking features. So things like VPC, things like security group, things like network access list, and demonstrate your ability to implement connectivity features. So there are different ways you can connect your data center environment to AWS. Those ways includes a VPN or a NAT device, or those includes your direct connect connectivity as well. So you need to be aware of all those services as well. Again, required skills or recommendations: 1 or more years of experience, capability to provide AWS operations and deployment guidance and best practices through the life cycle of a project, experience in provisioning, operating, and maintaining systems on AWS, and your ability to identify and gather requirements to define a solution which needs to be built and operated on AWS. In terms of job trends, again, SysOps is something which is kind of picking up from 2016 onwards and will continue to pick up as more and more companies are moving their workload onto the cloud. All right, so I'm going to take a moment. Any questions on any of the topics that we have covered till now? All right, one question from Hemant. I'm sorry, I may have missed it. How can you decide between RDS and a standalone database on EC2? Well, you can decide, and point or the question that you need to keep in mind is, first of all, what is an RDS service and what are the benefits of RDS service over an EC2 service? So the benefits is, first and foremost, it's a managed services from AWS. You can deploy your database directly on AWS. You don't need to worry about deploying any infrastructure. You don't need to deploy any server. You don't need to purchase or procure any license or configure any license. You can most of the database management task or the DBA task or the database operation tasks are handled directly by AWS. So for example, if you use RDS service, so there is a feature called automated backups. So RDS will automatically take backups of your databases every, depending on the backup schedule that you have set. So you can keep your automated backup for maximum of 35 days. And your RDS service can also implement minor upgrades or updates as well for you. And in case if you have selected highly available databases in terms of multi-AZ environment, then it will also automatically replicate your storage from your primary to standby databases as well. Now cut to, if you want to deploy everything on your own, so first you will have to deploy a server. On that server, you will have to download your database software. You need to implement your database's licenses. And after doing all things, you need to be responsible for maintaining your databases in terms of when you want to create backups. You will have to take backups on your own. In case if you want to design highly available environment, then you need to also create multiple database instances. And then you also need to make sure that you are replicating between these environments as well. The only positive point that you get while deploying your database on a standalone EC2 instance is that you get root level access to the underlying server, and you can probably have access to the underlying physical underlying instance as well. So in case if you want to run, let's say, any particular scripts, or you want to keep your database to backups for more than 35 days as well. But again, there's a trade-off decisions again you have to make, whether you want to do all these things environment on your own, or whether you want AWS to manage all of these things for you. So that's how you can decide whether you want a standalone environment versus your, as a service environment. Any other question? All right, another question: how is a solution architect, associate, and a professional different? Well, primarily the difference is between the number of years of experience that you have working in the industry, because a professional is something who will have more experience and they will design more complex solution. In fact, we have the slides coming up, so we will understand a little bit more on this professional level certification as well. And just to give you a perspective, I think right now there are only around 5,000 or 6,000 AWS architect professionals which are available in the market. So across the globe. So you can imagine how tough this certification is and what value it currently holds. All right, so let's continue with our slides in that case, and we'll understand a little bit more on our professional level certifications as well. All right, your solution architect professional is again going to be multiple choice questions. This time the exam is 170 minutes, so this approximately 3 hours of an exam, available in multiple languages. Practice exam $40 and exam registration fee is $300. Blueprint, you will see it is a combination of your solution architects, your SysOps, and your developer associate all combined together. So you need to be aware of high availability and business continuity, costing, deployment management, networking design, data storage, security, scalability and elasticity, cloud migration, and hybrid architectures as well. In terms of high availability and business continuity, you need to demonstrate your ability to architect an appropriate level of availability based on your requirements, ability to implement self-healing capacity. So self-healing capabilities means, let's say if one of the server fails, how you can ensure that if the server fails, automatically a new server instance has been installed, has been launched as well. You need to demonstrate ability to implement DR requirement based on the RPO and RTO timelines. You need to determine appropriate use of multiple availability zones versus multi-region architecture. So there are some services which you can operate outside of a region, which you can take outside of a region as well, and there are some services which can only stay within a single region. So you need to be aware of those services and the breadth of those services as well, in terms of whether you can span those services across availability zones or across regions as well. And then again, you need to be aware of high availability versus fault tolerance. In terms of costing, you need to apply the appropriate account and billing setup options based on the scenario. Ability to compare and contrast the cost implications of different architectures. So as I said, there is no perfect architecture. So there may be a reference architectures available for you. But even if you want to design a perfect architecture, you need to keep in mind the cost scenario as well. So based on the budget that you have, that budget will decide what kind of environment you want, what kind of availability, fault tolerance, or scalability you want to implement or deploy in your environment. So there's always going to be trade-off between these different aspects of your infrastructure. You need to demonstrate the ability to make architectural changes that minimize and optimize your infra costs. So this section is primarily focused on cost optimization. So you need to be aware of what cost optimization techniques are available and what are the ways by which you can keep your application running but still cut down on the cost part. Then you have network design for complex large-scale operations. So you need to demonstrate the ability to design and implement networking features. So things like VPC, things like direct connect, VPN gateway, NAT instances, NAT gateway, etc. Ability to design and implement your connectivity features. So again, your direct connect, whether you are deploying a 1 gig connection, 10 gig connection, or a sub 1 gig connection. So there are multiple ways by which you can connect your AWS environment to your data center. So you need to be aware of all those features and how those features, or which of these features or which of these options will fit into your requirements. For storage and complex large-scale deployment, ability to make architectural trade-off decision involving storage option. So this will test your knowledge on services like S3. There are different tiers of storage tiers like S3 standard storage versus infrequent access versus RRS versus AWS Glacier service. You need to demonstrate your ability to make architectural trade-off decision involving database options as well. So again, RDS versus RDS in a multi-AZ deployment, RDS with read replicas, RDS on a database on a standby EC2 instance as well. And lastly, ability to implement the most appropriate data storage architecture. So which particular data storage services you're using. There are different services like EBS, EFS, S3, Glacier, EFS storage gateway services, import export services. So which particular service fits into which use case. And lastly, you need to be aware of use of synchronous versus asynchronous replication. So synchronous is the moment you are writing any changes or making any changes to your primary database, that change will be immediately replicated to your secondary database. In terms of asynchronous, the change may happen eventually, so it may take some time. So you need to be aware of which services or which particular features support synchronous replication versus asynchronous replication as well. In terms of security, so again, your shared responsibility model. So design information security management system and compliance controls. Design protection of data at rest controls. So we are talking about different encryption options which are available. So there are encryption options available for data at rest, data in transit, whether you want to encrypt your data at client side, whether you want to encrypt your data at server side. So server side is your AWS side. And if you are implementing encryption at your AWS side, which type of encryption you want, whether you want encryption at rest or encryption in transit. Design identity and access management control. So you need to be aware of IAM services and what are the different options or features available within IAM. Design security control with shared responsibility model and global infrastructure, and protection of data in flight and network parameter control. So data in flight means your data in transit. Network perimeter controls include services like security group, network access list, services like there is a web application firewall services available with CloudFront as well. So these are the different services that you will be tested on in the security part of AWS Architect Professional. In terms of scalability and elasticity, you need to demonstrate ability to implement the most appropriate data storage scaling architecture. So now your storage is either growing or it is shrinking. So how you want to, which type of solution you will deploy that your storage can increase or decrease based on the requirement that you have. Ability to design a loosely coupled system. So they will test your knowledge on services like SQS, SNS, SWF, ability to implement the most appropriate front-end scaling architecture. So again, things like auto scaling, things like multi-AZ RDS, trade-off between vertical versus horizontal scaling. So vertical scaling is when you are increasing the size of the server or specification of the server. So maybe from going from 2 CPU to 4 CPU or 8 CPU type. Horizontal scaling is when you are just increasing the number of instances. So same specification, but rather than running 2 instances, now you're running 3 or 4. Demonstrate ability to implement the most appropriate middle tier scaling architecture. And you have cloud migration and hybrid architecture, where you need to plan and execute for application migration. You want to migrate your application from your data center to AWS. So what are the steps that you need to be aware of? And you need to demonstrate the ability to design hybrid cloud architectures as well. So there are some prerequisites. That prerequisite is to have certified solution architect associate level exam cleared before you appear for professional level. Again, recommendation is 2 or more years of hands-on experience, and you need to have ability to evaluate your cloud application requirement and make your recommendations for implementation, deployment, and provisioning application on AWS as well. You need to have capabilities to provide best practices guidance on architecture design across multiple application projects or enterprise as well. In terms of job trends, so 10% upward trend of 2016. As I said, this is a relatively new certification, and there are only 5,000 or 6,000 people available in the market today across the globe who hold this certification. So you will see this trend going up very quickly. All right, the last certification that I want to talk about is your DevOps professional. Similar to your solution architect, you have 170 minutes to complete the exam, $300 exam registration fees, multiple choice question, and exam is available in English language only. Now, this will have more focus on development side of things, or deploying your cloud applications. So things like continuous delivery and process automation, how you can deploy your code onto the AWS environment, how you can continuously deploy or roll your updates on AWS, monitoring, metrics and logging, security governance and validation, and high availability and elasticity. All right, so in terms of continuous delivery and process automation, they will test your knowledge on application deployment management strategy, such as rolling deployments. Rolling deployment means that continuously you're coming up with new versions of the application, or you're coming up with new updates, and how you want to ensure that all those updates are automatically deployed on the fleet of EC2 instances that you have used to deploy your application. Or A/B testing as well. A/B means that you have deployed a new version of your application, but rather than testing it out on all the server instances, you only want to test it on a number of instances, so that in case of any issue, not your whole environment is not getting impacted, just a certain test environment is getting impacted. Then you have version control, testing, build tools, and bootstrapping. So all those things you need to be aware of, how you can control, enable version controlling, how you can test and build your tools, and how you can bootstrap those environments, so that using bootstrap scripts, so that whenever your new instances are getting launched, it automatically deploy which may be available locally, or which may be available from GitHub repositories as well. Then you have to implement and manage CD processes, your continuous delivery processes using AWS services. So there are some services like code deploy, code pipeline, etc. that you need to be aware of. Then you need to develop and manage scripts and tools to automate your operational tasks, such as SDKs, CLI, and APIs. Demonstrate an understanding of infra configuration and automation, how you can automate most of the whole point of being a DevOps guy is that you're not doing the same task over and over again. Any task, any steps that you are repeating again and again, that should be automated by the way of scripts, by the way of some of the services which are available to us. And lastly, you need to demonstrate an understanding of application lifecycle management. So what are the different phases of your application, how you can, once your developers are, developing an application, whether you want to test it, you need to build it, you need to again test it, then you need to deploy it, then again, there is a feedback loop and so on. In terms of monitoring, so you need to monitor and manage billing and cost optimization process, monitor availability, performance, use metrics to drive the scalability and health of infra and applications. So basically, you can use your CloudWatch alarms in continuation with your Elastic Load Balancer and auto scaling, so that whenever your certain resources are going or crossing a certain threshold, you can automatically launch new services or new instances as well to take over the load. Then you have to analyze data collected from monitoring system to discern utilization pattern. So things like CloudTrail, or you can also use logs in CloudWatch monitoring to analyze what is going on in your environment. Leverage the SDK, CLI, and APIs for monitoring and logging, and manage the lifecycle of application and infra logs. And lastly, aggregate and analyze infra, OS, and application log files. So as I said, that you can aggregate and put all these files in a CloudWatch monitoring system, so that you can analyze graphically that what are the different types of log files, what are the different events which are happening in those log files as well. Security, governance, and validation. Implement and manage automated network security and auditing. Apply the appropriate AWS account and billing setup options based on your requirements. And implement and manage your AWS resource auditing and validation. So whenever you see auditing, there is a service called CloudTrail for this. So you can use CloudTrail to audit, take log of all the API calls which are being made to any of the AWS services, which you can use for auditing and validation purposes. How you can implement and manage your IAM and security controls. Use AWS services to implement your IT governance policy. So you can use, for example, AWS config policies to make sure that your configuration environment is following your configuration management compliance as well. Implement and manage your protection for in-flight and at rest, for data in-flight and data at rest. So we are talking about the encryptions here. So what type of encryption you want to deploy, and whether you want to deploy encryption client side or server side. And you can also implement, automate, and validate your cost controls for AWS resources. So again, by virtue of using your billing alerts, you can manage, even kill some of the resources in case if you are crossing certain threshold as far as your billing is concerned. In terms of high availability and elasticity, you need to determine appropriate use of multi-AZ versus multi-region architecture. So which services can span across availability zone versus which services can span across across regions as well. How you can implement self-healing application architectures. Implement the most appropriate middle tier scaling architecture. Implement the most appropriate data storage scaling architecture, the most appropriate front-end scaling architecture. So typically any application you deploy, they are typically deployed in 3 tiers. So you have a front-end tier, which is normally called a web tier. You have a middle tier, which is normally called application tier, and then you have the third tier, which is your data storage tier, or you can also call it as database tier as well. So front-end tier is what which will receive traffic from the internet. Application tier is the one which will receive traffic from your front-end tier, and application tier is the one which will talk to your database tier. So you normally keep your database tier the most secure because it includes your customer data as well. So how you can implement auto scaling architecture in all those 3 tiers, that's something that you need to be aware of. And lastly, you need to determine an understanding of vertical versus horizontal scaling concepts as well. All right, so in terms of required skill, for DevOps professional, you need to be either developer associate or a SysOps associate. You need to have 2 or more years of experience in provisioning, operating, and managing your AWS environment. And you need to be experienced in developing code in at least 1 programming language, experience in automation and testing via scripting and programming, and understanding of agile and other development processes and methodologies as well. Lastly, job trend. I think this is one certification which is picking up the most in terms of job requirements. So DevOps professional, as you can see, it is already touching 30% in year 2016 and will continue to grow over and over. If I take a wild guess, this graph should point at least 50% by 2017, by the end of 2017, and it may continue to go further as well, because we want to bring as much automation as possible in our infrastructure environment. The new concept is infrastructure as a code. So rather than deploying infrastructure standalone, all of this infrastructure needs to be managed via your code, and that is only possible in case if you have DevOps guy in your environment who understand both the infrastructure as well as they have development background as well. All right, so in case if you want to register for any of those exams, so you can go to aws.amazon.com/certification/ depending on which certification you want to choose, and you can schedule your exam directly from that site. You will also need to have a web assessor account in case if you do not have already. So you can create a web assessor account. Once your web assessor account is created, you will have to log in Criterion environment. So once your web assessor account is ready, you can log into your environment and then schedule a test. In case if you want to learn all of this, there are different courses which are available for you. First thing first, you need a structured training which shall cover exactly what is required in the exam. So depending upon which exam you want to focus on, we have already given you introduction of each and every exam and what are the different components which will be covered on those exams. And depending upon your background, you need to choose which certification exam you are interested in. There are not many companies out there who will provide you AWS training, and their curriculum will somewhat be aligned like introduction and getting started with AWS, followed by EC2, storage services, VPC, direct connect, database, ELB, autoscaling, application services, Route 53, management control, OpsWorks, mock test, and route clearing session. So this is your Edureka course for solution architect. So as you can see that in Edureka, we are covering each and every service which is written in the exam blueprint of a particular exam. So this is for solution architect. So this is a very, very structured training in terms of exactly what you're getting. Exactly which services will be part of the training, because if we talk about AWS services right now, I think there are around 70 to 75 services out there on the AWS console, but you don't need to learn all of those services at once. In fact, there's no single resource who can work on all the services. But for solution architect exam, there are certain services which are already written in the exam blueprint, and all those services are being covered in the learning path that we have on Edureka as well. All right, so session in a minute. So we started off with what is AWS, why do you need an AWS certification? Then we moved on to cover different AWS certifications which are available with a detailed view of what all services you need to know and what all different experience levels you need to be on to clear a certain certification. Followed by what are the ways that you can register for your AWS exam. And lastly, we covered the learning path which is available for you in case if you're interested to get into your AWS certification track. So that will be all. Any questions from anyone on any of the topics that we have covered? All right, so we have one question. We have question from Hemant that can you share your experience as in how did you prepare for your exam? In terms of preparation for the exam, so what I did is, again, I also followed the training. Definitely I took the training. I also have some experience working as a solution architect in one of the MNCs as well. So that experience has definitely come in handy. I have around 14 years of experience in the IT industry as well. So that definitely came in handy as well. So I'm already aware of things like, disaster recovery, things like, things like high availability, fault tolerance, and all of this. But for you, the best way to prepare is, since AWS is going to cover so many aspects of infrastructure, so you will be learning a little bit about databases, a little bit about security, a little bit about networking, a lot about system operations, a lot about storage. So I think the best way is to enroll into some kind of training. So as I said, Edureka has a very, very good course in terms of it's a very well structured course directly dedicated for you for a certain exam, so solution architect exam. Once you cover those sessions, I'm a certified AWS architect and I'm a trainer with Edureka as well. So if you, for example, if you enroll in my course, so first we'll start off with the theoretical part. Then there will be a lot of theory plus demonstrations which will go hand in hand. So if you are working on EC2 services, so I'll explain you what EC2 service is, followed by the demonstration of that EC2 service. So there will be a lot of labs that you will be doing during that course. Once you complete all that training, there will be some further study that you need to do, not a lot of, but there will be some further study. So I'll be giving you some reference material that you need to go through. All those, there is no proprietary reference material that I'll be sharing. All that reference material is available on AWS website. I will just point you to which documents that you need to read through. Once you go through the documents and the reference material that I point you to, and you cover the training part and you do all your assignments that I gave you for the lab part, you will be easily be able to clear those certifications. All right. In terms of hands-on, so as I said, there is no fixed limit in terms of whether you need to have hands-on experience for 1 year or 2 years. In fact, when I cleared AWS certification, I only had a hands-on experience of hardly a 1 month or 2 months, because as I said, I was working as a solution architect in one of the companies. So I was definitely not a hands-on guy. But when I started preparing for AWS, I definitely used the free tier account of AWS and did all this on my own. So definitely, any lab that I have covered, I would practice those labs myself on my AWS account so that I know exactly what is going on. So if you practice those labs, which is covered on your training session as well, your hands-on experience part, you should be comfortable with hands-on experience part. You don't need a practical live experience before you can get into the certification as well. All right, any other question? Okay, I've got no thank you for this. Vineet has also not pointed any question. All right, so if there are no more questions, I will be ending this webinar now. Make sure that you provide your feedback for the session as well. And hopefully I'll see you in one of the sessions on Edureka for one of this certification track. And happy learning, and make sure that you enroll in Edureka for if you're interested in pursuing your career in AWS Architect, AWS Cloud.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!